Okay, so it is Monday. The video is number 128, as you can see in the bottom of the screen. And let's look, not at the agenda screen. What are we looking at? What am I looking for? Actually, right here, I guess, is what I want to look at. I want to verify everything's correct. So it is Monday. The video number is 128. The project is AAC 2020, which stands for Atomic Alice C Code 2020. 2020 is the year it was established. The sub-project, or the sub-library within the project I'm working on, is called PAINT5D. And then the subtask of that is PHEXDUM, which stands for PNG Hex Dumper. And so we're working on PNG Hex Dumper in order to get assets into the game. So with that kind of said, with that established, and that I know that all of the IDs for what I'm working on are correct, I can start to program without worrying that the indexing of this video will be improper, because it really sucks when I'm coding and then 20 minutes in, 30 minutes in, I realize I have to scrap the entire video because the labels in the video are incorrect and therefore they can't go into my archives. Okay, so yesterday, or no, Monday, not Monday, Friday maybe, we were working on this, and we need to wrap this up, and some of the features I thought were going to be necessary aren't going to be necessary. Some of the features that I didn't even put in are going to be necessary. So we need a way to, so let's say we have this thing here, right? We need a way to, you know, include the naked array. Naked array.txt, whatever. And the naked array.txt will be like this stuff right here. And then we also need to be able to, right here, include naked array, naked array, something like this. Naked array, we could do like naked array.txt.top, and this could be a define for a length. Now the problem with that is we don't know what the define value is, right? And so we're gonna lose some ability to look at this code and understand exactly what it does. So we might want something more like this. Or we might want, in here, we just have to do some wonky indentation like this, and say, you know, include naked array .txt.len, right? And that'll just be a file that, the file just contains a hard-coded value for how long this is in terms of how many entries are there, right? And then, if we need to, the problem with that is, the problem with this approach is that we can't use any defines. So if we have this at file scope, how are we going to, well, we can't do something like this. We can't do define include, right? That's not a thing we can do. So we can't do define, we can't say define, well, I don't think we can. Let's, hey, let's see if we can do something like that. I don't think we can, but let's, try it out. So, basically, if we want to say define include, I don't think that's a thing. Because we can say define len include, len.txt, right? So, I don't think that's possible. But let's just see. Let's not make any assumptions. Now, the thing is, even if this works, it could be a thing that only works on GCC, right? So it could be like something where, yeah, sure, it works, but it's not going to work for me everywhere. So let's say, you know, printf len, and then %d \n, and then we'll do len right here. And we'll save this, and we'll just put this in like an R&D folder, right? So we'll go in the AutoHotkey folder. And we'll just, shortcuts, SC files, CXXX, because we don't really care what version of C it is. It's in research and development, because I don't really know what I'm doing here. And we're just going to say, I'm going to call it define include, right? And I don't think this will work, but why don't we just try it? So define, we'll call it din for define include.c11. Then we'll make a new file called, this is going to be our build file. And that's not going to work. Okay, let's HKMF for hackish makefile, C11 for the language, and then mini, because it's going to be a mini makefile. And so here's our little makefile. We don't need this macro. This macro is just going to be clutter. All of these look good. For right here, we're going to put din.c11. We're going to change the indentation, fix that up a bit. And we'll save that in here. So din.sh. And we'll open this up in Explorer, and we'll just give it a shot, right? Well, actually, we need one more thing, right? So we had that, it was like, what do we call it? We called it, not here, we called it include len.txt. So over here, we're going to have to do a file, and we're going to call it len.txt. So len.txt, and then within len.txt, we're going to put like a number, and we could say 42 because we want to be hipsters. And then, yeah, let's just give that a shot and see what happens. Now, we might want to do /len.txt. That would be the more proper way to include that. So let's just give that a run and see if that actually works. I doubt it. Well, let's see what happens. Like, I'm kind of... stray... Yeah. So, it doesn't like that. Now, we could try another thing, right? We could do... we could try a line continuation character, right? And then try that. I have no clue if that would work. But, you know, we should experiment a little bit and see what can we actually get away with here. And I don't think any of this is going to be possible. Yeah, stray blah 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 in the program. Yeah, like this is not going to... Yeah, it's not going to fly. So, yeah. This does not work. So, we could do something like this, right? Where we have the length here is just a number. But if we want to, I'm going to put this in my notes. Define include define. Yeah, so that's not going to work. So we have to think of another way we can do this. So do we really want... Is it absolutely necessary that we have the ability to create a define as well as kind of do this? And I think that, yeah, actually it is, because... Well... Let's think about the simplest thing we can do. The simplest thing we can do is this. And then instead of having a define, we could just say, we could say, you know, int32 my data len, right, equals, and then we could do the same thing here, right? Now, it's not a compile time constant, right? But the idea here is that we can easily follow what this is, right? We can say, oh, this length is in here, right? And it goes to this array here, right? And that's going to, I think, be the best way to do this. So then we could say, like, you know, this part here is, you know, naked array.txt. So, contents of, right? So then down here is the contents of naked array.txt. I think that is actually how we wanna roll with this. So it's not. The solution with creating define files means that we would have to create a, we would have to create a naked array.txt dash like top dot len dot define. We'd have to create something like this, right? We'd have to create a we would have to create a define and undefine file if we wanted to use defines. And then not only that, but then the other problem is we wouldn't know exactly what the variable names were named, right? Because the variable names, the defines would be tucked into these files. If we do it this way, sure, we can't have a define, but we can still have this as a compile time constant, right? Because we can have the file here, and then we can have the variable here as well with whatever number needs to be in there. And there's going to be less indirection, and we don't need, instead of 2 files, we only need 1 file to get this going. So I think that don't create define and undef files, because too much indirection in source code when doing this way. So yeah, I think this is the way we want to do it. Now the thing is, I have these nice little notes. We should put these notes somewhere. So let's look. We got the notes file here. So let's just put this in like design notes, right? Let's just say, or actually, hold on. Did I? Yeah, so let's just make a design notes section. And then we'll just kind of paste what we've been working on into the design notes section. So, so example usage of naked array hex dump. That would be a section. That would be a main section. Let's kind of indent some stuff a little bit more. So all this stuff here needs to be indented a little bit. And then, so right, we embed the hex dump into the source code like so, like such. And right, so this is our hex dump, right? And we're going to include this naked array.txt right here. Then also outputted by the command is going to be like this length file. So, we could say, command So what are we going to run on the command line? So in order to get this working, we're going to do something like I'm going to say like /PHEXDUM.exe, and we're going to say, you know, image.png. Or actually, not image.png. How do we do this? PNG to naked array. And then we're going to say png.image.png or img.png. And then we can supply an output file. Right, so that's the input file. The output file is going to be... here, let's do some line continuation characters here. Because what we want to do here is we want to say... image.png, and then the output is going to be, I think it would be easier to do like image dot image.png.txt maybe, and then like image.png.length, right? Like that might be a way to do it. Now we already kind of named it this, so we should probably just keep this kind of thing here, right? If we really want to like make this a good example, like yes, it is nice that it's very terse like this, but we should kind of do it the same way so that we know what we're doing. So, right, so alright, so this is how we want to give this a roll, right? So this is the command, input image, right? This is the naked array text, right? Naked array text, and this is this is the number of elements within the naked array, right? So that's kind of like what we want to do here. And we just want to create these nice little notes so that we know what the heck the goal is. We also might want to make a don't do this section. I don't know how we want to label it, but maybe we want to label it like this. And I know it is kind of weird to have like a sections where I document what I'm not going to do, but it's just a thing where I want to document explicitly what I do as well as what I don't do, if that makes sense, right? So this right here is a no-no. No. Just because if we create a define and an undef file, we've kind of experimented syntactically with how that would work. And by just sketching this out, we realized that this is kind of the better solution. The syntax is a little bit awkward because the way we got to use these includes will require us to indent as such, or else this won't work. But clunky and awkward is better than hard to follow. Okay, so now that we know kind of like what we're going for, what the goal is here, we need to fix up some of the code that we already have. And we need to decide that some of the functions that we wanted to write are we're just not going to write them. Like, the fastest code to write is the code that you don't write, right? Like, so somewhere in here, we have like we have some commands for like PNG to whatever the heck. Let's kind of find that in here. So in the data file, we have like a lookup table for what commands you can type and what they route to. And the naked to PNG commands are what we're using, but the PNG to C99, we're actually not going to do any of those. So so anything that says C99 text in it, right, these commands right here, we're just not going to implement them And so we need to find them in the code and wrap around enumeration. Oh, this is enumeration. No wonder. Okay, so this is... So we got a, so this is CMD for command, right? So we have some things for C99 text. So these things we don't want to implement. So we're not going to implement them, but we're going to keep them stubbed in, how they're already stubbed in. And so instead of calling it a to-do, I'm going to call it, I'm going to change the indentation here a bit. And we're going to call it a won't. I'm going to call it a won't do. Okay. So PNG to C99. This is going to be a won't do, meaning I am just not going to do it, right? And let's put a note in here. And the time is 21. Let's do 23 because we want to keep with the conspiracies. The fastest code is the code you do not write. Right? So basically, we are just not going to do this. And we could also make a note of, like, what do I mean by won't do, right? So we could kind of, we could hashtag that out and do, like, hashtag won't do, or actually at won't do. Or at underscore won't do. At won't do, right? Okay. And let's kind of make a note of that. So let's go into our AAC 2020 doc folder. I didn't think that would work, but I'm going to make a note of that in my shortcuts. AAC 2020 doc folder. AAC 2020 doc folder. AAC 2020 doc folder. I'm going to make a note of that. So AAC 2020 folder, I do have something, a shortcut for that, but then in the doc folder, I don't have a shortcut for this, so I'm going to paste that. So next time I want to go directly into documentation, I can. And then also edit AAC 2020 H file. Edit AAC 2020 hashtags. Edit AAC 2020 doc H. Edit so this file here, the underscore H, making a shortcut for that to be able to edit later. So over here, I'm gonna just put this on here where you can see it, but right here I'm just gonna say, you know, edit underscore H, edit, or underscore H edit, or underscore H underscore, right? And that is a pretty vague shortcut, and as long as I don't work on too many code projects, that won't be a problem. It will be a problem if I work on many different projects that have similar structures, then that becomes a problem. But yeah, so at this at won't do, we can just make a note of, like, what do I mean by won't do? And we can say, well, it means, it's like a, so at won't do, like a to-do, but means that you intend to never do right? And We can also make a note of this, that, right, the fastest code is the code we don't write. We can make a note of this, so we're at video 128 and 25, 12. Well, let's do 13, because unlucky numbers. Okay. So now that that's stubbed in there, we know that we have another function that we want to also stub in as won't do. So it's going to be pretty much this function except the inverse. So C99 text to PNG file, right? The inverse of that. And we see that it looks like we were about to core function work, huh? We're gonna say, not executing. We're not gonna do this. And we've kind of stubbed in this a little bit more. This to-do message won't do the PNG file array, the PNG file str length. Yeah, so we're just going to stub this in as won't do. And do we just want to keep it like that and make it not trigger an error? Yeah, sure, why not? So this array here, have you ever decide to implement this function? Right. So if I ever decide to implement this, that I need to get rid of these two lines right here. Right? So I can make a note of, even though I'm not going to implement this, I can still kind of leave the code in a nice state where if I ever do decide to implement this, I've been nice enough to myself to where I know where I need to go to get this working, right? So if I ever decide to implement this function, I need to get rid of these two lines, right? Because these are just kind of placeholders here. At won't do, right? And we can make a note that it's at vid IID 0128, and the time is 28 or 29. Yeah. So we can make a note that this is a won't do. And now the next step is there's like a few kinks where, like, if I type a command that is not valid, it just kind of blows up in my face, if I remember correctly. So we need to go full file path to clipboard, or put it over here, run that build script. Oh, I guess this is actually my thing. But we need to go in here and just be like, we just need to give it a run and type out the commands that we've decided not to do. So first of all, we need to actually compile it. So compile it, make sure that the won't do's that we kind of shoved in there. So lazy unit test ran. So this is my lazy unit test. So I decided that if we compile, if we run the function without any arguments, it'll run the unit test. And that makes it nice because then it just works with the build script. The build script doesn't supply any arguments when it builds the code. And the build script tries to run the code right after it's built. So now that we have this, we're going to go PHEXDUM.s8.exe, and we're going to go run, we're going to try C99 to naked array, and whatever .txt. It doesn't exist, but the thing is that we should just, that shouldn't really matter. Well, it could create some problems for us. Let's try an actual file that exists for now. So let's say 001.txt. PHEXDUM command not found. So that's actually, oh, well, that's because it's that's not actually a valid command. So so let's we're gonna add some robustness here. So I get that, yeah, we've kind of like we got these invalid commands, and I'm going to we could actually put that in here, right? We could say, since this is an invalid command thing, well, the idea here was that we just wanted to recognize that it was invalid command. Actually, no, let's just do it. Let's, so right, so these are explicitly invalid commands. They don't actually exist because C99 and naked array, they're both text things, and we don't actually have any conversion functions for those. I just wrote that. I just made some stuff up for a command and made up some BS. So let's see what happens if we kind of like... So now that we know it's invalid command, what happens? Command not found. Yeah, that kind of helps, but the thing is... Yeah, we didn't use that array... that's not really what this array is for, right? This array is really not for this kind of stuff here. So let's not do that. Let's put this back. And if we really want something like that, we can get some type of feature like that, but it is going to take some more work. So so we could say if we really wanted to, we could copy this, paste this, and commands that are bogus. We could make a little section for commands that are bogus. Right. And we can keep the same format, but it's naked text to C99 text, right? So it's like C99 text is what we call the stuff. So right here, C99 text. And then we could name this, like, we could name this, you know, to C99 text. And this is 04, so we can name this 05. anywhere we see PNG here, we could say C99, right? Naked text to C99. Naked text to C99 text, so C99 text. And then naked C2, C99. Right, so now we have kind of these different ways of writing an invalid command, but we explicitly know that it is an invalid command. We can get rid of this null terminator, right? And we can just say null terminated list. Null terminated list. And then we can do the inverse of this, right? So we can cut and paste this. And instead of naked text, it's going to be C99 text converted to naked text. And these are also invalid commands, so we're just going to invert all of this, right? So we're going to take the, well, first let's kind of like color all this, because I'm thinking that maybe if we kind of like color code this, we can see what we're doing a little bit better. And we're also looking at the wrong thing here. How do we do that? So right here, let's color all this. And this is no longer 05, this is going to be 06. And we're just going to say this C99. We're going to move it over here. Then we're going to take this and we're going to cut this. And we're going to paste it over here, right? So just a lot of cut and pasting to shuffle this around. And so this naked text thing here, we're going to take it, we're going to paste it over here, then we're going to take the C99 text and paste it over here. And then the C99, we're going to paste this C99 over here. We're going to take the naked part, and we're going to paste it over here. Okay, cool. So now everything is kind of shuffled around. And we have these sets of commands that are explicitly invalid commands. And we have two of these new lists, and we need to account for them, right? So right here, we got to say, you know, we should say, I believe we go from the top to the bottom, so let's put them right here. So so these are explicitly invalid commands. Commands I'm not going to ever write. Commands I actually care about. Right, so there's a lot of bloat in the code I wrote because it was kind of an explorative process where I'm like, oh, I should make this command, that command, that command. And then as I kind of figured things out, I kind of realized that these are only two commands I need. And these commands would be nice to have, but they're not immediately things that I need, so I don't think I'm ever going to write these, but they're already stubbed in, so I'll keep them stubbed in. Explicitly invalid commands are just like, in case we ever type these commands, we want to make sure that we note that, hey, these are explicitly invalid commands that aren't really good for anything. 1, 2, 3, 4. Now, I don't know why I did, like, this 4 + 1 thing here. But yeah, now it would be a 6 + 1. Right, because we have... like, we have this. Like, in terms of checksums, I have no clue why I would have done this. But for whatever reason, I have 6, and this is our +1. I don't know why I decided to notate it like that, but okay, if that's the way we're going to notate it. And so for this now, needs to have some other things kind of stubbed in place. So we have... PNG file to naked text, naked text to PNG file. So we are actually going to stub in these functions, right? Synonyms. And I am questioning whether or not this is a good idea, or if I should just let go of this, but we're already doing it, so let's not worry about it too much. Command enumerations. We got C99 text to PNG file. PNG file to C99 text. So we're just going to copy this, and we're going to take these ones. 1, 2, 3, 4, 5, and 6. Oh, so that's why we have that +1, right? Because the zeroth is like an invalid index. So this is the only command the only commands I care about. These are bogus commands. We got to keep on doing that for a lot of stuff, right? So we're going to take this, and we're going to keep on doing the same thing. So for this, we're just going to take these two things right here, and we're going to paste those in here. So we have the commands, we have the enumerations, and we have the synonym arrays. Then we're going to go look at this kind of code here. And the way we did this is kind of like how we want to handle it, right? Won't do, and we just kind of write it like this, right? So I'm going to steal this, because I think that's the... And then I'm just gonna like make a section. We're just gonna call this section like bogus commands I won't support, and it's gonna be like in here. We're gonna take this because it looks like a good template for how we want to write this function code, and then we got to look at this and say to C99 text. So we want to take naked text to C99 text. So anywhere where we see this thing here, we're just going to change this. Right? We're going to change this. Naked text to C99 text. Nil string 10:07 a.m., I guess. So this is going to be string naked text, or yeah, relative string naked text. Now, I don't know why this is .png file when... Oh, because text to text, so that makes sense. It's already marked as won't do. This looks wrong here. Because we say .bin.txt equals any text. There's an any text type. And then .any text equals this. Oh, the PNG file is being set to empty. Oh, because we're using kind of like a union type pattern. Okay, I see what's going on here. That is actually correct. And this won't do will be naked text converted to that won't do. Bogus function. I'm just going to mark it as a bogus function, I guess. Yeah, I'll just mark it as a bogus function. Put the function name right there. So that looks like a good stub for that. And then we'll do the same thing for the inverse, right? So for the inverse command for this, the inverse, we're going to take, we're going to look for naked text, and we're going to look for C99 text, and we're just going to swap everything, right? So this will get swapped, so we'll take this, paste it over here, then we'll cut this out right here, and we'll paste it right in there. And this will become C99 text, so C99 text. These right here. Now, how the heck did we get these? Oh, because it's the pointer. Okay, yeah, so that's, yeah, so these can be naked text. And this will also be naked text. And this will be C99 text. And this will be naked text. Okay. So, now that we've kind of stubbed in these bogus functions, let's put some breakpoints here. And we actually have to look at, well, how do we execute these, right? So we go through all the synonyms somehow. And these synonyms are located in this synonyms table. So somewhere in this function code, we're looping through all these synonyms, right? This table of synonyms. And if we look here, we can see that we're kind of building these tables again as like redundancy. PNG file to C99 text, PNG file to C99 text, C99 text to PNG file to naked text to PNG file. So we need, if we're to rebuild all of these correctly, then we need to insert two more. So these two right here, we're going to insert at the top, and we're going to insert these commands up here at the top, right here, 1 and 2, right? And then 1, 2, right, is going to be 3, 4, 5, and 6. And then we need to do the same thing for these enumerations. So let's go find those enumerations, which are going to be, like, way up here, right? So we're creating, like, a table of these enumerations, and they need to be in the exact same order as well. So we got the PNG file to naked text to PNG file to C99 text. C99 text to PNG file. So we need to take these two and copy them and then override them with these. So these are the enumerations. One, 2, 3, 4, 5, and 6. And we could also kind of group these, right? So there's some obvious grouping here, right? And we could kind of try to group these. Now the problem is if we group them like this, you can see how that can kind of make things a little bit difficult because of well, you can kind of just see how trying to add some more spaces there just makes things kind of more difficult on us, right? So we might want to just put those back. We know we have a very specific order for these clusters. Table of enumerations. And then, I don't know. Nothing found is 0, invalid enumeration, invalid command. Okay. And so, right here, we want to do the same thing. We want to take this C99 text to... So these two correspond to 3 and 4 right now. So 3 and 4. PNG file to C99 text, PNG to C99 text. Yeah, these things. We're going to take these two, we're going to copy them, we're going to paste them right here. And we're going to override these two with the new definitions up here. So these are CMD. So CMD right here, these CMDs. We're going to take these. We're going to copy them, and we're going to paste them right here. And then we're going to change the numbers, so 2 to 3, 4, 5, and 6. And let's, so 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. So that looks good. However, 0, 1, 2, 3, 4, we should have 5 and 6 to keep up with the pattern. So 5 and 6, and 5 and 6, and 5 and 6, I think, right? Table of enumeration. Yeah, these enumerations should all be equal to each other, right? So this is just double checking this table of enumerations here. Okay, so what else are we missing here? Well, we've declared that there are 7 elements in here, and right now we have 5. We need to change this 5 to 7, right? So these things need to be 7, right? Because the table of synonyms now has 7 things in it. And so is there any other place where like hard coding this, right? So at one point we had 4 commands, right? Because we had 1, 2, 3, 4 commands. And now we added 2 more, right? So we added 4 commands. So we see that this number here looks kind of like it's hard-coded there. We got to change that. So let's make this a little bit more robust, like a little bit less let's make it a little bit more resistant to change, right? So define number of commands. And right now that is going to be changed to 6. Right? Define number of commands. Then we're going to go down to the bottom of this function here, and we're going to undef that, right? So we're going to just undef number of commands. And then also what we're going to do is define NOC as number of commands. And the reason why we're going to do this is just so that we have kind of a more shorthand variable for this, right? Because number of commands is kind of bulky. So number of commands could also be referenced by NOC in this area of code. And then instead of like this 7, we can do NOC plus 1. Now, we're running out of some space here, so... So, table of functions... Right, sure. So, number of commands, 6 plus 1, right, we get 7, right? So, we got 6 plus 1, right? 6 plus 1, 6 plus 1, that all makes sense. So then here, the number of commands was originally 4, but we changed that to number of commands. Looks like we have enough room. We have just enough room to use the long-handed version. So if we have enough room to use the long-handed version, we should. And number of commands is 6, not 7, because we want to include the actual valid commands, or the commands we recognize, and then the 0th is for commands we don't recognize. So that's why greater than or equal to 0, we end up on that 0th slot. And looking through this, it looks like we probably kind of like did that correctly. So let's just try to see if we can compile this, see if we kind of forgot anything. And if we forgot anything, we'll try to fix it. So if you look there really quick up here, we got this 6 plus 1, conflicting types. And this is in the data file. So let's go in the data file really quick and see what the heck we screwed up. So we got 5 here, but then we have number of whatever the hex. So we swapped some things around here. So we got to look at this. This is also, all these things here are potential mistakes. So no, I don't know what that was. But let's go up here. We can see synonym numbers 11, right? So so all these arrays should have like 11 things in them, right? So this number of elements here should have 11. Yeah, so we got 11 things in here. 11 plus 1 because of this. So, sin has a 6 plus 1. One, 2, 3, 4, 5, 6 plus 1. That actually makes sense. Now, where are we referencing this? Why is it, like, thinking... Oh, yeah, because 6 plus 1 here... 6 plus 1, right, that's a 7. And right here, it's not correct, right? Because we changed this. We added those 2 things in it to get 7. So we just need to change that, right? So we could actually... We could use 5, or we could use 6 plus 1. Or sorry, 6 plus 1. We could use 7. Let's just do 6 plus 1. Let's just write it like that. Okay, let's give that a shot. So we got an assertion that failed. Command enumeration between 0 and... Yeah, so 2, 3, 7, 6. So I see exactly why that's failing. Let's go Control G to 2, 3, and then I'm gonna have to take a quick break. 7, 6. So the command enumeration, yeah, so we need to change this and make sure that we can look up everything correct. So I'm going to be right back. I'm going to take a break. Okay, so let's reset these. Okay, so we can see where this assertion failed, and whenever we have an assertion fail, we want to be a little bit more robust about why that failed. So basically, we added 2 other commands, and now this lookup table is no longer correct. And the way we made this lookup table is it needs to match kind of like exactly the order in which we put those other functions in. So we need to say, if right, if it if it's in that range, it's good, and else error probably forgot to add new functions. Right, so if we get this error, you probably forgot to add new functions to the jump table JMP. Then we can say @vid IID 128, and the time is 1:18:00, right? We can keep the timestamp there. And this orange coloring is really annoying me, so let's get rid of that. But yeah, we can actually add, since this assertion just failed us, it makes sense to add something a little bit more robust so that next time this error happens, we get a little bit more information. So if we run this now, I'm expecting to still see a problem, but probably forgot to add new functions, right? So from here, that's a little bit more informative of what's going on. And we see C99 text to PNG file to C99 text, C99 text to PNG file, and this last thing on the tail is the functions we actually care about. The new functions we added are at the top here, right? So we want to keep that same ordering. If we don't add in the exact same order, we're probably going to encounter some serious problems. 1, 2, 3, 4, 5, and 6. And so these are going to be, these 2 functions here are going to be the new functions we kind of stubbed in here. And we can see that they're called naked text to C99 text and C99 text to naked text. So we can just take this, and since we're very uniform in our naming conventions, we can just paste it right there. And now we have all of these functions right here. We have the new functions in that jump table. So now we got to look here, and we see, okay, we got this 0 to 4 inclusive, so this needs to be a 0 to 6 inclusive now. Let's not add anything else in here. Let's just call it that. That's fine. And we have a hard-coded 0 to 6 in other places, right? So we have this 0 to 6 here as well. And if this is not invalid enum whatever, okay. So lowest command enumeration And then this is the highest. Highest. All right, since we're revisiting this code, it does make sense to just label things a little bit more explicitly. So now we're going to give that a shot and see if that runs, right? See if we screwed up anything there. And we're just going to keep on refactoring this until everything kind of like works. So it doesn't seem like we have any compile time mistakes. And so the lazy unit test ran, that's all good. And it passed. Okay, so now we want to try one of the commands that's completely bogus, right? So exe, and let's do C99 to naked text, and let's just say 001.txt, I think is the thing. And it says bogus function. Now, if we do something like C99, we forget the extra parameter, right? We say, and we forget this parameter, and we just run it like this. One argument wanted 2 or 3. Okay, that's fine. It is an invalid command, but it's not called with the correct number of parameters, so we'll let that slide. Also, if we do the inverse, so if we do naked text to C99, and then we do 001.txt, bogus function, naked text to C99 text. Okay, so that's fine. So the next thing we want to do is we want to do our PNG to naked array, and we want to do logo.png, and we want an output file of let's just call it out.txt, but then we also want a thing called len.txt. So we want so we have 1, 2, 3, 4 arguments, or do we? 1, 2, 3, 4 arguments. So let's give that a shot. And it says PHEXDUM default text out. So that's a little bit bothersome, this default text out. I think that was probably because I added more parameters than were needed. So if we get rid of this thing here, and we do this, yeah, so if we do more than the number of arguments that are being expected, we're getting a problem where it looks like the code throws an error if we give it not enough parameters, but if we give it too many parameters, it seems like it's also doing something weird. So we have like 2 or 3 arguments. If we have 0 arguments, if we have 1 argument, wanted 2 or 3, wanted 2 or 3. So what we need to do here now is just say, really we want 2, 3, or 4 now. But down here we have this default text out, and I don't know if that's really what we want to do, because this default text out isn't very helpful. It's really what's going on here is that we have too many arguments, right? So we're saying 0 arguments, 1 arguments, or 2 and 3, right? So really, what we should be saying is, instead of default text out, we should really be saying something like, we should really say, you know, ignored too many arguments, too many CMD line arguments, right? So there's too many command line arguments, and that's what's actually going on. So if we take a look at this, and we give that a run, we try to compile that, we want to make sure that when we run this, we actually get a message that's a little bit more informative. So if we try to run this command with, you know, the out.txt and the out.length, or the len.txt, whatever you want to call it, and it says ignored too many command line arguments, that's more specific to what the actual problem is. And so now what we want to do is we want to say, oh, you know what? We change our mind. 4 is actually a valid amount as well. And this fourth argument, we want to say, okay, let's see, here's three arguments. Here's our third argument here. And so file path output is what this is called. So I think we should just call something like len out. Len out maybe might be the good name for this. So let's just copy this and say load optional arguments. Let's make a section called load optional arguments. And within this section, we're going to do really could just exit. Let's just make a command. Let's make a note here. Return instead of exit. So that long rant, we're just gonna put it there, and then in our commentary file, we're gonna take this long comment, and we're just going to offboard it to over here. And so we can still find this comment. If we really want to find this comment, we can find it later. Right, PHEXDUM return instead of exit, right? So it's an offboarded comment. And I just think that this is kind of clutter, and rather than kind of figure out how to reformat that comment, we're just going to dump it in here and say @vid IID 0128. The time is 1:27 and 42 to be cool. Comment offboarded to H file on date. And the date is 2021-0208. Okay, so now that we have that offboarded, we can say blah blah blah. This is the output argument, correct? So file path out. Yeah, so this is the output argument. So we'll just say arg3 output file for output file for data, right? Is what this is. And let's call this return not exit so that we can indent it like this. And then we'll just kind of also say, we'll double label this because that commentary is a little bit too long for our column limit. So let's kind of like change that up. Okay, so now that we have this, and this is argument 3, right? So argument 3 is the output file for data, right? So it's the main thing that we actually care about. And then we want another thing. We want arg4 length of data number in file. That is kind of like a very, very ugly kind of name. Length of data, number in file, whatever the heck. we can make a note of this, right? So at vid IID 130 and 23 for the conspiracy. And so here we're just going to create a file that just has a number in it that tells us how long the array is. The naked array, how many elements are in that naked array, right? So that is so this section here is to implement in our notes file, right? In our notes file, we have, our array. Our array is right here. And here's the raw data for the array, right? Here's the naked array.txt. But we also need another file for the length, right? So the length that goes inside these square brackets. And then we can also create a variable, myDataLength, and also include this file. So this file right here, this output file, is going to be the fourth parameter right here in this section, right? So we can say, example. Let's take this and say example naked array len.txt. Let's keep that as a little example so we can kind of more easily link it back to the notes file over here. Okay. Well, we can link it back to the notes file when you're looking at this timestamp. You'll be able to see this right here, and you'll see it open over here in my editor over here, right? So this stuff, let's highlight that again because they're two different colors. But this right here, and then corresponds to this stuff over here, right? So anyways, let's figure that out. So first thing I want to do is let's just cut and paste, right? Let's cut and paste. Most of this stuff is going to be the same. And PHEXDUM return not exit. Sure, we could do that, but we're also going to have to make these unique. So we'll use like 001 here, and then over here we're going to say 002, just to make the error messages unique. So my str string comparison, whatever. Oh yeah, so this is my specific string comparison function that I made. So this file path out thing here is not going to be what we want. This is going to be arg4 is going to be file path let's just do this. Let's just call it file path txt length to kind of match this thing here. Let's also keep another example right here for what we want for this, right, for this. And the string comparison, let's just call it SC for string comparison, because everything is going to kind of need to be more terse here. And let's see where else we can find SC. If we match whole word only. So we are already using SC, so I just want this to be a unique whatever right here. So actually it's like string comparison insensitive, right? So let's call it psi. And the only reason I'm doing this is just so that when I try to look around the code base, I want this to just be unique right here, so I can just easily see, hey, I'm defining it, using it, and then undefining it. That's the only reason I'm giving it something different, is because I really don't... So 0 equals this comparison here, And then we have this file path input, but then we have file path out. We don't want it to match either one of those. So let's kind of like say 0 or this thing, right? So file path out, so the input can't match this, the output can't match this as well. So 0 means that these two things are identical, right? This is just false, right? That is kind of weird how I wrote that, but that's fine. So that'll work. So FIP_TXT length, and we need to actually declare this somewhere. So by FIP out, if we can find FIP out, we need something where we say, you know, FIP_TXT out, right? Which is kind of a weird name. It's not the same as everything else. It kind of breaks the pattern. But the reason why I don't want to call it FIP length is because then you might think that it's the length of a file path, and that might be kind of confusing. We could call it now let's just keep it like this. Let's just kind of keep pasting this example everywhere. Right? And this is going to equal... Right, so this kind of makes things kind of suck, because now if we want to realign all this, we have to kind of like do all of this. Right? We have to... right, everything is taking up more room now, right? So it's kind of like... I don't know. I don't know if I like this. It's argument 4, right? So why not... I know this is kind of like, okay, that's kind of crazy. But why not just... Sometimes when you're running out of names... when you're running out of names, and none of them make sense, then why don't we call it this? FIP004, and that literally stands for file path output, and it is from argument number 4, right? So it's the it's defined by argument number 4, and then right here we're getting argument number 4, right? So this thing right here, easy. 004 is this thing, right? So right, and then we can say, you know, FIP004, aka FIP out txt, right? That's what we're calling it. Yeah, FIP out txt, FIP txt out, FIP, aka FIP txt out, right? We can keep a little aka there. Let us know what we meant for that, but yeah. So the thing is that if I can read this and say, okay, you know what, I'm just going to, no matter what I name this, I'm going to get confused at what it actually stands for later. So in order to avoid confusion, we're just going to give it a more obscure name. And the reason why we're going to give it a more obscure name is then we're like, that we can't make any assumptions on what that means. Because if I call it fiplen, I'm going to think it means like one of those other file paths and the lengths of the file path input, and that's going to confuse me. So we're just going to call it fip004. And, you know, we could make a note at vid iid 0128, time 1:41:01, and we could say y fip004, right? So if we want to know why exactly we decided that to call it fip004, we can explain that right now. So let's put this at 23 to keep the conspiracy here. So why did we choose fip004? And the reason was if we called this fiplen, we would think that it was the length of this. And if we call it fip_txt out or whatever, then we wreck the normalization of all these being kind of like the same length. And this one has like a special, like, the token length being longer, making an outlier like that wrecks the normalization of the data. So because we can't really find a good three-letter abbreviation that will concisely explain what this variable is, because we can't figure out how to concisely explain what this variable is without leading to confusion, we're actually going to make the variable name more obscure rather than less obscure, because it's better that the variable is obscure and hard to understand than to think we know what it means when we don't know what it means, if that makes sense, right? So, so better to, you know, like, for an analogy, maybe, better the instruction manual be written in Japanese and have the proper instructions than to have a short description in English that could be easily misunderstood by somebody who natively speaks English, right? If that makes sense. I don't know if that's the best analogy, but we're intentionally being obscure because we just don't want this to be misunderstood, right? So it's better to be, okay, to be more concise. Let's be more concise. So the time 43, and let's wait for 23 again. So let's explain it one more time. It's better to be completely obscure than concise and misunderstood. Yeah, that's why we're doing this. We would rather have it completely not understood than misunderstood. Better to be completely vague and not understood than misunderstood. That's why we have this kind of weird variable name that's completely cryptic. So we can figure out what this variable name means, right? We're going to look this up, right? And we are going to document it. It's just that you can't exactly look at it and say, oh, I know exactly what that means from looking at it. So we have default text output, default file path output, default data output. And so this is default length variable output. And then example, and let's keep another example, right? So let's just keep on pasting this. Right. So let's just keep with this. And this is kind of fluffy how we've been doing this, but oh well. So char pointer, And this is going to equal we're just gonna say just call it array dot txt dot len dot underscore. So something like that. I'm not going to call it naked array because it could be some other piece of data. We'll just call it array.txt.length, right? So this will be the default for this. And then we assign the default here, and then we actually have to implement this, right? So we have it sort of implemented, right? Because if there's a fourth argument, then we have, let me fill it out here, right? So we override it. So right now it's going to be hard-coded here. Then we can override it here. Make sure there's nothing that matches exactly. And what else? So then the question is, where are we saving this? Like, how are we saving this off to disk, right? We need to implement that somehow. So before we even try to implement that, let's just make sure that the changes we have made haven't wrecked how it compiles, right? So this is kind of getting annoying. Does not allow extra outside function, blah, blah, blah. 94 in the data. So if we look at this, this is just a force of habit. We got to remove that. We can't get away with that. Also, the formatting, we've decided to do it this way in these files, so let's kind of keep up with that same formatting. Also, if we want to be nice, I kind of like doing it like that if we're not too long. Okay, so we actually have a null terminator here. Now, we probably don't need a null terminator. A null terminator is added by default for a string literal like this, but better safe than sorry, so let's just put it in there with everything else. And even if it's not safe or better safe than sorry, it's also nice to be consistent with the way we already did it in other places. So let's take a look at this and see what else we've screwed up here. PHEXDUM default FIP004 error, FIP004 undeclared. So if we go up here, we have set this here, but it looks like we have a declaration section, probably, right? Yeah, file path out. And so, CHR pointer FIP004, length, file path out, length file. What's a length file, right? It's file path out, but it's the length file. Sure, let's just put it there. Let's give it another run. Segmentation faults. That's always a horrible, horrible thing. So we got to think about, well, what did we add? Well, we added this FIP004, right? And let's go look at that code and see, okay, well, here's kind of where we did this code. And arg array 4. Oh, well, if we look right here, it looks like we screwed this up, right? So we have greater than or equal to 3. This needs to be changed to a 4, right? We kind of cut and pasted this. We changed this number. We didn't change this number, right? So we could say define arg. We could define argdex as 4, right? And this is the argument index that we're actually looking at. And then down here, we can undef that, right? So undef argdex. Or actually, we could do arg4, right? Instead of calling it argdex, why don't just call it arg4? Arg4. And then over here, we can, instead of that, we can say arg4 and arg4, right? So we can see everything connected there. And then over here, if we want to be more consistent here and refactor this, we can also do the same thing and say define, and this is arg3, and arg3 is going to be a 3. And then, so that is going to be arg3, that's going to be arg3, right? And then down here, we can say undef, and arg3. So the idea is that when we fix the code, every time we fix the code, we want to make it more robust, right? So we just don't want to fix the problem, right? We could have just instantly fixed the problem, been like, hey, this line's wrong, fix that 3 to a 4, right? We didn't just fix it to 3 to a 4. We made the code more robust so that that error is not going to re-pop up ever again. Okay, so now we ran this, and it's working. So we can try .exe, and then we're going to say, you know, png to naked array logo.png, and I'm assuming that worked. So we could look at this thing right here, and if we rename it to .png, we should be able to actually, I did that completely wrong. What was the command I ran? PNG to naked array. So actually, this is completely wrong. Rename this. Let's just rename it to, let's put it back. Yeah, if we look at this, yeah, that's what I expected. I don't know why I was, whatever. So that's fine. So that looks good. Now the next question is, how are we going to get that? How are we going to get that output file that's going to tell us what the output file name is going to be, right? We got to figure out how we're going to get that into what we've been doing, and I don't know exactly how we're doing that. But the payload object is going to have to somehow encode. So if we look for the payload object, payload, this needs to be changed, right? Because we have more things now. These two commands are bogus, but let's change the documentation to match this. So naked text to C99 text. So right over here, this is going to be naked text to C99 text, and right, and then here is going to be naked to C99 and C99 to naked. And we can go see, this is going to be C99.text, and then I don't know, naked.txt, I don't really care. But this really makes more sense calling it naked.png. Yeah, that's just more consistent. But yeah, so in our payload, let's go find that payload thing. So not our enumeration, but the struct here. We have the PNG file, we have the any text, and we have the array length. Now, so this length is not the length of how many literals. So we need something that we could call it number of elements. So this is only going to apply if it's any text. So let's just say that, you know, int32, any text, number of elements u32, right? Number of uint32 elements encoded by the right. So variable only valid if bin txt equals right. So we're just going to add to the payload and make this thing here. And then we're just going to kind of fill that out, right? So let's go and find let's go find this function here. Oh, backwards. So right here is what we want. And let's just create some control F help here. And because I keep on wanting to type things like PNG C2 naked text, PNG to naked text, or PNG to naked text, or PNG C2, right? I keep on wanting to type these things, but I can't find them. So we can make this a little control F helper, right? So that way, next time I want to look for, you know, PNG to naked text, right? Next time I want to look for this, which is what I type in the command line, I can easily find it like right here really quickly, right? Because this is, the actual command is not exactly what I type in the command line. Well, you can type this in the command line as well, and that'll get you there. But you can see why maybe PNG file to naked text. But you can kind of see why maybe or PNG file but you can see why it might be convenient to have these little helpers here. So next time I try to look for this specific token, I can find it easily. Okay, so this is what we want to change. It's the only thing we really care about, PNG file to naked text, right? So we want to output a file for the the length. And I'm not exactly sure how we got those arguments in there, right? Because we have this command here, and it just takes this PNG file argument. I have no clue how we got the arguments in here, right? Because we just have this one payload object. That seems kind of odd. I'm going to guess that we haven't implemented the output file. Or have we? So file path in. Oh no, the output file doesn't need... This function doesn't need to know about the output file. That's why it's not here. This function also does not need to know about the output file for the length, right? It just needs to encode the length in the payload. Okay, got it. Okay, that makes sense, right? Because this is a command. This is a command that won't always be executed by the command line. That's why it's written this way. That's fine. So with that said, where are we gonna put this? Like, where does this? Where do we put this? I don't know where we put this. Well, we load this file. We load a file from a hard disk. This U08 array to naked text right here. So here's the naked text and the naked text length. Let's just put it here. Let's add it another thing here, and call it no U32. So I'm not sure if I want to call it no U32, because maybe it's not going to be U32. So I think sometimes it could be something else. Number of literals, right? Number of literals, right? And we can make a note in our notes file where we have a place where we're documenting different names. So we could say numlit, number of literals. Example. Right, so that would equal 2. Right, so if we have something like this, where it has 2 literals in here, then it's 2, right? And then number of literals in uint32 format. So I think that we should call it null for number of literals. And yeah, so we should call this null U32, right? Null U32, number of literals, format uint32. So the format is a uint32 literal, right? So now that we have like all this stuff here, it might make sense to document these in our shortcuts, right? So we have this null U32, and if we type it correctly, we're just gonna say we typed it correctly, right? So if we do it backwards, we're gonna say that we did it wrong. We also want a definition of null U32. Like, what does that mean? Null... So, null U32, number of literals, format, uint32. Example, 0x ff00 ff00 0x ff ff0000 equals 2, right? Because there's 2 of them. Okay, now if we do something like null no u32 no u32 no u32, or u32 no u32 no and u32 no, deprecated, use null u32. Right, so this is close to what we want, but it's not exactly what we wanted. And what was the other contender here? Numlit. 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 Be more specific. For example, null u32, right? So if we try to use number of literals like that, we're going to say, hey, be more specific. If we do it backwards, like litnum, backwards, and be more specific. Alright, so null u32, right? So now we have this kind of documented here as well. So we can kind of continue, and if we ever wonder, like, what the heck is that variable, we kind of have it documented in multiple places, and we know what the heck we meant. So we have it, we're going to have to implement it here, right, because we added this parameter. The compiler is going to catch us if we forget about it here, so we're not going to worry about it there. But also, we want to fill out the output parameters, right? So we have one more thing we want to fill out here, right? Which is that naked text dot, and let's look at this payload. Any text number of literals u32. That is kind of like, that is kind of overly verbose, but the idea is that it only applies when it's a naked any text type. So I think that it makes sense to be verbose like that. And we're just going to set it to this number of literals u32 value, right? So we're not going to do anything fancy. We're just going to move it forward there, right? So now this number of literals thing here, we actually have to define it here in a section. So if we look here, we have a declare variables section. Load file if exists. Well, where is it actually being used? It's being used into array to naked text, right? So do we have a section for array to naked text? Yeah, array to naked text variables right here. So it should be declared right here. So we'll paste it here. And we'll just set it to 0 initially, right? So number of literals, u32. Number of literals, u32, right? Okay, so now that we have it kind of like packed in there, the next part is okay, well, we need to support that variable, right? So number of literals, U32. And so, right here, we're just going to say int32, and we're going to say by ref number of literals, U32. Number of uint32 literals. And then we want to see where we're exporting these and do something about it. So we have a section where we kind of output this, so we want to write the same kind of thing and say, okay, by ref, number of literals, U32, equals number of literals, U32. Right, so we're going to keep that same kind of pattern, but then we also want to be like, okay, well, where the heck are we declaring these variables, right? Because we want to declare a number of literals U32 variable somewhere, and so we see allocate string memory, variable declaration, right? So we see don't want to mix by ref double pointer crazy logic with our other logic. Yeah, that makes sense. But yeah, so right here we're just going to say int32 number of literals in the format of U32, and it's initially going to be set to 0. Okay, so now the next part is, well, yeah, sure, we have these here. We have it declared, but we still need to somehow figure out what those values are, right? So we never set this value to anything. And somewhere we're setting these values, right? So, so somewhere these values are getting set, and we want to figure out where to set this value. So we see naked text is kind of like this array, so the naked length is probably what we want to look at the most. So this thing here, so let's look at these two colors here. So the cyan is already assigned, and the orange we want to assign. So let's look at this cyan times literal length. So this variable is probably exactly what we need. So, number of hex literals, right? Number of hex literals, right? So, AKA, so number of hex literals is also technically what we could call this. So we might want to make a note of that as well. Now, do we have a definition for what that is? So if we go like, that seems like an uncommon variable name. Number of hex literals, right? So if we do this, sure, we can make note that's correct. Let's make sure that we haven't, like, forgot to reload our shortcuts and this actually exists somewhere. No, it doesn't. So, if we type it kind of similarly, we're just going to correct it. Okay, so NOF. Okay, so this is number of hex so U32 or U08 literals. Right. So it could be in two different formats. But yeah, that's definitely the variable we want. So, we're going to say right here, we're just going to say aka number of literals U32, right? Right, so number of literals U32 is actually what this is. And because this number of hex literals is already kind of set here, I don't really think we need aka aka so number of hex literals, right, is what we could also call it. And so rather than create a variable for this null U32, let's match the whole match case here, or match whole word only. And say, we actually don't need we've already kind of declared it here, so I guess sure, I don't really care. They're synonymous. I don't care about adding a little bit of extra cycles. So, we can also assert right, they're just synonyms for each other. That's fine. That's fine. It's a little bit ugly, right? And we're being a little bit wasteful. But it's better that we just know that number of hex literals and number of literals U32 are the same thing. Number of literals U32 here, number of literals U32 here, and then we just output it here, number of literals U32 there. Okay, so now that we know that that this function is properly returning that new parameter we've kind of thrown in there, we can see where that's being called. And it looks like it's this one new place that we've kind of like put this in here, number of literals U32 here. And we've created this variable here, so it's there for us. And then it's being outputted here, so number of literals U32 is being outputted here. Excellent. So now we got to see, like, okay, well, where are you being called from, right? So where is this function being called from, right? It's being called from, like, in a jump table somewhere, right? So in this jump table, here is where it's being called. And we need to make sure that if this exists, that we want to save it out to a file somehow. And we only want to save it out to a file if we've provided... Well, we have a file name, an output file name. So, let's just look here and see what we got here. Text out. We'll save to disk. Payload.anyText. Save text to output file. So this is the section that would consider doing everything we need to do for saving the text to output file. So let's kind of read through this and see what's going on here. So figure out what to save to disk, right? So if there's no payload, we're not going to look at it. If it has a payload, we want to see if it's an anyText payload. If it's an anyText payload, we have this file data out equals, you know, this anyText in the array length. So we have a save file txt. We want to um, so let's just make another section here. Right, so there's going to still be save text to output file, because that's what we're doing. And then in here, we want to like do something like this. We only care about if it is a. So we had this thing here, right? So we only care about any text, right? So this thing here. So we only care about if it's this type, right? If it's not this type of payload, then we do not care. So I'm going to say, you know, int32, right, this variable here is going to be extracted from this payload here. And we don't need, I don't know why we have a cast in the first place, but sure. And we need to define any text as whatever it was defined up here. So any text is this payload type enumeration. And then we'll undef it here. So if it's any text payload, then we're going to do this. Okay. So the first thing is we need to convert it to a string, right? So file data out, file data number of bytes. God damn it. Okay, where's the fuck? Fuck. Okay, I will be right back. I need to get something. God fucking damn it. Okay, so you might not be able to hear me very well. but needed to get my mask on because there's solvents in the air right now. So let's see. Let's get this working. So we have this like file data, number of bytes, and whatnot. And I want to know, like, am I doing anything with this file data output that maybe I want to make like new variables for this, or can I kind of reuse these? So if we look at this, file data, whatever the heck, out, and file data number of bytes. It looks like we could just keep it like that and just reuse those variables. It doesn't look like there's any type of there's no reference to it down here. So I'd say we'd be good with that. So the file data out is going to be like STR-OUL, something like that. Yeah, I do mean that. STR to unsigned long. So STR to unsigned long, and we're going to take the actually, no, we're not going to do that, are we? We more want like I to A. We really want something like into ASCII, right? I to A now. So let's make a note of that. So I to A now. And let's go look up how that needs to work. So we really need like int to ASCII, and we need to take this number and convert it to ASCII somehow, right? And I don't know exactly how that's going to work, but that's going to be the output data. And then the number of bytes is going to just equal, like, you know, the string length. Right, as long as that's null terminated, then that's kind of like all we need to do, right? Is do that. And then we can just take this junk here. And it also looks like in order to get this to work, yeah, that's fine. We just need to work it like that. That'll be fine. Okay. So let's go look at how we use int to ASCII really quick and see how we can get that working. So I to A C99, so int to ASCII. So I really hate advertisements like this, like allow or later, like fuck you, really? Like, how about allow or don't allow, or allow, or how about never? Like, I really hate this, like, this attitude here. I don't know, I don't want to get too inflammatory with analogies for why I don't like this attitude, but let's just say that saying yes or maybe later, maybe you could think of some situations where if somebody was trying to coerce you to do something and they said, hey, you can either pick yes or later, but never yes or no. Can you see like why maybe that might be kind of problematic? Not that I'm going to cancel someone on Twitter for doing something like that, but you know,
I do, like, you know, if I meet the person who wrote that, like, you know, there's that. I'm going to have to hold back from punching them in the face. Like, so sometimes with advertising, the thing that annoys people less is actually less effective, right? So I understand why they do it, because it's probably more effective to write it that way than to write it in the more honest way. So it's better for your bottom line to be less honest, but you sacrifice your integrity doing that. Anyways, so A2F function converts string to float, I to A. So now the question is, where does this even come from, right? Like, we got all these examples, but does it even say where it comes from? stdlib. But it is a non-standard function. Okay, well, we're just going to see if we have it, and if we don't have it, we don't have it, right? So, I to A, we got the buffer. Okay, sure. So, right here, I to A, we got the argument, the buffer, and the radix. So the argument, the buffer, and the radix, right? So char, let's just call it char pointer. Buff, or actually char, buff, and 16 should be plenty. 16 should be more than enough. In fact, 8 would be probably fine. Let's just do 16 to be safe, right? So 16 characters. In case we have something incredibly long, but anything, by the time we use up 16 characters, we're already going to have some catastrophic problem because of how big the file is going to be. So that is going to equal, we'll just zero that out at first, and the radix, right, so int32 radix is going to equal, it's a base 10 radix, so base 10, right, radix, base 10 decimal, 16 character buffer. 16 character buffer, that should be enough. I to A gives us, it should give us a, oh, I to A does not, right, it's not how that works. So this file path output, we can just say, you know, file path out equals the buffer, right? And the buffer is already a pointer, so we can just do this. The output data is this buffer. The number of bytes is going to be the length of the text, right? So we're going to do str length of file path name of file. Well, geez. So that's not quite correct, is it? So this file path out should be like FIP004, right? Or something like that. Where are you? Let's go way back up here for a second and be like, hey, there's FIP004, and does it have a default value? Does it have a default value set? Yeah, it has a default value set. Okay, yeah, cool. So yeah, FIP004 is actually what that needs to be. So FIP004 is the output. The output data, right? So FIP, so file data output, and that is going to be the buffer. And then file data number of bytes is going to be not the buffer, but the str length of the buffer, right? So we can do strlen buff, right? And that should be kind of like everything we need to do what we want to do, right? So we take this number of literals, and with the buffer and the radix, we can get, right, so convert to ASCII. Right, so we're going to convert it to ASCII, we're going to save it in buff. Right, so this is set up params for function call, or set up arguments for function call. And this is not really what we need. Let's get rid of that. Now we could say that the way we wrote this, I think, is clearest, right? Because we could also use strlen in this, but I think this makes sense. 1, 2, 3. So yeah, we're going to save the file, and that should be everything we need to do, right? So let's make a note of when this was added. So at vid IID 0128, and the time is 2 hours, 37 minutes, and 8 seconds. Added ability to save a file telling us how many text literals are in the naked text array, which is needed for using data embedded by our build system. Okay, so that is kind of a crappy explanation, but basically, if we want to use this hex dumper utility in our build system, we have to somehow get a way to figure out how big those string literals are. And this is going to do it for us. So right here, we just want to make sure that we have this feature kind of in there. So our code is all over the place. We don't know if we've made any stupid mistakes, but now is the time to just try to compile. See if we can compile, fix some things if we can't compile, and then go from there, right? So PHEXDUM.sh, let's just see if we can compile. And we see where we put this, like, control F help, we kind of botched that completely. So let's go and look for that for a second. That should be in the function file, should it not? Okay, so it's not, and that is kind of infuriating. Oh, because matchful word only.
Okay. So, this is me being stupid, right? Because if we want this to actually work, then we can make that work if we want to, if we want to, you know, we can do this. If that's how we want to roll, we can kind of like create a section like this where we kind of like embed this in here like this. Like if that's how we want to do it, we can do that. I feel like putting the colons on both sides might help. Writing it like, sure, why not? But yeah, we just need to surround that in a multi-line comment because it's not code, right? It's just comments written to help us find our way around. And we have a thing that says fatal error, too many dots. And I am kind of confused there because I don't know. So that's because with the way we structured our code, we never wanted to, we wanted to keep things kind of simple. And by having files with multiple dots in them, it made things a little bit too complicated for us, for our saving feature. And that's what's going on. So with this array.txt.length, we don't support that, actually. So we can give it some type of name that we can hold on to, where we can kind of have a better idea of like what it means right away. So number of U32s, right? So I think that it'd be easier just to call it let's look for where we're using null U32 and see what we can call it. How about, let's name it, I know somewhere, yeah, by_ref null U32. Yeah, anyText. Didn't we have a variable called anyText null U32 somewhere? Yeah, anyText null U32. Let's just call it that, right? So, because we cannot write anyText null U32 dot underscore, right? Let's name it that. And let's give that another run, right? So it's just, that's a runtime error because I can't support multiple dots in the way I decided to do this, and that's fine. So the unit test ran, and we're good. So now the question is, if we go up here, can we actually find the actual thing? PNG to naked array, and logo.png, right? So let's try that out, see what happens. And we got an assertion that failed on line 1457. So let's go control H, or no, control G, because we're going to go to the line 1457. And on line 1457, we see number of hex literals equals this. And so that is crazy that these numbers don't equal each other. Like, how the heck did that happen, right? Because it looks exactly the same. I did not expect that to fail. Like, of all the assertions that I expected not to fail, that is not one of them, right? Because we assign them both here. Oh, right, because number of hex literals here gets added. We add 1. Okay, I see. So, if we want to kind of keep up with this parallelism here, this hackishness here, then that also means that we have to do the same thing here, right? Right, so this is ugly hack, the way we're doing this, but sure. So, so if, and then do a not equal, right? So, since this already got triggered, we're going to be more specific and be like, error should we'll just do must match exactly this variable and that variable, right? Let's say, let's make a note of this. Right. So, hackish. So it's a bit hackish, but just get it working, right? So, there is really no need for this other variable. And maybe we're just causing more headaches by just adding this other variable. But it's just nice to have this extra explanations in the code that number of hex literals is equal to the number of literals in the format of U32, right? It's nice to have that explanation in the code. So I literally added extra variables and changed how the code functions in order to make the code more readable, which is kind of a no-no for me, but sometimes I do it, but it kind of makes the code a little bit dirty. So let's run that. Okay, so unit test passed. That's good. And now let's clear this and look for the command we want to test. So PNG to naked array, right? Logo.png. And that looks good. Now let's go check the file system and see if we have this thing. So any text, number of literals, U32. So let's take a look at that and see if we have like a number here. We got 187. And is 187 the number we expect? Like if we take a look at it, does that make sense? So do we have an output file? Nope, we don't. So that means that it's going to be in our default file, which is going to be this like it's going to be in this thing here. Should be our output file. And so we're saying 187. So 37 times 1, 2, 3, 4, 5. 37 times 5 plus 2. So 37. So 37 times 5 plus 2. Is that 187? Yeah, 187. So it is correct, right? It's giving us the correct number here. And so now we have kind of like everything we need to create a build. So now the next thing is we should try to run this somehow. Let's try to create like a demo project in here to make sure. Let's create a demo. Okay, and in the demo, we're gonna say we're gonna steal logo.png for a second. And actually, let's actually steal. No, let's just steal this asset here, 512 by 512. So let's just delete this. And new text document, we're going to call it demo.c11. Yes. And we're going to say so it main void with arguments. Boy, that's not what I expected. So let me make some notes here. So I2A, we just used I2A. Let's go find that for a second. I2A. And this is kind of like, I just want to make a note of this. CHR buff 16 equals to do. Okay, so int main void with arguments. Let's look for int main in here. Or actually, no, it would be in here in the C11 file. So if we look for main, we should have, yeah, argument count, blah, blah, blah. We're just going to steal this here. We're going to steal this code here. And we're going to make a snippet out of it really quick. So, char, int32, arg count, NC for non-const char. So anywhere we see char, let's just say NC non-const char. And say non-const char. Right? Then in here, I want to know how to call another executable. Call another exe file from here somehow. So I want to know how to call like another executable. right here and give it these arguments. I don't know exactly how I want to do that, but I want to kind of create this as like a little wrapper function, right? So let's save this and say sc files cxx snip new folder int main with args. So int main with args. And but also, I want to copy this as well. Oh, we have exe call here, huh? Let's take a look at that. I'm going to call this something similar, like so it's right next to there. I'm going to call it ECM exe call main. I'm going to give it kind of a ridiculous kind of section name here. Main section, ECM, exe call main. And then we'll say, and so it looks like we've already done something similar before. So let's go kind of find the other function and see what that syntax is in our demos file. So we have so execv. Warning, once you call the other exe from your C code, control never goes back to your original C code after the called code is done executing. You'll need to keep learning until you fix that. Okay, so if we use this to call the other thing, we're never getting control back, huh? So we might as well keep that warning. We might as well keep that warning in here, because that warning's kind of relevant. We can also make that warning like red or something, right? So that's a pretty big deal, right? Not being able to get control back. So we can use this as a little demo script to do what we need to do, to like explain how to set up a build system. But we can't use this as, like, the final thing here. So... you know... so that's the define we're going to need for that. And it looks like we have the args is like in an array. Okay, so it's a null terminated list. We have to create a null terminated list if we're going to do this. That's fine. I just need to know that that's what's going on here. Now I don't know if the actual arg array is already null terminated, right? Like I'm not certain if that is. Well, we're about to find out. So if that's a null terminated list, then we're already good, right? Except the argument array, yeah, args. We already have argument count, so what we could do is we could say if we're lucky, this is already null terminated. So the command is going to be // right, this is going to be what we want. This is the command we want. And that's arg. So really, we're just going to ignore these. We're going to ignore these arguments. Or are we? Yeah, I don't know if this is a good idea. Okay, I'm gonna abandon this. Left unfinished. Right, so I'm gonna say, you know what, we're gonna leave this unfinished. Because I think we're getting out of hand here. I think that trying to set up a little example and all that stuff is great and all. But I think that we're wasting time. I think we just need to go in for the kill and get this working. So, so we know kind of what we need to do to get this working. Let's just delete this demo. Right? So I know how I want to use it. Okay, and that's all that really matters. Now let's kind of take this. Let's take this and put it in our gitignore. All right, so let's put that file out.txt, rename. Same thing. Let's put that in our ignore. Yeah, so out.txt. Yeah, let's put that in ignore. So this thing and this thing, all these things, let's kind of delete the things that are going to be ignored. And let's just give that a run let's make sure that everything kind of makes sense here. Right, so if we do this, PNG to naked array, it creates any text number of literals U32, right? And then this thing here. Sure. Okay. So now the next question is, okay, if we try to do something where we actually know what the outputs are going to be, where it's going to be like, so array.dat and then array.len, right? Let's call it that. And then we have this .dat, and if we go open with, and we say more apps, and we look at this thing here, we got the data. And then if we go look at this, the length, and we open this with more apps, and we got this length thing. So I would like to keep that underscore format, so maybe like r underscore dat dot len dot under, I don't know. Let's just delete this. So that looks kind of like how I want the system to work. Let's just let's call that good, right? Let's say, you know what, we have everything we need. Let's put this this stuff over here, and let's clear this. Oh, there's one more thing though. If we type a bogus command, it just blows up on our face, right? Okay, well not yet. We have to give it some other arguments, but if we do like blah dot blah, PHEXDUM command not found. Okay, how about if we have all these valid arguments, and then we do some just gibberish here, right? Okay. I could have sworn that if we typed something that was gibberish, it blew up on our face earlier. Maybe I fixed that, or I don't know. PNG to PNG. That's not a valid command. Maybe it's the dash is an invalid command. That. Nope. It seems to. How about, maybe it depends on how many invalid arguments we have. Maybe if we do this, it blows up. Nah, I mean, it looks good. Okay. So, array.dat, let's add this to the ignores. I know I'm kind of like adding a whole bunch of things in here that are going to be ignored. So in my git ignore, I just added all this. And let's close that. Yeah, let's look at this again. Okay. Git commit dash am ready to integrate. Okay. So we got this thing. If we think about it, it's kind of like a file utility. So we should make sure that we integrate it properly when we are using it. But we should have a... So we want to take this stuff here, and we want to dump it into our main project, right? So we kind of like worked on this separately, and we're kind of like ready to we're ready to put it into the main project. So before we put it into the main project, we want to double-click this, make sure that it builds, right? Make sure that it builds before we try to start pasting code into the project, right? We want to confirm that the project is indeed in a valid state, and if that is the case, then we will gladly do what we need to do. Yeah, so that's how we last left it. Now let's do a git bash here, make sure there's no like changes that we didn't commit. So in the documentation, and then we have like default data 001.png, and let's go look at that. So in the lib assets folder, and it's like lib, but we also have libdat, unit test data. So data and assets are kind of different, right? So I didn't put assets inside the data folder, even though assets are technically data. Or we could do assets.data, or we could do data.assets, but we want to keep things as flat as possible. So assets means not text stuff, right? This data is kind of like textual data that's just included into things, right? So, but these are like actual assets. So if we look at this PNG file, right, this is kind of like the default tile set that we would like to encode into the system. So we need to create like a build system for that. So all this stuff, that looks good. Git status, git add dot git commit dash am, save before integrating and this is actually a working commit, right? So because this is a working commit, we actually are at liberty to git push kanji coder master. We can push it up to kanji coder as well, and that's fine. So now that we have that, let's let's kind of figure out where this goes. So if we go into our lib, we may already have like a stub for this. We may not though. So p whatever the hex polyogl. So it does not look like we have it stubbed in here. So that probably means that if we look at our C11 file, I'm going to guess that it's not in here either. So we can make absolutely sure. We can go Control H and go, hey, is there PHEXDUM in here, right? And it looks like, nope, indeed you're not in here. So we want to integrate this into the main project because we're probably going to need to add some other functionality to this. Like, there's probably some unforeseen functionality that we're going to need. For example, we want to be able to uncompress whatever assets are encoded into the library using PHEXDUM. We also want to use PHEXDUM to decode those assets as well. So it kind of makes sense that it would be kind of... It's more abstract than FileBoy, right? Because it does some weird kind of stuff. But if I want to think of like, we could integrate this into here in many places, right? This is the list of dependencies, and this is the list in which all of the libraries are included. Currently, this library has really no dependencies, so we could put it kind of anywhere if we wanted to. But it would make more sense if we put it somewhere that kind of makes... It would make more sense if we put it somewhere that makes sense. Well, that's kind of circular logic. It would be really cool if we could... Like, we have this list here. It kind of sucks that we don't have a... It would be really nice if we had two lists, where we have one list of things that have 0 dependencies, and then things that have, you know, more than 1 dependency, or whatnot. Because right now, PHEXDUM has no dependencies on anything, right? And so it's like, so if you put PHEXDUM right after FileBoy, there's still the potential that it could rely on FileBoy or any of these things, but it doesn't really rely on any of those things, right? Well, actually, it kind of does. I don't know. There's a compromise. I mean, you can only say so much, and you have to choose what's important to say here. The most important thing to say here is everything is included in strictly this order. That's the kind of thing we wanted to focus on saying. And so, yeah, it does suck that this library we're going to add in here doesn't really have any dependencies on anything, but we should still put it somewhere where it makes sense, where we don't have to rearrange it. So we have this like FileBoy, so it may make sense in the future to eliminate some redundant code by making some of the PHEXDUM file access functions using FileBoy, right? So that could make sense to have it right after FileBoy. So I'm thinking kind of in here is where we want it. Let's think about what else would make sense. Should it need to know what keys are pressed? That seems like a bad idea. Does it need to know mouse position? Any of this stuff doesn't make any sense. It's just for the build system, for managing files and encoding and decoding. Does it need to know about fragbed? No, in fact, fragbed and like GPU data and the pixel pushers and pixel loaders and this kind of stuff, that kind of stuff actually probably needs to know about PHEXDUM, but not the other way around. So I think that PHEXDUM being here is probably the best place. So we can just kind of steal this. So PNG hex dump, right? And this is going to be 6. PNG hex dumper, right? PNG hex dumper. And that's for getting assets into the engine. And so now that we have, this is 6, we have to shift everything up, right? So we have to take everything here. And we just got to paste it here like that. And then now we have 34 different libraries. So 34 different libraries. And now we have to compile up to 34. So compile to 34. Cool. And we're going to have to cut and paste. So we're going to cut and paste what we worked on and say, you know what, we're done developing it as a solo library. We're ready to just cut and paste what we worked on. So the D file, the F file, and the notes file, right? So the C11 file, this C11 file here, it's just kind of like a bootstrapping, right, to get things kind of working. So this standalone logging, we may have to define this. We may have to rework this, but this configuration may break our code not having this. But we'll get to that when we get to it, right? So let's just steal the data file, the function file, and the notes file, right? So we're going to take those and we're going to copy them. And then we're going to paste them into the lib folder here. So we're just going to control paste. Okay, so now we have PHEXDUM, notes, data, and functions. And we're going to forget this exists now. We're going to go to AAC 2020 folder really quick. And we're going to open up the things we need to open up, I guess, to start getting this working. So we know we need the libchan. The libchan top and bottom, we're going to need to open, right? So open those up. We're going to need F macros as well. So F macros, top and bottom. We're going to open those up. So open those. What else? I don't know what else we need. Let's close all this stuff, all right? Let's do I reload it? Nope. No, don't save the file. Jeez. Okay. So let's just try to focus on Okay, this is in there. So let's look at libchan top for a second and say, let's put this over here so we can focus, so we can look at this summary here and say, oh, PHEXDUM is 6 now, right? And so now when we're editing libchan top, we can go through here and start just editing things. So now we have 34 individual libraries, so this 34 equals 34. These numbers need to match right here. And then we got to go find the old 6, which is native key, which now is going to be 7. So we're going to take this, we're going to copy it, we're going to paste it. And then we're going to change the one beneath here, or the one above. We're going to change this to PHEXDUM. And that's going to be our new 6. And then we just have to change all these numbers, which is really tedious. I hate this, but it's a trade-off, so I'm not gonna complain for now. The hope is, as this code base matures, that we don't actually insert things at the very beginning like this, right? Or insert things more at the tail end, and so we don't have this kind of problem of having this much shuffling, right? The closer to the beginning of the list we insert new things, the more problems we have. However, we want to insert things into that linear list of dependencies in the place where it makes the most amount of sense. So even if the place where it makes the most amount of sense is the place where it leads to the most effort, right, where it's the hardest to insert because of all the work we have to do, that doesn't matter. We're going to put things in the clearest place, even if the clearest place leads to a lot of effort like this, where we have to just kind of do this mindless, kind of like changing everything everywhere. So this is PIXName. Is PIXName 22? Just checking here. PIXName is 22. I'm just making sure because I kind of lost track while I was talking. So PIXSave 23, 24, right? We're just adding 1 to everything because everything is getting shifted down, right? And this sucks. Like, this is not one of the desirable features of how I organize my code. This absolutely sucks. The trade-off is just the lack of abstraction, right? Like, I don't have to worry about initialization order as much because the initialization order is very explicit because I took the time to meticulously hard code the initialization order into the system. But it comes at a price. That lack of abstraction comes at a price. So this is the price I'm paying for that. So 34. So 34 is the last thing. P5G OGL. Okay, so now we got to do the exact same thing. So we got to find the next 6 here. So native key. So we're going to take all this stuff. We're going to copy it. We're going to paste it. And this old native key, right, is going to be turned into PHEXDUM. So PHEXDUM for PNG hex dumper is number 6. And now we just want to change these numbers again. So 7s, right? This is 7. This is 8. This is 9. Okay, this is 10. Okay, 11. There's 12. 13. Gonna scroll up. 14. 15. 16. Let's spot check. Well, is 16 correct? 16 in our list over here is GL bind, and indeed it is GL bind here. So just making sure. So let's keep on incrementing. 17, 17, 18, 18, 19, 19, and this is 20. Let's spot check 20 once we're done with this and make sure that 20 is our free spot. So we have this random free spot in here. 20 is the free spot. That's fine. So let's scroll up, change this to 21, 21, 22, 22, 23, 23, 24, 24, 25, 25, 26, 26, 27, 27. Spot check 27. Is that pixload? Yes, it is. Okay, 28, 28, 29, 29. We'll spot check 30, since it takes a little bit more time to type 30 than it is one key. 30 is Tau Depot. Is 30 Tau Depot over here? Yes, it is. So let's keep on going. 31. 31. 32. 32. 33. 33. And 34 should be the last thing, right? And if you look at 34, it is, in fact, P5D 1OGL. So that's good. So now the next part is, so we did libchan top. We got all this cruft down here. We're not going to worry about that. Let's just... so let's look at libchan bot. Alright, so here we have... Let's look at where this was inserted. So it's inserted after FileBoy, right? So here's FileBoy. So let's take these macros for FileBoy, and we'll copy them down here. And anywhere we see FileBoy here, we would just want to replace it with PHEXDUM, right? For PNG hex dumper. We don't want to forget this one. I often forget this part. I'm getting better at that. Okay, so now that's in there. And this is just a redundancy to make absolutely sure we don't screw things up. So we'll take this cluster of macros as well. And we're going to paste this right here. And this FileBoy is going to be changed to PHEXDUM as well. PHEXDUM. And PHEXDUM is going to be 6, right? So we're going to take all these numbers here. And we are going to... cut these. And then we're going to go up here and we're going to paste them right here, right? So I'm a little overdue for... Oh, actually, that just worked out of the box kind of nicely, didn't that? Did not expect that to work so well. Okay, you know what? So... Right, and this is 34 now, right? This is 34. So we got 5, 6, 7, blah, blah, blah. This is PHEXDUM, right? So we're just a little redundancy to make sure that all of the system numbers match up correctly. Okay, so we know that PHEXDUM comes after FileBoy, so let's look in here. We got FileBoy. We'll duplicate this. And then we got to shift everything up, right? So this is going to be 34 now. And let's make sure that the numbers make sense. So FileBoy is 5, PHEXDUM is 6, native key is 7. That's good enough for me. Free spot is 20. Yeah, so a little spot check. That makes sense. Okay, so I'm satisfied with this. Let's kind of move on to the next file. So F macros, bottom and top. Let's look at the bottom F macros file. Also, that just made me realize we need to actually look into the main function file stuff here. And we're going to have to modify... We already have to modify the file we cut and pasted in here, right? Because we have to initialize the library. It doesn't really need an initializer, right? We have a init none function. We need to use an init none function on that, and let's kind of look for where FileBoy is and see if, like, FileBoy underscore whatever the heck. Let's find that and see if we can find... we can't find that, can we? Backwards direction... Okay. So this may be kind of like... Right, we have all these kind of init functions. So we should kind of like work on this a bit here. So we got silence, kill test, reentrant, whatever the heck, reentrant test runner, which isn't actually going to be made. We got to-do man, and then we actually need FileBoy has we're going to add a init none for this. F macros, FileBoy, init none, and then we're going to say F macros, PHEXDUM. Right, so I didn't fix everything, but the idea is there's some missing init nuns in here. right? We're gonna start to add these ones, right? So after to-do man, we need fileboy and PHEXDUM, and they're just gonna be init none functions. And fileboy is 5, and then we have 6. So 4, 5, and 6. We can make a note of that. So now it's kind of like supported in here. So we got fileboy and PHEXDUM that we need to look at. So when we look in here, we know that there's going to be a init none for that, and it's after to-do man, right? So we can duplicate this twice, and we can say, oh yeah, we need fileboy and PHEXDUM. Let's close this up for a second so we can kind of steal these like this. We can just go right here. We can say, right here we need fileboy and PHEXDUM init none functions, right? And we're undeffing those. I shouldn't have looked at the bottom file first like I did, but I did, so oh well. So let's look at the top file, and in fmacros top, we are going to have to change all these numbers, right? So we edited number 6, we edited, right, the insertion point was right here, so that means that everything past this point, 6 here, has been incremented, right? So CPU NIFO is going to be 18 now. So if we look at 18, right? So all these numbers here just need to be incremented by 1, because everything got split up, right? So I'm not really sure that I like these little checks here, but I'm just going to kind of keep them because extra checks are nice, I think. Though I'm not sure if I'm a fan. I don't know. For now, let's just not rock the boat. Let's kind of keep it the way it is for now. So tau sync, is that number 32? Yes, it is. Tau depot is 30. Tau depot is 30. Graquad is 19. If you look at Graquad, 19. So that's good there. So in our init nuns, so are these init nuns? Yeah, these are our init nuns. And after to-do man, we got to go duplicate, duplicate. And we are going to make init nuns for fileboy and PHEXDUM, right? So right here, we're going to say right here, fileboy and PHEXDUM, you need some init none functions. Let's get those, right? So let's take the source code here. Let's take all this code and copy it into the clipboard. And all of this stuff here, we're going to just rebuild it, right? So I'm pretty trustworthy of that I have done this many times and that I'm consistent enough that I'm not even going to check it, right? I'm just going to do farc, and I'm going to assume that we're not missing anything from that list and everything is rebuilt properly, right? I'm not even going to waste any extra time spot checking this because I've done it so many times that I have a lot of confidence that my script for auto-generating this stuff is it just works. Now, it does kind of suck that I'm doing a little bit of cleanup here, but it's not as time-consuming as individually checking this list and making sure that this list is correct. I am fairly certain this list is correct. Okay, so now that we have these in here and we have the init nuns for the f macros, the next thing we need to do is, well, we actually have to create those functions, right? So we're calling them here, so that's good, but they don't actually exist yet. So we need to actually open up the fileboy for a second. So fileboy functions. And let's just look at what we got here. We got this info print string, private recursive, make directory, whatever, touch file, file macros bottom. This was like a horrible, this was just a horrible thing that we just need to not do. So let's just add this somewhere. So halt is typically the first thing. Then we have this like info string function. So let's just do init none paste, right? So we're gonna paste a init none function here. Doesn't need to be fancy. It's just gonna be called fileboy init none, and it's not gonna do anything, right? It's just a do nothing kind of function, little placeholder. We can keep it kind of small and compact. We could, yeah, I mean that's good enough. Let's not. We could make it a little bit more compact. We've done this enough times where I really don't care. I really don't care about this function being very readable. It just needs to be kind of like stubbed in there to where I know where it is. Right? Yeah, so that's fine. That's fine if we make it compact like that. And then we can also kind of steal this init none function from here. And we can also put it into the library we cut and pasted into here. So in the function file, we can look in here, we got halt, we got log after halt, and then print info print string or whatever, and then right here, it seems like a good place for the init none function. So let's say PHEXDUM init none, and that's good enough for me. Okay, so we think we have everything kind of in place to where we're going to be able to compile. Now, I don't know if that's true or not, but we're about to find out, right? So let's just take this, and let's just double-click this and hope, fingers crossed, that we got everything. I mean, very rarely do I get this the first time, so... silence.phexdum, huh? Did we even stub that in? I am kind of surprised that... I'm going to guess that I had some type of define in here that kind of caught that. Oh yeah, so if this is defined, then we're actually... Else we use this standalone, right? Okay, so I did kind of make a concession for... This is only included in that C11 file for when we were compiling PHEXDUM as standalone. So we did make concessions for this, right? So logging is on, depends on what this is set to, right? But we also have... but it's a little bit more complicated than that, isn't it? So if we look at how we use silence for a second, doesn't silence have like an override? Or it has some way to... If we look at silence.d, right? I think that silence is all if turned on, right? So if this is turned on, then everything gets silenced. We're never going to want to turn on everything. I don't think that's ever going to be useful. So let's just make a note here that if AAC 2020, AAC 2020 silence dot silence, then right. So this is override turns off logging for all systems. Right, so this is the override that turns off logging for all systems, right? And so logging is on equals 0. Okay. Now, why did this not compile, though? Because here we are. Oh, yeah, it doesn't. It's not here because we didn't include it in here, right? So if we look at our list, to-do-man, fileboy, and PHEXDUM, right? To-do-man, fileboy, and then PHEXDUM needs to be added in here, right? So U08 PHEXDUM. And has logging stuff been added here? Has silence code been added? Yes, indeed. We just kind of like added that silencing code in there. And PHEXDUM, because it is a new system, so to-do-man, fileboy, and PHEXDUM. To-do-man, fileboy, and PHEXDUM. Since it's a new system, logging is going to be turned on. Anytime it's a new system that we've just added, we're going to make sure that the logging is on. And then as things kind of stabilize, and we're no longer interested in the messages we're seeing from it, we'll turn the logging off. But right now, we're going to keep the logging on for this system that we've just kind of shoved into the codebase. Okay, so now that we have that, it's time to give it another go, see if we can get this compiling, see if we forgot anything. I think that we're probably pretty good here. I think, right, because it just complained about this. Yeah, so that, it was tedious, but we didn't make too many mistakes, so that's pretty cool. P key for the data. Okay, so now, I think that the next phase here is to create kind of a build system with this, right? So we have this as a we have this kind of ready to go, but if we want to use this library as part of the build system, we're going to have to compile it as a standalone. So let's look at that init none function and make sure that that didn't wreck anything for us. Yeah, that's not going to wreck anything for us. That's fine. But we're going to have to look in our build script, and we're going to have to edit this build script to compile multiple executables. So things are starting to get complicated. So we got this kind of GCC command. Let's not make it too complicated. Let's so this is pre-processing. So since we're going to compile the same code, let's not get too complicated with the this GCC command, right? Let's do like GCC-XC. The code is going to be called I don't know what it's going to be called. Let's look in here for a second. Let's see, where are we going to put this, right? So I don't really want... so I'm thinking... I don't want to keep too many files up here. So I'm thinking lib.exe. Okay. And... then I want to steal this PHEXDUM.c11 file. I kind of want to just steal this, right? So it will need to be re-edited, right? Because these dependencies are not kind of in the same area. But I want to kind of steal this, because this is the utility I want to write. So I'm going to copy this, and I'm just going to go new text document. I'm going to call this, you know, PHEXDUM.c11, right? And then in here, we're going to cut paste this, save it, and we're in the exe folder, right? So if we see these dependencies, that means we got to go ... to get into lib, and then we got to go ... right? So we got to go back one. We got to go back one to get to here. Then we got to go back one more to get to here, and then we can go forward into dependencies, and then we can grab these out, right? Now for this include here, PHEXDUM.d, right? So we're inside of, remember, we're inside of lib.exe, so we got to go back one to get into lib, right? So once we're in lib, we can grab the d and f files, right? So we just want to go, we just want to back out one to get the data file, back out one to get the function file, and that should work to kind of create this executable, right? So we're gonna use the build system to create an executable, and kind of like have a standalone compilation of the code so that we can run it as a command line utility. And then here we want to do /lib.exe lib.exe PHEXDUM.c11, right? So let's actually kind of indent this correctly, or not indent this correctly, but keep to the format that we have been using. So there's the file. .o is going to be object let's just call it PHEXDUM object file.obj. And then all these kind of things here, I'm not as worried because it's going to be, if there's any weird problems, it's going to be caught by this compilation here of the main project. So I'm not really worried about making this as strict. I just think we want to go like, you know, .std equals C11 and -m64, right? We're going to make a 64-bit executable. That's really the things that matter to us for this. The last command, right, is not going to be no line continuation character on the last command. So then we need to do this linking stuff, right? So kind of this linking and removing and all that stuff. Not exactly the same, though, because you don't want to remove this, right? We want to keep this here, right? So let's, I don't know, let's change the formatting around a little bit for funsies. Alright, so this is .obj this time. And we're not going to remove it, right? We're not going to remove this. And we're not going to call it exe.exe, right? We're going to call it PHEXDUM.exe. And we're not going to remove it either. We're not going to run it either. We're not going to run it. We just want to keep it as, it's like a component of the build system, right? So let's build system build create build system executables. Right, that's kind of what we're doing. So let's just create like a little section for that, right? So let's so now the build script is kind of getting complicated, right? So we're going to create build system executables, and we need this in order to use the utility to create some of the files we want, right? So generate GLSL code from C99 code, that's great. This is not the correct section, is it? Let's put this at the top because this section may eventually depend on one of our build system executables, right? So with that said, let's say 2-upper CMD, right? And Control-Z. Try that again. Copy 2-upper CMD. Okay, that's better. Let's kind of double underscore that, right? Make it a little bit more readable with this section. And this is kind of a main-ish section, so I think maybe giving it something like that makes more sense. Now we're getting kind of designy, but that's okay. Okay. So create build system executables. PNG hex dumper utility for embedding PNG file data, right? So we can make a note of what this is all about. And yeah, I mean, that's fine. So we just want to make sure that this script kind of works, right? So this output file is not quite correct, is it? Because the output file probably needs to be in the same kind of path here, right? So let's kind of do... file path, it's file path exe, right? The file path to the exe is this thing right here. And then what we can do is, this thing is going to be $$FIP-exe, right? We use the $sign to access the variable. And then we can do the same thing for, right, this output file. This is the object file we're using, but the output file right here is going to be defined by this, right? So FIP-exe. So file path to exe. 2/of. It's to exe or of exe, depending on how you want to read that. Okay, so I'm kind of ready to give that a whirl and kind of see if that works, or if we've kind of like screwed something up. Here's the C11 file. Oh, hold on. This is the source. Right, this is a source. We really want to think about it. File path input. File path output, right? If we really want to, instead of exe, calling it exe, file path input, right? We could call it source as well. But I think file path in and then out, right? So here's the input, here's the output, right? So in terms of transforming the data, we take a file, we take this data, and inevitably it gets converted into this, right? So that kind of makes the most sense to me. Then we have this intermediary PHEXDUM object file.obj. That's fine. Okay, I think I like that. I think I like that. Looks the clearest to me. Now we have file path input and file path output. No, I don't think I have such a thing for that. So let's do FIP in. Okay, so if we do something like this, FIP in. Yeah, so let's make a note of this. So we have FIP in and we have FIP out. FIP in, if we type it similarly enough, we're just going to correct it, right? Same thing with FIP out. If we type it similarly enough, we just correct it. Now, if we type it backwards, we're going to say, hey, you typed it backwards. So if we do in FIP or in FIP or in FIP, we're going to say backwards, use FIP in, right? And same thing for the out. So if we do out FIP or out FIP or out dash FIP, oops. If we do something like this, also make a note that, hey, you typed that backwards, you want to use file path output. And now we want to say, well, what do these mean, right? So if we do FIP in means, FIP in means, or FIP in means, or FIP in means any of these, we're going to say, hey, FIP in, what do you mean? It means file path input, right? So it's the input file. And then same thing for the output file. So FIP out means, FIP out means, FIP out means, and FIP out means. Okay. That is going to be file path output. And yes, I realize that input does not have two ends. The reason I type in with two ends is just the normalization of the style of my variables. Okay. Is there anything else that we're missing here for these variables that we've created? I don't think so. I think that's good. We might want to make a note of the video ID, right? So you might want to say, hey, this section at vid IID 0128, and the time is 3 hours, 51 minutes, and 42 seconds to be cool. Made FIP in and FIP out variables on date 2021 0208. So we're just going to add that in here so we have like a document of when these were created. So if we want to see the actual code we were writing at the time that we created this section of variables, we can actually go through here and be like, oh yeah, this section of variables was created on this day during this video, right? We can find all that, and that's nice. So let's put that back on the other monitor now that we've documented that. And now we really just got to give this a run, cross our fingers, hope everything works. But if it doesn't work, we need to... Okay, let's not worry if that fails. Let's just give it a run, just see what the heck happens. Because I am nervous, but let's just see what happens. -X after last input has no effect. Compilation terminated. So it looks to me like the first script kind of like failed on me, but it gladly did everything else. So let's look at this and say, oh, so this thing right here, we just forgot to include the we forgot this, right? The line continuation here. We can just do this to... Okay, so let's give that a run and see how that works. I know I'm getting a little bit too designy, I think, in here, but I don't know. Blame it on my art degree. Okay, so let's try that out. Okay, so we got a PHEXDUM.exe, so we're looking good here. Okay, so I mean everything's running. That's good. I mean, we press the P key. We got this pattern here. Okay, so now the next goal is, okay, we got this executable. So that's a problem, right? We got this object file here, and we wanted to delete that object file. So let's see why that is the case. Let's delete this object file right now, and let's look at our build script again and say, what the heck did we forget here? I'm going to guess we just forgot the remove, right? We use the object file here, but we don't remove it, right? Because we were like, oh, don't remove anything. We're done removing stuff. But we actually want to remove the object file after we're done using it. So we just want to go like rm, and then this object file, right? So let's just say rm, this object file. Now the object file is in a weird place, right? It's like in the root of the project, which is kind of like, but I see why. That's fine. I don't care. It's a little bit odd, but that doesn't matter. So we should probably, though, remove Actually, no, I'm not going to do that. Because that scares me that I might accidentally... If I screw the input and the output, and I remove the C11 file rather than the exe file, just have it overwrite. Overwriting should be fine. I think that'll work properly. Let's give that a run. Let's give that a run, see what happens. So let's give that another run. Okay. So now we're ready to kind of like integrate assets into the engine somehow. And honestly, I don't know where we're putting these assets. I think we should probably have a... If we're going to create a section of just hard-coded assets, it really kind of makes sense to me to kind of put that in its own library, right? Its own library section, right? Like, we shouldn't have kind of loose stuff. Like, we have everything else here. Like, the do one thing and do one thing well would be... hey, this is just like hard-coded assets, right? So, we could call it hard ass, right? Because that's 7 letters, right? 1, 2, 3, 1, 2, 3, right? Hard ass, right? For hard-coded assets, or we could call it ass hard. I think hard ass kind of like is better, just because hard-coded assets versus assets hard-coded. This reads more as English, and then also, it also is a, what do you call it? It's already a phrase in English, right? Like, you can call somebody a hard ass, and I don't know exactly what that means, but if we look at it for a second, if we look at hard ass definition, let's, maybe we should put this over here just in case we get something that's not safe for work. And if we look at this, right, it means tough and uncompromising. Right, now obviously the definition of this doesn't really match what it does, but it gives us kind of like an elaborative way to like remember what the system name is, if that makes sense. So I think that's what we're going to call it. And the hard-coded assets should be somewhere that makes sense. So we know that we want to use PHEXDUM to decode those hard-coded assets, and those hard-coded assets are the result of using PHEXDUM, right? So both of those facts really point to hard-coded assets should really be inserted right underneath PHEXDUM, right? Because they are the result. PHEXDUM basically creates those. So it makes sense for the hard-coded assets thing to be here. So we're going to copy this, and we're going to say, you know, define macro libchan order hardass, and this is going to be our new 7 hard-coded assets, right? Hard-coded assets, and that means we have to change all these numbers, right? So we got to shuffle everything around. And then we got a lot to do, right? So let's get to it, right? So let's kind of move everything up. Now we got 35 different libraries. So this 34 needs to be changed to 35, and great. So now we have to do all this stuff again. But you know, like I said, does it make sense to have a kind of library just for hard-coded assets? Yeah, it does. It does. It definitely makes sense to have everything consolidated in one spot. Right, because then the things from this assets folder can be hard-coded into this hard-ass library, right? That makes sense to me. So let's actually stub those in, right? So it's going to be hardass.f for functions, and then we also need a data file. So new text document, and we're going to call this hardass.d. underscore. And then we can kind of open these both up. And for the data, for the functions, this will probably be a data only system. we'll use PHEXDUM functions to decode hard-coded assets. All right. So that is my guess. So let's make a note. So it's 1:28. The time is 4 hours, 1 minute, and let's say 13 for, you know, just because unlucky numbers. Okay. So yeah, there's probably going to be nothing in here. Now, in this data file, we're going to have to use the build system to create this. So, use build system to create some right. So we'll need to figure this out. Yeah. But we know that we need, so even though this is going to be a data-only thing, we do need to have, like, init. We do init none paste. Does that work? Yeah. So let's just create an init none function for this. So hardass.init none. Because we will need an init none function for this, right? We shouldn't need anything else in terms of functions, or at least as far as I can understand right now. And let's close this note here. Let's close this script. Let's close this build file. So PHEXDUM, right? Let's kind of look at this and say, oh yeah, hard ass, and the logging is going to be on, even though I don't think we're going to have any logging code for this, but we want to keep a consistent pattern here. So after PHEXDUM, EO8 hard ass, right? And doesn't talk. Yeah, I would say that this doesn't actually talk, right? It's just hard-coded assets as far as I'm concerned. So we'll just keep it as a little asterisk, because it does not talk. So it's been added into the silence system, so that's good. So now let's actually look at what else we need to open up here, right? So in libchan, we need to open up libchan bottom and top again, so let's open that up. And then we also need to open up fmacros, the top and bottom, so let's open that up. So open that up. And then we also need to look at the main and open up the function file, right? So that's everything we kind of need. And let's just consult, let's close these, right? Let's kind of focus on the task at hand, and let's do one thing at a time. So this function file, what needs to change about this function file? Well, we have a section where we're kind of like calling different init none functions at before the window creation, right? So right here. And so we just want to duplicate this and say hard ass for hard-coded assets, and that should be number 7 in the library chain. We can check over on this file and say, is 7 indeed hard-coded assets? Yes, it is. So that's good. Then this is just the notes part, right? So we also have to actually call it, right? So we have to call it right here, hard ass. And we really should kind of keep this note here. Like this note here, it can also function as a checksum. So we might as well keep this here as well, so we can see 1 to 7 here, and we can see 1 to 7 here as well. So that helps us know that everything is accounted for. That's everything we need to do in the function file. So now let's go to libchan top, which is going to be the most annoying part of all of this, right? And we need to change this 34 to a 35, right? Because now we have 35 systems, and we're compiling up to the 35th. We're compiling everything. So we're going to duplicate this. We're going to go Control-D. We're going to change this to 35. And we're going to change this to 35. We need these numbers to match. And then we need to look for number 7. So look for system number 7, and we see its native key. So we're going to duplicate native key. Right? So we're going to duplicate this, paste it. Then we're going to highlight native key here. And before, this is our new 7. Hard ass is our new 7. So we're going to say, all right, we're just going to change that, right? And now we have to go through this painstakingly and increment every single number. Right, this is kind of a time sink that I would rather not have this time sink, but like I said, I want the code to be very easy to follow, right? And so this is dead simple and very easy to follow. It's just painstaking to change when you make insertions so close to the top of the list. So I absolutely hate this. I think this sucks, but I want to keep a build system that is as simple as possible to get the job done. And this annoyance is only going to be an annoyance when we're, like, adding more systems. If you're coding the library, if you are the one coding the engine, if you're me or you're somebody else on my team that's coding the engine, you have to deal with this problem. If you're somebody using my engine, you don't have to deal with this problem. So it's only a problem for me, but it's not a problem for my users. And so when it comes to my end user, yeah, I don't want to annoy my end user. I want to make everything as easy for my end user as possible. And this is part of making things easy for my end user, like making things as unabstract as possible. So I think I screwed something up here because I typed over the same numbers. Let's look at where pixload is for a second. So pixload is 28. So pixload right here should be 28. So somewhere in here I made a screw up. So we're going to highlight this. And we know that this needs to be 28. That means this is 27. Okay, that means that this is 26. 25, 26, 27, 28. Okay, so we fixed that. So this is now a 29 for poly OGL. Yeah, 29. And this is 30. Right, so we're going to keep on going through here, changing all the numbers, and then if we think we made a mistake, like we're like, I think I did something stupid, then we'll spot check, right? Or we'll spot check every once in a while if we feel like it. But this is pretty mindless, but it is easy. Like, you can easily lose your place while you're scrolling through here. So it is easy to make very stupid mistakes, and that's why I have redundancies in place in case we screw up. So 35 is the P5D 1 OGL. Okay, so now we're going to go look for system number 7 once again. And it's this native key right here. So we're going to copy this and paste it, right? Because this is where we need to refactor. And the second chunk of native key we're going to keep. But the first section here, we've inserted hard ass above it, right? Hard-coded assets. And now we need to change these numbers, right? We just got to say, hey, that's 8. That's 8, right? And then we just have to do this mindless, painful, one thing at a time. So iMouseBox. Is iMouseBox 10? Yes, it is. Okay, so let's keep on going. 11 and... Ooh, I almost made a mistake there. 12. 12. iKeyless. 12, yep. Let's kind of carefully scroll up. Start changing some more numbers. This sucks. I hate this. I hate this. But yeah, we're going to keep on going through here. And we're going to painstakingly put everything in here. And the hope is that eventually, the hope is that we're not going to have this factorial increase of work that we have to do every time we add another system. We're hoping that eventually the beginning parts of the system are going to stabilize and we won't have to make insertions so close to the top of the list. That's the hope. That's the ideal. The ideal is that eventually it won't make sense to insert new systems so close to the top of the list. But we have to insert things where they make the most sense, even if that means a lot of work. So pixel backup, is that 25? Yes, it is. Okay, I'm just double checking because I kind of thought I lost my place. So 26, 26, 27, 27, 28, 28, 29, 29, and now this is going to be 30. And this is also going to be 30. Okay, 31. So let's make sure that 31 is the correct thing. So Tau Depot. Is Tau Depot 31? 31 is indeed Tau Depot. Okay, cool. So let's scroll up here. 32, 32, 33, 33, 34, 34, and then 35 is the last thing, I think. 35, yes, 35 is the last thing. Excellent. Okay, so that sucked. I hated that. And let's just close this. Let's hope that we just got that correct. And now let's go through the bottom file of libchan, which is going to be a little bit easier, right? We just got to look for system number 7, which doesn't exist yet. So let's look for PHEXDUM and native key, right? So PHEXDUM right here, we can just duplicate PHEXDUM. And then wherever we see PHEXDUM, we're going to change it to hard-coded assets. Right? Because hard-coded assets is between PHEXDUM and native key. Okay, now the next thing we want to look for is we want to look for the cyan and the purple in another section, right? Because we should have it here. So we want to make another insertion here. So we're going to copy these macros, and we're going to paste these, and here's the thing we want to insert. And so this PHEXDUM is going to be changed to hard ass for hard-coded assets. This number is going to be overwritten. We're going to shuffle everything upwards, right? So we're going to take all these numbers, column select, and then we're going to go scroll back up, and we're going to column select over that X. And remember, there's one slot missing, so this is where we want to paste. Control V to paste. So all the numbers have been split up. And now this is our 35th system, P51OGL. And so now that's inserted to a place where it kind of makes sense. Now, we have this tail order fails, and we were kind of like trying to make this easier to insert things in the future. So let's kind of fix this. So let's just call this, oh, I see why we did this, because it's kind of nicely aligned. This is nicely aligned with this. So if we try to change this, we just end up with problems here. Well, we could, if we really want to do what I'm thinking, we could go here, actually, we could do this. Let me think about this. So what we could do, I see what I'm trying to do here. So right here, we could add a little bit of space. Right, we could go 1, 2, 3, 4, right, which is kind of, not sure if I'm feeling that. But if we do that, then we can kind of put comment characters right here, in between here. And I know that I was originally going to do this a long time ago, and so now I'm just feeling like doing it now. And this is just to make it a little bit easier to cut and paste and edit this list of numbers in the future, right? This makes it a little bit easier on our column selection if we can see what the heck we're doing. Now, I realized for a second that sometimes we have these 2-digit numbers, so I'm going to take back what I just did. We want 2 dashes. I don't ever think we're going to get above... I don't think we're ever going to get above 99 systems, but we could, but let's pretend that we're not for now. So let's change that around for a second. And... Alright, so we just want this to be a little bit more friendly to our cutting and pasting that we do, our column selecting that we're doing. It is kind of hackish, but, you know, might as well do this now. So, I've been putting it off, but we might as well kind of, like, add this, because it's going to make our lives a little bit easier, because we do come back to this file quite often. And so we are assuming that this project will never get over 99 subsystems. Now, you know, we're like almost 1/3 the way to 99. Oh, actually, we're more than 1/3 of the way, right? Because we got 35 and 33.333333, right? 33 and 1/3 would be 1/3 of the way. So we're about, but yeah, we could say we are approximately 1/3 of the way to 99 subsystems. So I say that, you know, we'll probably never get 99 subsystems, but if we keep on this trajectory, right, and we're only a year into this code base, so if we keep into this trajectory for 5 more years, or even if we keep in this trajectory for 2 more years, we'll probably have more systems than we have. Yeah, we'll worry about that when we get to it. But yeah, hard assets is 7, 29, just spot checking here. 29, poly OGL, 35, P51 OGL. Yep, okay, so that looks good. And then, remember, it's between native key and, when I inserted this, I was stupid. So let's kind of unstupid ourselves here. So it's FileBoy, let's look at this code. FileBoy PHEXDUM hardass. FileBoy PHEXDUM, and then hard-coded assets. So 5, okay, so let's check those numbers, right? Let's check the 6, 7, and 8. Right, is 6, 7, and 8 correct? So if we look at 6 is PHEXDUM, hard-coded assets 7, native key is 8. Okay, so that makes sense. Good. So how about here? Did we make this? Did we do this right? FileBoy, PHEXDUM, and hard-coded assets. And then native key, right? Yeah, that looks good to me. Close that. So let's look at F macro's top, I guess. And once again, we have inserted things very close to the top of the file, right? Also, did we do the silence class, right? Did we add silence in here? Yeah, hard-coded assets is here, and it's here. Yes, we did that. Okay, cool. So once again, all these things needed to be incremented by 1. So CPU, uniforms, right, 19. So this needs to be 19. This 19 needs to become 20. And these are just like little spot checks that I'm like, maybe I should remove these spot checks, but I do like the extra like little safety that I get from these spot checks, so that's why I haven't removed them yet. Okay. So now, once again, we have this list of init none functions, and hard-coded assets is another set of init none functions we need. So if we look at this library chain, we can see, where are you, hard-coded assets? You're right here, between PHEXDUM. So between PHEXDUM and is this init none? Yeah, it is. Does the native keyboard have an init none? Let's go look at the native keyboard for a second. If it has an init none, how about an init? Does it have an init then? So there's no init, and there's no init none. So let's look at it. So this is just like a function-only file. So I get why it doesn't have anything. Let's do paste init none. And then let's just add this, right? Native key init none. We're just gonna throw that in here, right? So basically, this this system itself is just like a function, right? It's not really much. But while I'm here, I might as well say, you know what? We have PHEXDUM right here. Then we have hard-coded assets, and then we have native key, right? So FileBoy, PHEXDUM, hard-coded assets, native key, right? FileBoy, PHEXDUM, hard-coded assets, in native key, right? So we just want to say, hey, you know what? We're going to make some more init none functions. So we're going to copy all of this code here to rebuild our init none conditional function wrapper thingies, whatever you want to call these. And we're going to just nuke all of this. We're going to nuke everything between these orange sections. And they're just going to run fork on this and rebuild this list. Unfortunately, my script kind of leaves these spaces here, which is kind of annoying, but it's not too much to deal with. But it is getting kind of annoying because this code is getting to be quite a lot of boilerplate, and so this is starting to become a nuisance, I think. But okay, so that looks good. So we rebuilt this, and F macro's top, F macro's bottom. And we also need to, so we have FileBoy, PHEXDUM, and then hard-coded assets and native key. So we want to duplicate this twice. And then let's close this up. Let's close this up so that we can just take hard-coded assets and native key. Because it's going to go right here. Hard-coded assets and native key. Inserted there. And we're just undeffing them, right? So it's not too consequential. If we screw this up, it won't affect our compile, but it could affect people who are using our library. So we still want to be careful about it. So now that we have that, native key.f, let's close this. F macro's top, we kind of already edited that. Let's look at this, make sure everything is, yeah, we're good here. The last thing we've kind of missed here, let's save this. The last thing we've missed is that we want to look at the function file again. And we want to make sure that all of our new init function, oh, wrong thing. This function file. I want to look at this function file, and we want to call these new init none functions that are happening before the window code. So we have PHEXDUM, hardass, and then we decided at some point that we wanted to add a native key, right? We wanted to add native key here. So native key is that system 8. Native key is system 8. Silence is 1. FileBoy is 5. FileBoy is 5. Okay, cool. That's all we got to do. So duplicate this, and we're gonna take this. Right. Okay, cool. So now, what I'm seeing here is I'm seeing that this control F help is not all-encompassing, where we are missing something here. So let's kind of like put the same comment here, and then let's take these F macros, right? So so this is just a section for, we've changed the namespace on these, and so searching for these functions, we're never going to find where they're actually called because of the indirection from using these macros. So that's why we have this here, so that using Control F in the code base, we can kind of find what we were looking for, right? So let's, I don't know what the number on these needs to be. Let's change that to 8 right there. So little checksums. So we got 1 to 8 here, 1 to 8 here, silence to native key, silence to native key. Okay. Is there anything else in this file? No, that's all we needed for that. Let's see if we can compile this. Let's see if we have everything, if we've done everything correctly. What am I working on? Yeah, so let me give you a, hold on, I'm going to give you a quick tech demo. Let me just compile this. Okay, so I'm going to give you a quick so first thing I'm going to do is I'm gonna send a demos page to you. All right, so you asked me what I'm working on, right? So what am I working on? So the Markham. Let's call you the Markham because that sounds about right. Unless you want to correct me on that pronunciation. So actually, have you seen my tech demos before? Demos. Because that's gonna change how in depth I get. Because if you've already seen those tech demos, that's correct and no. Okay, yeah. So we're gonna go into the tech demos and show you what that's all about. The summary. If you want the high level overview, bitch. are you familiar with auto tiles? Because that's also going to be, right, I have to kind of know what you know so that I can describe things at the correct level of granularity. Like, okay, cool. So auto tiles are self-aware tiles. Are you familiar with the concept of tile-based games, like in old school? Are you familiar with the concept of tile-based games? I just want to see. Nope. Okay. So this may take a little bit longer than usual, but we'll get to it. So, let's find some things that aren't mine, but can kind of like describe this pretty well. So let's see if we can find Zelda tile map OpenGL really quick for you. So I have a shortcut file where I put like all the reference material. And anytime a shortcut that I'm looking for does not exist, I make a synonym for it, because I know it's in here somewhere, it's just not under what I type. So Zelda tile map, actually it might be under that. Yeah, so Zelda tile map, OpenGL. So I am going to find, I'm going to date this. So I have a master shortcut file where, like, anytime I touch a piece of data, and I want to reference it, like, in the future, I make, like, little shortcuts so I can find things easily. But it looks like Zelda tile map URL is what I want to find for you, because it's going to give you an introduction to what the heck I'm talking about here. So let's see, Zelda tile map URL. So I'm going to throw that in there because I think my shortcuts just... Hold on. Zelda tile map. So sometimes my shortcuts don't work properly. Well, that's not what I wanted. Okay, hold on. I'm going to find this for you. I swear I'm going to find this for you. Zelda tile map. Okay, so I know it's somewhere in my shortcuts. It's somewhere in my shortcuts, but I need to just look through here a little bit more thoroughly. So this shortcut that I made doesn't actually exist, but I know if I look for the word Zelda, and I look down in my shortcuts file, I'm going to find this for you. It's somewhere in here. I know it is. We're going to find it. Zelda tile map.html. That's probably the blog post. This thing might be the demo that I want to find. So I'm going to copy this and see if this is what I'm looking for you. So it's weird that, you asked me what I'm doing, and I'm going to show you other people's stuff first. Okay, yeah. So I'm going to give you this. First, because this is going to introduce you to the concept of tile maps. And so so in a game, like in an old school game, like an old school like RPG game, the way this is rendered, right, is it's not rendered, like every single asset here on this thing is composed of like little tiles. Right, so so the easiest thing is like this flower here is probably one tile, and we could kind of see like how many. If you look at the screen, it's probably like a 16 by 16. This looks like it's probably 16 by 16 pixels for this tile. So everything that you see here is probably composed of kind of jigsawing together a whole bunch of 16 by 16 tiles. So this big image here is probably like it's probably 3 by 3, 16 by 16 tiles that are fit together, right? And so you could think of this tile map, this is a tile map, and it's basically just a big jigsaw of a whole bunch of pre-made 16 by 16 pixel graphics. Now, it doesn't have to be 16 by 16 pixels, you could use other units. So let's find maybe a more interactive demo of what this kind of means, because just keep in mind that everything you see here is rendered in tiles. Okay, so let's find. Well, actually, before I'm gonna put this into my notes really quick, right? So, because I couldn't find that immediately for you, so I'm gonna go into my notes file, and I'm going to just say, hey, this thing here, that's what I'm looking for. And then maybe also Zelda tile map URL. Okay, so I'm going to put this on my other monitor now since I found what I was looking for. And let's say rule... Let me see if I can find the rule tile video. Rule tile video. Not what I wanted. So now I'm going to go back to my shortcuts and try to find the rule tile video for you. Rule tile video. Rule tile video. Auto tiles explained. So this is what I want. So I'm just giving it another, I'm giving this shortcut another alias, but that's what I want to show you. So I'm going to drop that in the chat as well for you, so you can take a look at that on your own as well. But I'm going to give you, I'm just going to go through the irrelevant part of that video really quick.
What you're looking for, then you can stick around.
Let's rewind a bit.
But if this, then you can click automatic tutorial. This.
Okay, so a rule tile is another name for an auto tile, and it is 16 graphics, 16, in this case it looks like they're probably using 16 by 16 pixels, so you could say it's 16 little 16 by 16 pixel graphics, and these 16 graphics are used to create one, you could say, material, right, like one material in your game, in your two-dimensional game. And the tiles, the subtiles of an auto tile set are self-aware, and so they, well, just look at it. So
is going to look like. All of the tiles will automatically update. If this is not what you're looking for, then you can click away from the video right now. But if this is what you're looking for, then you can stick around.
So as this person is using their tile brush, the correct subtile is selected, right? So you could say that each one of these cells here is the same material or the same auto tile set, but it's the same auto tile set, but it's a different subtile of that auto tile set. And we select the correct subtile in order to get this nice little boundary around here. Now, when I was showing you this Zelda tile map here, this is probably not using auto tiles. Like this dirt texture, that actually might be an auto tile, but the tiles used to, say, create this house, probably not auto tiles, right? Tiles for this water, probably not auto tiles. The edges of this ground, that possibly could be auto tiles. The grass texture here, that could possibly be auto tiles. These little bushes here, probably not auto tiles, probably a single graphic rather than a set of 16 graphics. Okay, yeah, cool, I'm understanding. What's the reason for this type of render? Arg, usually it looks like Minecraft glass, merge when connected. Yeah, it merges when connected, yeah, so that's exactly. So the reason for this type of rendering is to reduce the amount of, well, there's two reasons. One is it reduces the amount of, so two reasons. One, reduces the amount of work the artist has to do to draw levels, right? So they don't have to individually select they don't have to individually select and match everything together seamlessly, right? The artist can just select one material and they can just kind of draw with it as a brush. So that's the first reason why you would want to use auto tiles. The second reason, it makes for nicely destructible levels. So I'm gonna explain that to you. I gotta go find my source code for that, or my source explanation, whatever the heck. So AAC 20 Old Atomic Alice GIFs. I'm gonna see if I can find this for you. Let me update this for a second. So Old Atomic Alice gifts. Old AA gifts. AA1 gifts. Old Atomic Alice gifts folder. So now I'm going to show you the second reason for, like, you're asking why would somebody make auto tiles? What is the usage for said auto tiles? So let's go into this folder where I have a whole bunch of screenshots, and I'm going to change the display. I'm going to change my view here for you really quick. So let's see. This should be GIFs Windows slideshow. Okay, so let's do this, and I think this will hopefully work. So I'm going to select, oh, got more bash scripts, hold on. So let's just select one of these and make sure this looks correct. Okay, yeah. So here's this old game I made, and you see we have these bombs, and these bombs are kind of like blowing up the level, right? And as the level gets blown up, because all the materials are made with auto tiles, everything kind of like snaps together nicely. So if we weren't using auto tiles, when parts of the level got destroyed, if we were not using auto tiles, it would almost look like someone went into MS Paint and just deleted something, right? So let's, and what do I mean by that? So let's, screenshot this for a second. So let's screenshot this and say, let's just select this. And then let's say, file, I'm gonna save this somewhere and open it. So, if I can figure out how to, my dual monitors doesn't really like the way I do things, so I'm gonna save this as AA1 screenshot.png. Okay, so let's let me show you some more of these before I go into it. So I made this bomb game, and right, there's bombs that have different directions, and they like blow stuff up, right? So they blow stuff up, they create these kind of like chain reactions, you have to get out alive, right? That's the basic premise. The bombs are like proximity mines, some of them. The skulls are instant kill bombs, so you cannot touch them because they immediately explode, but other bombs, they have a little bit of a delay before they explode, right? So you touch them to activate them, and then after you activate them, you have to figure out how to avoid the chaos that is to come, right? And you have to get to the exit door, right? So you touch the bombs, then after a while they explode, right? So, like this level, right? So we have these bombs, we touch them, after a while they explode, and you just have to avoid the explosions that you are causing. So you don't have a weapon or anything, you just have to maneuver through the level and not die, basically, which I thought would not be a fun mechanic, but then I played Clock Tower a long time ago. Clock Tower is a really fun game, and basically you just kind of run from a serial killer, is kind of how the game works, and I thought, hey, this is actually a fun game. Despite not having a weapon, it's actually a really fun kind of game. It's kind of like, it's almost like if you were playing Metal Gear Solid, except you just never had a weapon. That's kind of how you could think of it, Metal Gear Solid with serial killers. Metal Gear Solid with serial killers and no weapons, right? That's kind of how I could describe Clock Tower. So anyways, right, you got this destructible geometry and whatnot, chain reactions, explosions, all that good stuff. So I am still answering your question of, you know, what is the reason for this type of render? So let's go into that, and one more explanation before, well, this is more of a demonstration, right? I've already explained point number 2, but this will kind of hone in on point number 2, if we can kind of like, open up this file and, oh god, did I just close it? Okay, hold on. So let me open up the screenshot I just took. Hold on, looking for it. It is desktop, delete me, AA. Okay, so here's this screenshot here. And when this material got blown up, right, when this material gets blown up, it leaves these nice edges, right? And so let's say that we didn't have auto tiles, and we tried to create like a self-destructing material. Let's say that we didn't have auto tiles, and we were trying to implement some type of explosion game where stuff is blowing up, and what would it actually look like if we didn't have auto tiles? Well, let's say that a bomb explodes like right here, And so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16, right? And then 2, 3, 4, 5, 6, 7. Here, let me just... There we go. Okay. So, if we didn't have... and let's select like a black color. Hold on. Actually, nope. Anti-aliasing. We gotta turn anti-aliasing off here. Okay. So if we didn't have auto tiles, then when you blew up part of the level, right, it would look like somebody just went into the level map and just kind of like used MS Paint and just kind of like deleted that tile, right? And so if you just delete the tile, then you don't have the smooth edges around the material anywhere, right? See this brown border we have? That brown border is completely gone because instead of using auto tiles, we just deleted the tile, right? And now everything looks ugly, right? So since we have a lot of destruction going on in this game, we don't want it to look like somebody just went in here and manually deleted a tile, right? Because that just starts to look ugly, right? We want to maintain these nice borders so that the materials destruct in a nice way, right? Let me describe this one more way to you. So let's say, Doom, Chainsaw, Demon. Right? And let's look for an image of chainsawing a demon. Where, like, something that kind of emphasizes, actually, it doesn't necessarily have to be a chainsaw. Chainsaw, demon, let's put gore. Let's see if we can find kind of some of the... Okay, I can't find a good example. Doom rip demon in half. I'm gonna see if I can find, cannot find a good example. So here, let's go to, like, YouTube really quick, and let's look at, Glory Kill, Doom Eternal. Let's look at Glory Kill Doom Eternal really quick and see if we can find what I'm looking for here. So there should be, actually, if you split them in half, that would be probably, nope. Okay, right there. Right there. Okay. Okay. Okay, so, internal detail right here. Where, like, when you cut this demon in half, and you make, like, you have, like, the internal guts kind of showing, there had to be some pragmatic way to create that, right? So they didn't just take the mesh. They didn't just take the mesh and split it in half, right? Because then there would be no detail there, right? So that's kind of the similar thing that we're doing with the auto tiles, right? When we're destroying parts of the environment, we want the details that are left behind to be plausible, right? So if we say explode a concrete beam in our game, and we break open a concrete beam, we want there to be like a rough concrete surface left over, not just a blank area left over, right? So you have to actually account for that when you're doing something like that. So, so that's kind of analogous to what's happening here, right? So you could think of this creature as like a tile, as like a few tiles, and then if we delete the tiles in the middle, we have to correctly auto-tile to account for what's left over on this edge right here and left over on this edge right here, if that makes sense. That's a little bit abstract, but that's the best I can do. So 1 minute and let's do 30 seconds. 35 seconds. 35 seconds. I just want to make a note of this. I thought it was 35 seconds. Oh, and time equals 1 minute 35 seconds, right? Okay, so I'm going to take that. I can put that in the chat for you as well. And, okay, so Doom cut in half, Demon cut in half, cut in half. Yeah, so hopefully that kind of explains it. So if I want to summarize what I'm talking about here, because I kind of like gone on a little rant. The two reasons, right? It reduces the amount of work the artist has to do. They don't have to worry about latching everything together painstakingly. And also, it just makes the geometry nicely destructible, right? The geometry, it just creates better destructible geometry if we can do these auto tiles. So let's actually go to our demos page. So let's actually show you the demos page and kind of explain what the heck is going on the demos page. So here is like an old prototype, or not an old prototype, but a very beta version of those GIFs I was... Oh, actually, here, let me... ooh, sorry. So I was on the wrong screen when I showed you those other GIFs, or the other images, so I'm sorry about that. But I gave you the links, so that can kind of... If you didn't see exactly what I was pointing to, you can see that. Here's the old game, right? And this is auto-tiling. This is also auto-tiling, but we're doing it with fancy shaders, right? So this right here, I can give you the link to this. The direct link to this is right here. So if you want to take a look at that. But this is auto-tiling. I'm just clicking here and laying tiles, and they're automatically snapping together in a pleasing way. And now you'll notice that this is not done with pixelated graphics, right? So, but this is still auto-tiling, right? So this is still the same concept of what I've been explaining to you, but instead of doing it in pixels, we're doing it with like fancy shader tech, right? And so the engine I want to create, I want to use auto-tiling, but that doesn't necessarily mean I want old school graphics. So I want to take basically like this old school auto-tiling concept, and I want to turn it into like a next-gen kind of an engine, right? So I want to use this kind of tech. But this is just one of the pieces of tech that I want to combine into the final engine design. So this is just one of them, right? So now if we want to zoom into this, let's try to zoom into this stuff right here, right? So this is not a pixel-based engine. So if we zoom in here, right? If we zoom in, oops, hold on, 256. Oh, I see. So if I zoom in, right, we can still see all this crazy, crazy detail, right? We can see just plenty of, like, crazy, crazy detail, right? And then we can also zoom out, right? So we can zoom out, and we can get this high-level overview of what's going on, and we can lay some more tiles of different types, right? But the idea is that it's auto-tiling, but just done with fancy GLSL shader tech, right? But that's not just all I want to do, because there's nothing fractal about this, right? I want to create a fractal auto-tiling engine. This is one piece of tech with how I'm going to render those tiles, but it's going to look even better than what you're seeing here. This is just a little proof of concept. So let's go down here. This is not going to be in the final engine. This is just a little game I made. This tech, however, is going to be in the final game engine. This is a tile map I made, a tile map engine that has multiple layers, and the layers can be blended together. Then, after you've created the tile map, you can apply rendering settings to the tile map. So this is the same tile map 3 different times with different rendering settings applied to them. So this is a foggy morning rendering setting. This is a sunset rendering setting here. And then this is starry night rendering setting. So it's all the exact same information, but rendered in 3 different ways. Now, the reason for this is a concept called data leverage. Now, I don't know if there's an actual term. That's the term I'm using. And basically what I mean is the artist only has to create this map once. But then with data leverage, we can just simply apply 3 different rendering settings to it, and now we've increased our artist productivity by 3, right? They didn't have to manually make this, manually make this, and manually make this. They only had to make one asset, and then we just applied 3 different rendering settings, and we get 3 completely different art assets, right? They are different enough that we could reuse them, and people wouldn't be like, oh, it's just the same thing reused, right? So we want to, when we're reusing artwork, we want to reuse artwork in a way that doesn't bore the end user, where they're just like, oh, that's lame, they're just reusing the same art assets, right? There's nothing lame about the difference between this and the difference between this and this are interesting enough that no one's going to accuse us of just being lazy and reusing the art asset, right? Because it looks different enough where we get interesting things, right? We notice different details here in the data than we notice from here or here, if that makes sense. So, AAA studios have a ability to just throw many brain hours at asset creation, right? Because they're a large studio, they can hire a lot of employees. And when I mean brain hours, I mean a human being is creating the stuff rather than a engine creating the stuff, right? Like a human being, an artist, actually had to create this data set, right? This data set, or this tile map, right? A tile map is just a type of data set, right? Everything is data. Right, because all this stuff basically eventually boils down to ones and zeros, right? So an artist had to manually assemble all these tiles and make this pretty piece of artwork. So I call it brain hours because a artist, a person, had to use their brain cycles to create this, right? And so as a small team, you don't have a lot of artists. So you need to make the artist as efficient as possible. And one way to make the artist as efficient as possible is to make an engine that intentionally is designed to help your artist be efficient. Okay, so here's the lighting engine aspect of the old game I worked on. Right, so this is very overblown. It may look like it's done in Unity. This was actually done in ActionScript, so it's like an old Flash game. Here is the preloader screen for that old Flash game. Here is a tile editor that I worked on in SFML and Golang. It's just a prototype for how I'm going to create the tile map editor engine. And you can see this demo on my main demos page, so I'm not going to go over it too much, but you can see there's like 16 different tiles here, and there's different tile sizes, and I'm just drawing a cool pattern, right? This is kind of fun, but it's not going to be in the final engine because this is triangle-based. The tiles I'm working on are squares, so while this is cool stuff, and this is really fun to play with, right, because you can kind of like click it, and subdivide these triangles, and it'll randomly pick a different color for you, and you can make these like crazy snowflakes, right? And then you can also click and drag, and just be like, woo, right? And you can click, drag, like this, and you can click, drag, click, drag, click, drag, and you can make these very cool kind of patterns here, right? So if you want to take a look at that, I'm going to put that in the chat for you as well. And what else did I want to show you? So that's the basic demo of like all the pieces of tech I'm working on. So once again, you asked me like, what am I working on? So to answer your original question, what am I working on? Okay, so that's the high level. That's the high level of what I'm working on. The current task. Okay, so the current task I'm working on is kind of crazy. It's embedding art assets into the C99 code by converting PNG files into hex dumps that can be embedded into C99 array literals. And that on its own is kind of crazy. And I'm going to just keep on doing it. And it may get kind of like, you know, now that I'm done kind of explaining things, everything is going to be kind of confusing. Like, right? Because this is like a very large code base, right? Where I have like all these different systems. I got like 35 different subsystems, and they're all like put together in a very particular way. And so don't feel bad if you have absolutely no clue what's going on. Yeah, so I've been working on this code base for quite a while, so don't feel bad if you don't know what's going on. Also, you know, I don't intend for anyone to ever watch my stream all the way through, just because it's a lot of complicated, boring stuff. But, like, every once in a while, I'll have new cool stuff to show, and when I have cool stuff to show, I will, like, message everyone and say, hey, I got some new fancy stuff to show people. Anyways, I was trying to build this code, and I forgot if I was successfully building or not, or if I had some type of mistake somewhere in the source code. So I gotta, like, figure out where I was. It actually looks like I am building this. Okay, cool. So this is the start of getting my rendering engine to work for creating my tile sets. And I need a better data set to render, right? This is a very basic data set. That's why the tile patterns don't look very interesting. And so I'm working on encoding a better pattern into the art assets. So if we go into our assets folder, I have this PNG file, and this is the raw data for one tile set. And you might look at this and say, that looks kind of crazy. How is this one of the auto tiles I was talking about earlier? And it is. It's just that it's kind of like you're looking at a raw data view. So the artist will never look at this. This is just what the internal data set looks like. And our tile sets aren't going to be old school graphics, right? So our tile sets are actually going to have like multiple layers and multiple tile sizes, or pixel sizes, you could say. So you can see these three big blocks of pictures. These three big pictures here are like the smallest tile sizes. These smaller tiles here, these smaller three chunks here, are tile sizes that are half the size of these tiles, and so on and so on and so on. It's kind of like a map-like structure used to encode the tile set data, if that makes any sense. Okay, so I'm trying to figure out how to get this embedded into the engine. And in order to do that, we're going to have to create some builds. We're going to have to edit our build script somehow. So we're going to go into this main build script. And, well, first of all, let's see what we got open here. Yeah, so let's go into the main build script right here. And, oh, actually, I did not want to run the build script. I wanted to edit it. So, oops. So we'll wait for that to... Okay, that's good. Okay, so we want to edit this build script and figure out how to, like, create our asset pipeline. So this is creating our build system executables. This is just like GCC to build this library called PHEXDUM. Stands for PNG hex dumper, right? So it's my hex dumping utility. And I'm compiling it right here as a standalone utility so that I can use it to create some source files in my main project. I need to create another section in my build script and say, generate So the way I name my sections in my code is I want to know when a comment begins and when a comment ends. I want to know the jurisdiction of a comment, if that makes sense. So this comment, when it's left justified, that's the beginning of the section, and when it's right justified, that's the end of the section. So everything that I write in here is going to apply to generate hard-ass PNG assets. So hard-ass is the name of the library for hard-coded assets, and it's where we're going to encode PNG assets. So we got to figure out what we need to write in here. I'm not sure what we need to write in here yet, but we know that whatever is going in here, let's open up the data file for this. So if we go into lib and we go open up the hard-ass data file, right now it's completely empty, and we want to get this encoded into our source code. So I think what we should do is we should say this is going to be called U32 and paint default data 001. Now, do we want to call it PNG? Technically, it is a PNG file, so we could call it PNG like that. And we could make a comment that okay, so we're gonna. This is actually coming from right. So we want to know the origin of this. This PNG file is going to be used to create this array. Okay, and we're going to say that in this array initializer, we're going to say .len, or len._, right? So this is going to be the length file, and the length file is going to be used to tell us how many elements are inside here, right? And how many and so to create this array, rather than creating like a whole bunch of data in here like this, we're going to point to a file that has like something like this in it, right? It's going to have a whole bunch of binary data in it that's encoded in UINT32s. So what are we going to call this? Well, I think we're just going to call it, you know, PAINT5D default data 001 and ARR for array, right? So this is the array, or we could call it so NAK, oh, also we want to include this, right? And /assets/ this thing here. Okay. So now that we have this, it's like, okay, that's cool and all, but let's kind of reformat this a bit. I'm not sure exactly how I want to format this, but it would be nice to kind of see this kind of lined up. So this actually needs to be an include as well. So include. So we have to kind of format this kind of weirdly because of these includes that are included into this syntax here. So we may want to kind of write it like this. That is ugly as heck, but sure. Okay, so let's get another level of indentation just so that we can kind of keep this, just so that we can keep this commentary right above this, right? So we're saying that this variable comes from this PNG file. So here's the length, and then here's the naked array that creates this. So we could just say let's just call this section, let's kind of name this section based on the data that I'm encoding, right? So so this is kind of very fluffy in terms of like it's not really saying too much. and we're using up a lot of room just to write this. But right now, if I use my token highlighting on this section here, on the section name, I can see all these tokens kind of line up the same, right? And so we have the PNG variable, we have the length file, and we have the naked array file. And there's one more thing that we probably want. We probably want a int32, and this PNG. We also want a number of it's not really number of bytes because they're uint32s, so they're actually number of pixels if we want to get specific, but they're not really encoding pixels, it's just encoding binary data using uint32s. So I think we could say number of literals or number of elements. I think number of elements makes the most sense. And then in here, we could say equals, and the number of elements is going to be this this length thing, right? And now it's length, it's not... Length could be mistaken for something else. It could be mistaken for the number of characters in the file. So maybe we want to say NOE here, right? And then over here, we could call this NOE, right? So right here, we're going to say include. And we forgot our quote mark, so let's kind of fix that. So /assets, because we're already in the lib folder, and it's lib/assets. Right, so that's kind of how we want to do that. And then number of elements, we want to include that right here as well. And that looks good to me. Now let's kind of like make sure everything lines up nicely. So let's do that, right? So this lines up kind of nicely like that. What else do we want to do here? I guess if we really wanted to, we could save ourselves a little bit of space. Like if we want to say, you know what, let's not kind of put that on one line like that. Let's kind of condense this a little bit. Actually, this include, I'm pretty sure we can't have these characters right here if we're going to use an include. I think the include has to have all of its stuff on the same line. I think that'll screw us up, so we'll have to indent like that. And this is kind of wrongly indented. If we're gonna, this would make more sense. Okay. Maybe we want to save a little bit of space. Maybe that's a little bit too fluffy. Okay, so I kind of like that. That looks good to me. So that's how we're going to embed. That's the syntax I want for getting this first asset embedded. So we could make an index. So we could make a section, variable name index. So variable name explanation index. We could make a little section here and try to explain what the heck some of these variables mean, right? Like maybe you're looking at some of my shorthand variables and you're like, I don't understand what the heck this person is all about. Like, why are they naming things in this weird way? Well, I can at least explain what these variables mean. And I do have a reason for why I do everything very tersely. I do things very tersely to eliminate the mental search space for the variables that I'm using. So NOE, number, stands for number of elements, right? And then we have, this stands for naked, most likely naked array. Right? And then ASS is for assets. And PNG is for PNG file. PNG equals portable network graphics. Right, so we can just make a little index of explaining kind of what some of these things are, so that when you're looking at no, PNG, and all that, and NAC, you're like, what the heck is NAC, right? Well, NAC, we define it right there for you. In case you're looking at this, you're like, what the heck is all this about?
Okay, so now that we have this, we gotta look at our build script, and we need to modify it to create these files that we're gonna need. So in here, we want to execute PHEXDUM. We want to go, PHEXDUM is going to be in, so we're going to go /, this is executed from the main folder, so we're going to go lib/exe/PHEXDUM.exe. And then once we have this, we're going to do some line continuation characters, because this is going to get kind of beefy. But we want the asset, right? So what is the asset we're going to compile? So this is the asset right here. So let's copy this name. So this is what we're going to take. And then we're going to turn it into a few output files. So this is the... also, we need to figure out what the command we're going to run is here. So it's going to be a PNG file converted to... convert to I don't remember exactly what I call it. I'm gonna have to go look at that for a second. I think it's called like let me open this up for a second. I'm gonna go look at PHEXDUM really quick and see what that command is called. So in the data file, I should have like a lookup table for the aliases for what I call this function, and I give it a lot of different names. I want to give it the long-handed name. So PNG file to naked text. Okay, so naked text or naked array, and then we're going to take this file, and we need to know, well, what are the output names? So the output names is, here's the naked array, or the naked text. And we're just going to label it ._ because I just don't want to deal with file name extensions for everything. And then we also have this. Okay, so this is how we're going to roll here. And so we're going to take a PNG file and convert it into a hex dump, basically. This is the PNG file we want to turn into a hex dump. This is the resulting hex dump. This is the number of elements within that hex dump. All right, and we're going to need all of that data to properly embed an asset. So this is the function we're going to run. And so yeah, we could say, we can also make a note, so this makes two things, right? It makes this number of elements, it makes this int32, and it makes this u32, right? It makes these two assets. We're going to get these two assets embedded into the engine by running this command, right? So we just want to make a note of what asset we're making so that we can kind of just roll with it like that, and we're ready to go here. Now, we have to make absolutely sure that we do not put any commentary over here, because we have this line continuation character. So we're just going to do that just so that we can not worry about that, and then kind of write it like that, right? So now we have this kind of like thing where we have the asset we're making, and then we could just say we could hashtag asset1, right? We could tag this as asset1, and then we could, I don't know how we want to do this. Here, like this. We'll make a little section here. This will be asset number 1. So this will be a subsection. And we'll call this subsection asset number 1. And looks to me like it makes more sense like that. Yeah, so asset number 1. I think it makes more sense like this, just so that we can kind of click it and easily see. This is asset number 1, and this is this right here is the command we're going to run
to create that asset. So let's give that a roll and see if this build system actually works properly or if we have screwed something up horribly. So let's hope this works. Let's cross our fingers and let's just see what happens, because I'm excited. I am excited to see this work. I'm hoping that I did everything correctly. We will fatal error. WTF am I doing? And it's coming from PHEXDUM, huh? Unknown type name, I32. Okay, so there's a few things that are going on here. There's more than one mistake. But let's just go find WTF am I doing for a second. And I'm going to guess that we're going to have to open up the function file for the PNG hex number. So this is very curious. Else, if file exists, oh. Okay, I see. So there's a few mistakes. Let's fix the first mistake in the build script. This needs to, these paths need to be into here, right? And so we're not doing that. We're kind of like going in the root directory. So let's kind of fix that. So we have enough space to where we can just hard code that and do, we should just be able to do this. .lib/exe .whatever .paint5, right? So we can just make the path relative to here, right? And I don't know if that'll work, because I have actually never tested my utility using paths like this. So we may find that this will just not work for us. So let's just give it a shot and see what happens here. It looks like we may have... WTF am I doing, huh? Well, that sucks. Oh, wait, hold on. So we edited this, and did we make more mistakes? So in order to get this working without having to change the code, we're just going to have to change the directory we're in really quick. So we're going to have to say save current directory bash. I don't know. So I'm going to make a little shortcut for that. So current directory break time. Okay, well, I need to make sure I'm in a stable state here. So you gotta hold on here. So save current directory. So if we look at current directory, it's PWD. Okay, well, hold on. Okay, so we're just gonna say that original directory equals this, right? And then what we can do is we can go cd dot slash lib slash assets, right? So we can get into the lib slash assets folder. And then from here, we can just invoke these directly, right? So something about how I did this, I didn't really do very good parsing for how we create file paths. So it needs to be, it can't have these other things on it. So we're gonna do this. And then after we do this, we need to cd original directory, right? So in order to get this tool to work, we're going to need to save the original directory. Then we're going to cd into the assets folder, and then we're going to run these build commands on we're going to run these build commands. But also what I'm seeing here, oh, and this has to be that if we're inside the assets folder, then this is going to have to be dot slash, right? Because now we're going to have to go backwards. We're in the assets folder. We're going to go back to exe, back to the exe folder, because right, exe is in here. Okay, so that should be what we need to get this working. It's not gonna fix everything, but I want to fix the build part, the build script calling part first, right? So we just want to get that part working. So yeah, so now we got this little hex dump craziness over here. That is a little bit bulky, like I might want to silence that, but let's just get this working first. So we can see that there is a mistake, and I know exactly what the mistake is. So over in here, we need to actually define what some of this stuff is, right? So I think what I'm going to do is, since all these assets are going to use the same type defs or the same defines, I'm just going to make a main section here for the assets and say asset type macros, asset type macros, something like that, and then also all PNG file assets. All PNG file assets. Let's call it that, yeah. All PNG file assets. And it's going to be everything inside this section will be PNG file assets. And then once we get this compiling, I have to take a break here. But let's so let's change these equals to like instead of equals, let's make them dashes, right? So we want a little line hierarchy going on here. And let's take this variable explanation index, and I changed my mind here. This is going to be at the outer level, right? So it's not going to be embedded into this section. So we're looking at our hierarchy of lines and our hierarchy of categories, and we're kind of reworking things and changing our mind as we go. Okay, yeah, so I like kind of how that's organized, and then that means that this section, right, is going to be a thinner line because it's a section within another section. You want to keep kind of a line hierarchy. Okay. Okay, so that looks good to me. Let's give the build script kind of another run here. Okay, so let's give the build script another run here and see if we can get this compiling, right? So the idea is, can we get this project compiling? int32, so we forgot one thing. We were in the middle of organizing our comments and forgot the most important thing. We need to define int32. We got to define u32 as well. And those are the two types we're going to need to encode like all of our assets. We're going to undef int32 here, undef int32, and undef u32 here. And we can create a little checksum here as well, and just say, you know what, we have two defines here, 1 and 2, and then over here, we want to undef exactly 2 assets. So we just want to keep a little checksum to make sure that whatever we define, we also undefine. And a quick way to make sure that we're doing that correctly is just to keep a running total of numbers and make sure this running total matches this running total, or this checksum matches this checksum, right? It's just counting them out to make sure that they're correct. Okay, so let's build this again and see if this will get everything running. So pedantic, that's just me getting screwed over by pedantic mode, so that's not too big of a deal. And now I think that this is going to work. I think we've gotten rid of... Okay, yeah, yep. Okay, cool. Okay, so now... Excellent. So we have... This asset is now embedded into the engine. And so how does that all work? So let's actually go into the folders here and look at this assets folder and see these new files here. So let's look at this naked array. So this is a hex dump, and this really sucks that there's all this redundancy in it. We're not going to worry about optimizing this, but this is a hex dump that represents the PNG file, right? So this hex dump here represents this PNG file. So this PNG file is turned into a hex dump, and then we include this into that array literal, right? So we include that into this array literal right here. So right here, this is where we're including it. But we also need, within the square brackets, we need the length of that, right? So if we open up here, we have a number of elements file, and if we open up the number of elements file, we see there are 4,674. That is quite beefy. So we want to avoid hard-coding assets if we can, or try to optimize this later. But the first part is just to get it working. We'll work on the optimization aspect later. But yeah, so now we're able to encode this, right? And I gave it the same name everywhere. So PAINT5D default data 001.png, PAINT5D default data 001 naked dot underscore, P5D default data 001 number of elements dot underscore. So I intentionally give it the exact same name so that we can look at all three of these and be like, they have the exact same name. I bet they are very related to each other in some type of way, right? So I have to take a break. So I'm gonna maybe get some food as well. But before I take a break, let's commit this, right? So we've reached a good point here. And I'm excited because we're about to get some interesting stuff going here once we get this working. So git add dot okay, git status, git commit dash am asset PNG asset embedding now works. Okay. And because this is a working commit, we can git push to GitHub master, but we can also push to Kanji Coder master as well. So we're going to do that once so git push, and then we're going to do GitHub, we're going to do Kanji Coder master. So Kanji Coder is the public repo, and I only push up to the public repo, which is in orange. Like if you look at the bottom right hand of my screen, in orange you can see github.com/kanjicoder/AAC2020. So if you want to take a look at the source code yourself, you can take a look at it. So I'm going to take a break. Now that I've pushed all that up, we're going to say a 16-minute break. Keep it kind of short, enough to maybe grab a snack as well. So let's go to our break screen, and let's find a little timer. And I'll be back in 16. So red timer. 16 minutes. Okay, so I'll see you when I see you. Just in time. Okay, so, I have some food I want to eat really quick, so, I'm gonna give this 5 more minutes, because I have food. So, I think 5 minutes will be okay to eat what I got, or 6, I guess. The moral of the story is, our first break was 16, and then we added 5. We went over our break. This is why getting up. Like, if you get up, like they say, like in an office that, you know, you only get like 3 hours. People only like really get 3 hours of work done in an 8-hour office day. That's not surprising, because if you take a log of like how many breaks you take, I would consider that a really quick break. Like, I was literally running around the whole time. I was like running upstairs, running downstairs, microwave swinging something, doing some push-ups. Like, it was not like I was being casual with my time. And here I am out of time. Let's make sure that all of our things are working here. So Samsung, okay, yeah, we're recording. Okay, so we have a way to get the assets encoded into the game, but we also need a way to get the assets decoded. We need to decode them and be able to dump them into memory slots or memory regions. So we're going to need another library in here. And I want to be able to load this memory. So this is PixLoad load from disk. I want to be able to dump pixels from the hard-coded assets. So I could call it PHEXDUM. We have hard ass. My girlfriend said it would be funny if we called it dump ass. So, like right here after pixload, we could have, this is load pixels from disk, right? So, if pixload is specifically for loading pixels from disk, we might want to put the dump assets here. So that way, we don't, we can never accidentally have PixLoad reference something that's going to dump from hard-coded assets that are loaded onto, or that are encoded into the executable. So I feel like I want that distinction. I feel like it would be a mistake for us to allow assets. If PixLoad, the commentary says load pixels from disk for PixLoad. So I don't want PixLoad to be loading assets that are encoded into the source code. That is a different jurisdiction. So I think that right here, let's duplicate this for a second and say that right here we want a thing called, it's going to be called, we have hard ass, right? This is going to be called dump ass, right? And dump ass is going to be used to load pixels from exe. So we might want to change this to from disk. So now when we click this, both of these line up. But this is from disk, and this is from exe, right? So we could say XM for exe memory. And then we could go into our documentation, and I actually want to create a, fake whatever the heck, fix this, fan service. We're going to make another folder here, a new folder, and we're going to call it, we're going to create a new folder. We're going to call it a dex or index, and we're just going to, like, each file is just going to hold one definition. So we're going to say, like, you know, XM, right? And then XM here is just going to store, like, what do we mean by XM, right? So XM, exe memory, right? So XM just means exe memory, and that's all we're going to do. We're just going to put that in there so we have a place to reference what do we mean by XM, right? And then also we might want to make a note over here in our big master notes file. XM means
xm means, and then we can say xm, xm, meaning data hard-coded into .exe file, right? So xm, if we have xm, we'll say, good, xm, it's all capitals. Because it's an abbreviation. And then if we do something like xm like this, we're going to capitalize it. And then we need to change this brace, we got that wrong. And then we're going to add a new system. Right, so I know we're kind of getting crazy with like adding system after system after system, but the thing is we really want to stick to the idea of do one thing and do one thing well. So the whole Linux philosophy of do one thing and do one thing well. Now, I don't know if we're abiding by that the best we can, but we're trying to. We're trying to keep everything very coarse-grained. But at the same time, every one of these subsystems need to do one thing and do one thing well. So this this dump ass thing, right? That means that this is now going to be our 29, right? This is going to be 29, and all these things get slid forward. So we're going to slide these. Oops, we're going to slide these forward here. And then this is going to be 36. So now we got 36 systems. Then we're going to go down here, and we're going to compile up to 36. And now we have a lot of work ahead of ourselves, because now we have to go into lib, and we have to go, okay, new folder. Oh, not new folder, my bad. Delete this. Yes, I do. Okay. New text document, and we're going to say dumbass.f._. And then we're going to say new text document, and then we're going to do dump_ass.d. So we got the function file and the data file for this. And then we're going to open these, and we're going to stub everything in. So this is probably going to be this is most likely a function only subsystem. Used to decode hard-coded assets in and load them into. Right, so that's kind of what we're doing here. Okay, so we have a little summary of what the heck is going on here. And we can take a note of the video ID. So it's 1:28, and the time is 6 hours, 2 minutes, and let's say 23 seconds to keep the conspiracy going. So let's explain this, right? So this is most likely going to be a function-only file, so we just made a note of that here, right? So dump_ass really is just going to have functions for loading data into our texture memory or our CPU side allocations that match the texture memory. So in here is where we're going to have our main functions, and we'll just say, you know, halt is typically first. That's probably going to tell me to use 489 paste, right? Yeah, so 489 paste. And then we're just going to say, let's say halt. And then what's the next thing? It's log is typically second. Info any paste. And let's just say, let's call that 101. And that might be kind of bad, because then we might look at it and accidentally think it's binary, so let's not do that. Let's call it 202. Or hey, how about 123? So we look at it and we're like, that doesn't look coincidental. okay, what's after comes after the log, right? So we have the log, and then we have paste init none. So let's kind of like make this a nice little payload here. So let's say AutoHotkey folder, and then shortcuts, SC files. It's an AA2, AAC 2020, snip, new subsystem boilerplate, right? So it's really called new subsystem boilerplate. So full file path to clipboard, and we'll just say, you know, right here we're gonna put in our shortcuts. We're gonna add that to our shortcuts. Say new subsystem boilerplate, or new subsystem boilerplate, or new subsys boilerplate, or plate. New subsys boiler, subsys boiler, something like that. And then pick NSS NSB paste for new subsystem boilerplate. NSSBP paste, right? NSSBP paste, NSSBP, NSSBP paste, and paste NSSBP, right? So this, so, because I know we do this a lot, so we might as well make a kind of thing for this. And we're going to paste that file, right? So, new subsystem. Now, if we do this, I'm going to guess we might have... Okay, so we have these. We're just going to say, hey, use if AAC 2020 library. All right, we'll make a note that, you know, we want to use this if it is this certain library. We'll tag this shortcut as for AAC 2020, right? Yeah, we'll just have that there for next time, right? Because we've been doing this quite a lot, we might as well kind of do this, right? So let's take all this boilerplate stuff and just use it, right? So we can't load it into our shortcuts yet. The shortcuts kind of have to take some time to reload. So we have this, and all we want to do here is everywhere we see these kind of stars, we're going to change it to dumpass, and going to be lowercase, dumpass, lowercase. So find next. Replace. There's one place that some of these things need to be changed in case. So this needs to be, right, this is public. And then this is also a public variable. So a little bit ugly in the way we had to like make all those changes, but we got them all, right? So all these things are dump ass, whatever the heck. But yeah, a lot of boilerplate where it's like, I'm not too happy about the amount of boilerplate here, but the idea is to make the code very easy to follow, rather than having some fancy way to like auto-generate this stuff. So we can kind of like try to clean up some of this stuff. But yeah, in the end, it's just, you know, some of it's cluttered. Okay, so now that we have this in here, one of the obvious things is we need to go into the silence and add this. So silence.d. And we know, if we look at the C11 file, let's go look at the C11 file. Let's go
God, we have so many things open. Close this. Close this. Close this for now. Let's move this function file over here. Let's just close this data file. We don't need it. And now when we look at silence.d, let's move this over here. Silence.d, we can see that this new dump ass is coming after pixload, right? So if we go here, we can see that pixload is somewhere over here, right? Oh, or did we just forget that? Did we forget pixload? Okay, so pixload does not exist in here. That's fine. How about pixpush? Jesus, what did we forget here? Pixback, GPU data, pixpush. So pixload should be right here, but it's not. In fact, we're missing a few things. So we have U08. Well, after pixpush, we should have pixload, right? Or not? Yeah, we should have pixload. Then we should have. We're just gonna say that. I don't know. So sometimes. So since this is old stuff, I'm gonna say, right, what did they say? That sometimes smart people don't have the answer and they say, I don't know, right? The smartest people you know say they don't know. Not that I want to be pretentious and say that I'm super smart, but pixload, I don't know, because I haven't looked at this code in a while. I don't know what it's in there, so I can't flag this as doesn't talk, right? That would be my first inclination, is it doesn't talk because we never had to revisit it and add these flags. But maybe it does, and we just didn't add any silencing code to it yet. So I don't know if it's a yes or a no, or it doesn't talk. So I don't know if it's any of these three flags. So we're just going to use a question mark to say, I don't know yet. And we could just say, look at this code, right? Look at this code. I don't know. Okay, so we have pixload. Then we have dump assets. And for this code, we're just going to say that we're going to add the silencing code right away. So this one, added to subsystem, we're going to mark that as an X, because we actually just did that when we put our boilerplate in. We actually put our boilerplate in correctly. Huh. Looks like my commit script does not work on single-digit days. Oh, well. Okay, so anyways, we know that's there. Then we have, like, poly OGL that needs to be added. 08 poly OGL. Once again, I don't know. I don't know what this needs. So we're just going to put that there. So pixload, dump-ass, poly OGL. Let's make sure that these are actually unique tokens and that they don't exist anywhere else. And yeah, so now let's look at, there could be some other things. Let's just focus on these. 28, 29, 30, 36. And is there a 36 here? There's a 36 there. Good. Okay. So let's just copy these three things, right? So we have these three things we want to copy. They come after pixpush. So let's go down to pixpush and just make some room here. And then let's copy this, paste it, and then just insert it correctly. So dot. And we're just going to change the spacing temporarily to be like, these are old systems that I don't really want to see logging about, so we'll keep that off. However, this new thing, we're going to turn the logging on because it's new. And, oh, hey, so, there we go. Yeah, how's it going? So I am encoding assets into my game at the moment, using PHEXDUMs. And I have it working, but I need to, so if you look at this, this is my master list of all my systems. So all these are the different system names, and then every system name gets a different unique number.
And this is basically like a build script, but it's C code. So it's C code, but the functionality of it is to kind of serve as a build script where I include all of my sub-libraries in a very specific order, so I don't have to worry about any like initialization order things or dependency injection or any other complicated method of making sure that all your dependencies are met. And one of the systems I just added is this hard-coded assets library, and then I also added this HEXDumper library right here. And now I'm working on this thing called dump-ass, which stands for dump assets. So this dump-ass sub-library is responsible for taking the hard-coded assets and turning them into reconstituting them, you could say. Or the hard-coded assets are kind of like embedded into executable memory, and we want to extract those hard-coded assets and put them into arrays, and we're going to use the dump assets library to do that. So if we want to take a look at the hard-coded assets so you can see what that looks like really quick, so hardass.d is the data. And so you're going to see that we have this thing that says PAINT5D default data, and it says NOE. So NOE stands for number of elements. Then we have PAINT5D default data 01 PNG. So this PNG is literally a PNG file, but it's embedded into the source code using a hex dump. So you can see that the way we declared this array was we use these includes, right? So we're going to cut and paste text from this file and cut and paste text from this file. And so let's kind of like go over what that would kind of look like. So it's basically going to say, okay, so anytime you see an include, it basically means cut and paste code from a file. So let's go look for these files and build this. So let's go open the, so let's go into the assets folder and open up these files here. And so this is the NOE file, right? So the NOE file has this number in it, okay? So if we go into here and we see this is the NOE file with the include. So this basically will turn into this. Okay, so this is the NAK file that stands for naked array. And so here's our naked array file. So that basically means we're going to take all this text and we're going to paste it into this section right here, right? And then, you know, more stuff down here, right? But this is just for illustration, right? But basically we use those includes to create a array like this, but have it hard-coded into the data. So I have a pipeline that takes the images in the assets folder. So let's go look at the assets folder. So it takes this image in the assets folder. So this image right here, this is a PNG file. It turns it into this hex dump, and then it also creates this file that just has a number in it that tells us how many uint32s are represented in this file here, right? And then we use that to construct something like this. So we have a variable that encodes a PNG file within the executable. And that way we don't have to distribute our executable with like an installer or like a folder full of supplementary files. We can just use this, and that means the engine will just be like one executable file. You can pass it around. You don't have to worry about using an installer. It's like a single file payload kind of deal. Anyways, so I need to keep on working on this. So I'm going to close some of this stuff and keep on focusing on what I was focusing on. But yeah, so things are getting kind of interesting. But I don't quite have the visual tech demo that I wanted to show for like the new stuff just yet. But I'll probably be there by the end of the day. Okay, so we got these systems here. These new systems we want to stub into the silent system. And let's make sure that they are all in the correct order here. So we got pixload, dump-ass, and poly-OGL. So 1, 2, and 3, and they should be accounted for up here as well. 1, 2, and 3. Excellent. So those are there. We can close the silence.d file. I'm satisfied that that looks correct. We can also close this for now. We're going to have to... this is where we need to finish up, though. So I'm going to add this to the clipboard and just make a to-do note. So this is done. So I'm just making some to-do notes on another screen really quick.
So to do, finish. Okay. So I'm going to close this so I can focus on what needs to be focused on here. 29, so 36 systems. Let's open up some of the files that are going to need to be changed to get in this new subsystem. So within here we have a thing called libchan, and this is part of the build system. We're going to have to look at these. We're also going to have to look at fmacros, so the top and bottom file for fmacros. And we're also going to have to look at one more file. It's in our main folder. It's main.f._, which is just like our main functions file. It doesn't matter what order we edit these in because they all need to be changed in order for this to compile correctly. So the first thing we want to look at is these new files we've added. Where are they in relationship to the window code? So this is the asset dumper, or the dump ass, right? And it comes after GinaWin. So I know my initializers are, I have two sections of initializers. Half of my initializers happen before the window code, and then another half comes after the window code, which kind of sucks, but that's just the reality of how the code needs to work at a low level. Some things can't be initialized until a window exists. So some of my code is code that does not depend on a window can be initialized here, in this section right here, that we're looking at here. And then there's other code that needs to be initialized after that window exists, which is right here. So let's see what we have here and see if we can start inserting some of these new things here. So we have pixload. So here's pixload. And then right after pixload is where we're going to insert the dump ass thing. AAC 2020 dump ass. And it's not going to have an initializer as far as I'm concerned. And is this system number 27? It's 29, so it looks like at some point there are a lot more systems that have been added in here. And everything has been kind of shifted around. So let's look at GL bind init. So GL bind is now 17. So the first thing we're going to do is say, hey, let's just take everything that we currently have and kind of shift it up. Well, let's move this here, right? So let's shift this up first and change this to 34. Then we know that this GL bind is now 17. So let's shift all this up as well. So let's copy this and just shift everything up and see if everything kind of falls into place or what else is missing, right? So 34, this is 35, and this is 36. So if we look at this, 36 is indeed this. If we spot check, how about pixload? Is that 28? So 28 is pixload. How about pixsave? Is that 24? So let's look at pixsave. It is 24. How about our freeze spot? Is that still 21? 21, still our freeze spot. How about init none CPU uniforms? 19. Yes, that all looks correct. So this dump ass thing is system number 29 here in our library chain, 29 here as well. So that looks correct. So now we have to kind of change this around as well. So pixload and then dump ass, right? So let's look for the pixload. And we just need to make an insertion point underneath there. And this is going to be dump ass init none. And to get these numbers correct, if we have everything accounted for, we should just be able to copy paste this, right? We should just be able to copy paste this checksum, and then boom, everything is numbered correctly, we believe. Now we can spot check this and say 23, are you pix name? 23 indeed is pix name. Spot check one more thing. Tau sync, is that 34? Tau sync is 34. It looks good to me. Okay. So now that we have this function file fixed, where we have we're calling the correct initializers in the correct order, we can close that and we can go to libchan top. So this is going to be the most annoying file to edit. But fortunately for us, the insertion point was closer to the top of the file, so it's going to be, hey, how's it going? Have you been here before? I can give you a quick tech demo, if not. Otherwise... Oh, I see. Okay, I see. I know what's going on there. I recognize your
what do you call it? You know how everyone talks a certain way? Yeah, I recognize your speech pattern, yes. And I also recognize Pro Data Systems, yes, I do. I do recognize that old company name, the original company name, maybe? Yeah, so actually, let me give you a quick tech demo since you're here. Yeah, I'll do a quick tech demo really quick. I'm not going to go into like everything I'm doing because I know you're working. So I'll just give you a quick tech demo. So I have this art asset here, right? So this is a PNG file. I'm going to take this PNG file and I want to embed this PNG file into my C99 code. So I created a hex dump utility, and the hex dump utility generates this file, right? So this file is just a whole bunch of uint32s, and these uint32s encode all the binary data of the PNG file. Okay. Then over here in this file, it's just a number that says 4,672, and this number 4,672 is the number of elements in this comma separated list right here. Right? So my build system creates these files. It generates these two files from this art asset. Then, within my library code, let's go into my library code really quick. So I have this thing called hard-coded assets. So hardass.d, D for data file. If we open up this data file, we can see that we have a U32 array. And the way we're building it is that within the list here, for the number of elements in the array, we include this file that has the number for the number of elements, and then we include this file that has the array of actual data. So if we want to like take this and unabstract it for a second and kind of show you, like visualize what's going on here. So we have this piece of source code that looks all crazy, right? But we know that includes are just find and replaces, right? So if we take the this naked file, right? Let's not take everything because we just want to illustrate what's happening, right? So this is an include for the naked file. So the include gets replaced with the contents of the file, right? So boom, this gets included into the array initializer here. And then this thing, the number of elements, well, let's like open that number of elements file. So number of elements is 4674, right? So that means that this right here, this include gets replaced with the file contents, which is this. And then essentially what you have is you have a uint32 array called PAINT5D default data number 1 underscore PNG because it's encoding a PNG file. And this array has 4,672 elements in it. And then, oh, here's all the elements, right? So that's how we're going to get the assets encoded into the actual executable. And the reason why we're doing this is because we want to maintain a single payload executable. So we don't want an installer file that that dumps a big library of a whole bunch of folders and all that crap. I just want like one executable. You can put that one executable on a thumb drive, pass it around, no installer. It just works right out of the box, right? Like a portable piece of software, right? So that's kind of like what's going on there. So in order to do that, there's some more complexities as to like how I'm doing that, but that's like the basic idea. That is the basic idea of what I'm doing. And so then the rendering tech is pretty cool. I'll probably if you check back in and I don't know, I'll be doing this for probably at least 8 more hours. 8 more hours, probably like a 30-minute break somewhere in between that. But I'm going to have some more technical, graphical stuff to show. But I'm right in the middle of kind of refactoring. Well, not refactoring, but putting more systems into the code. So yeah. There's for shiny tech demo. Yeah, so yeah, check back in 8 hours and I'll have some shiny tech demos. But yeah, so I'm gonna keep on going, and keep on doing my thing. So you'll probably notice that in the in the bottom of the screen here, we have the day is Monday and the integer ID is 128. So this is the 128th video that I've worked on. And the idea is that as I'm writing comments in my code, I will sometimes put the video number in the comments so that the video number and the actual timestamp so that I can use my videos as a way to
document. Yeah. I know. I kind of. It's coffee day too, so that means I go overboard. But yeah, this the idea is that, you know, if I'm always coding videos and I'm always programming, there's no way I'm ever going to be able to look at all this footage, right? So, but what we can do is, like, when you ever have those moments where you're like, what the hell was I thinking when I wrote this code? Well, as I go through my code and as I'm writing things, occasionally I'll put the video ID into a comment, and then the actual time at which I wrote that comment. And so a lot of times in a lot of pieces of code, if I want to know exactly what I was thinking at that time when I wrote that comment, I can actually go back to the original video and I can see exactly what I was thinking. So it is kind of crazy. It's a crazy idea, but the idea is that even if I don't have many viewers, the videos serve as extra documentation for the code base. So it's kind of crazy. So kind of scary to do all this. Is that? Yeah, I've been getting a few here and there, every once in a while. Basically, like, I try to, what do you call it? I try to, like, anytime I see somebody new, I just like to give them a quick demo of what I'm up to, and then people are kind of interested. Also, I did set up those shelves, and the servers are on racks, but they're not plugged in. So I haven't tried to boot up these servers yet, but they're all on a rack. They're right in front of me. So they're right in front of me. Yeah, they're right in front of me. Like, I can see them. They're all on racks. I have not tried to boot them up yet. I need to get to that eventually. But they're here. Basement's all cleaned up. I'm going to go to. Yeah, they're pretty sturdy. They work for what I need to do. I'm going to. I keep on thinking about what I need to do. Oh. The patent, first patent is granted, got, confirmation in the mail. Mail, all the nonsense, with first one is done. Been checking into USPTO website weekly to make sure I never miss any important, things, meaning, yeah, so I'm making sure that I'm making sure, like, every week I have a thing called, I have a bash script for Sunday tasks. It's called Sunday tasks, and on a Sunday, a bash script will open up, and it just tells me, it has a list of tasks that I need to do on a weekly basis. So it's just like, yeah, exactly. Like, no, it all comes down to, it all, like the government and city governments and all, and neighborhood associations and all those, mother effers, it all really comes down to, they might say, make up excuses, but all it really comes down to is, give us money. Give us money and we'll leave you alone. That's really what it is. And they might dress it up and make it sound really fancy or whatever, but the reality is just, give us money and we'll leave you alone. And yeah, that sucks, but, you know, whatever. That's the reality of the situation. And as long as you can realize that it's that simple, then really all you have to do, right? If you know that's the cost of doing business, right? So if you know that's the reality, then all you need to know is, like, yeah, there's all these forms and all these other pieces of BS that you have to keep track of, but I think, you know, you just have to prioritize the one thing that matters most is, does everyone who wants money have the money, right? And as long as that's okay, then all that other stuff doesn't really matter as much as long as everyone's been paid. Like, everyone's going to be forgiving as long as they got their money. So I am trying to make sure that I Just remember that one thing. And I'm going to go to the shop soon I've been thinking about like what I want to make. And I think I'm just going to go for the kill. And I'm going to make... okay, I can either make money by making a lot of tiny products and selling those tiny products, or I can make money by making one ridiculous product and selling it for a high price point. Now, there's a higher risk with making a ridiculous product, right? Because you have to... finding a buyer for a more expensive product is harder, but there's actually less effort involved, right? Because to ship one product that basically say you make your month's salary for the month by selling one product, you just have to go to the post office once, versus if I have to do it every single day because I'm selling tiny little knickknacks. Also, no one's going to, and this is kind of like, I don't really care too much about this, but let's be real, no one's going to remember you for making tiny little knickknacks, right? But if you make something that's like this expensive piece of like designer furniture, people are going to remember that kind of thing. So I'm thinking of like, okay, how do you like make money in a time-efficient way and then also like make a name for yourself? So, so I got all this acrylic behind me. I do eventually want to make the tables out of like aluminum, but right now I just don't have the expertise to do that, and I don't have the funds to do that. So we might as well use this like all these many tons of acrylic that are sitting literally right behind me. I mean, right behind me. Like if I put my arm behind me, I'm touching acrylic right now. Yeah, necklace. Yeah, exactly. Yeah. Yeah, like I need to get on Etsy, and I'm thinking of selling felt washers because they have a high price point, and I need to manufacture them anyways because the acrylic table will get scuffed up from bolts if I don't use felt washers. Yeah, so I'm gonna make I've been thinking about, like, there's a whole bunch of things that I want to do, but in terms of just getting a product out there, I just need to get a product out there. And, you know, luckily Gramps' house is pretty nice, so it's kind of like I have a place where I can take a photo of the table in a relatively kind of classy-ish setting, right? Like, I can have literally a grand piano in the background of this, like, fancy-ass coffee table. So if we want to get political, not too political, not political enough to get me canceled here, but as the rich get richer and the poor get poorer, where do you think the spending of that extra money goes? And the answer is the spending of that extra money goes into things that, well, if the rich are getting richer, then they're spending money. So where's it going? Well, what do rich people like? Oh, they like art, right? They like art. They like designer goods, right? They like fancy French watches and things, right? So when I'm thinking about what I want to make here, I'm like, I think I can make like this very fancy designer table, and then no one can copy me because the actual parts of this table, like the very substrate of this table, is made out of patented parts. So any design I come up with, it's patentable, besides the copyright of me being the artist that has made this table, right? So, like, I think this is a good way to go. But today is code day. Today is just code. But yeah, photos, presentation, it makes a big difference, especially if you're trying to sell to, like, a upscale. Yeah. There's a saying, people buy the photos, not the product. According to yeah, and it's very true. It's very true. But anyways, I'm gonna get back to coding because I'm kind of ranting here, and I'm really excited because today I'm actually gonna get. It is 2 orders of magnitude more work to get to get this code working than it was to make the prototypes. The prototypes, so I'm saying that, not tenfold, not 10 times more work, but it's like 500 times more work to make this stuff. Yeah, okay, yeah. Yeah, it's like 500 times more work. Like, I did the math. It's 500 times more work. The time sink is 500 times greater to do this final C project than it was to make the JavaScript prototypes. I did the math. That's ridiculous, but I have a very strong foundation. Like, everything I'm doing is, like, solid. So I am excited. Anyways, I need to keep on working on this. So, libchan top. Okay, so let's, yeah, I'm gonna keep on working on this. But good talking to you, and I will see you when I see you. Okay, so let's look at this file here. So this new file, 39. Oh yeah, fundamentals, definitely. Fundamentals and just making the code, make the code easy to follow, right? A lot of people try to make their code too abstract. I'm making my code dead simple as a complicated problem can be, but dead simple. Okay, so 29 here. All these numbers look like that's just what they need to be. We just need to add another entry here. So this needs to be 36 and 36, and this is 36 and 36. So a lot of redundancy in my code, but it's a lot of dead simple redundancy, right? So it's not like it's hard. This code right here is not hard, but it's just a pain in the ass because it's a lot of very redundant code. It's a trade-off, right? So I'm trading flexibility for ease of understanding, and I think that's a good trade-off, right? Because maintainability is what really matters. Maintainability and understandability are more important than being able to quickly add and remove features as far as I'm concerned. So this is, we've duplicated poly-OGL, and that means that before here, this thing that says right here, this new 29 is going to be called dump ass for dump assets. So dump ass, name recommended by my girlfriend because you know, they have a sense of childish humor. So yeah, so now we're just going to renumber these. So this is 30. But yeah, this is the annoying part where when I make insertions, I have to do this, and this is quite annoying. But the idea here is that I don't have to worry about dependency injection. Like, everything is included in a very specific order, so that I have a lot of certainty about how my code is executing, and it just makes it easier for me to diagnose problems when I know exactly how everything fits together. So pixload 28, dump ass 29. Poly-OGL is 30. Okay, so that's good for the data section. So now we need to do the same thing for the function section. So we have code that looks very much the same, and we need to go and find 29 again. So 29 right here needs to be overridden. So let's copy this block 29 here, paste it here, and the top needs to be rewritten. So this 29 is now dump ass, right? So right here we're just going to column select, and we're going to say dump ass. Okay, and now we're going to just renumber these. So this is going to be 30. This is going to be 30. And now this is going to be 31, 31. This is going to be 32, 32, 33, 33, 34, 34. This is going to be 35. This is going to be 35. This is going to be 36. And 36. Now, another thing we can do is let's just make sure that P5D 1OGL, the data file, is also 36. Is that also 36? Yes, it is. So that looks like, that looks good. That looks like we refactored that correctly. We'll close it and forget about it. Just hope that we did that correctly. And if we did not do it correctly, well, it won't compile, hopefully. Because we have redundancies in here to make sure that if we screw things up, it won't compile. So pixload. Let's find pixload in here. So pixsave, pixback, and pixload should be somewhere around there. So here's pixload, and after pixload is going to be this dump ass thing, right? So we're going to copy these macros here and just paste them in here. And now anywhere we see pixload as in the second chunk, we're going to rename that to dump ass, right? So, and this is just code to make absolutely sure that my libraries are included in the same order. So I'm just making absolutely sure that all my library code is in the order that I say it is in. Right, so any stupid transposition mistakes or ordering mistakes that I make, I want to make sure that I don't make those, because if I screw up my build system, I could have like very hard to find bugs. So I absolutely want to make sure that the order that I say things are in is actually the order that things are in. Okay, so here we want to find the same kind of pix load right here. And let's take this section, right? So let's take these macros right here. We're going to copy and paste them. And then this thing that says pix load right here, we're going to call this dump ass, right? For dump assets. And now we have 228. So we're going to column select. We're going to column select all of this. And then we're going to overwrite this 28 right here and paste it right there. And 28, 29, right, 35, and then now we have to make 36. So we have 36 slots. That looks right. That didn't quite work out exactly how I wanted it to work out. Like, I felt that was a little bit clunky. Let's kind of change the indentation here, because something about this, I think, makes sense. I don't know. I feel like almost that adding these extra comments, the comments that you see in kind of like this purplish blue, may have been the wrong call for doing this. I'm going to change this around a little bit. I don't know. Okay, so let's look at this. Dump ass is 29, right? Yep, that's 29. And then over here, we want to do the same thing. So we're going to duplicate this pix load. And then the thing that comes after pix load is dump ass. And then we want to shift up these numbers. So like that, and then call this a 36. And okay, so that is in place, right? So that's done. Okay, so now we have F macros. F macros, let's look at the top file first. And let's keep on referencing our main build file. Well, this isn't really the build file. Well, this is the C11 version of the build file. It's basically a build file. This is the C11 file that gets compiled. And it has a master list of all of these subsystems and what order they're included in. Okay, so at 29, what numbers here need to be changed? So if we look at CPU info, this CPU info is probably somewhere over here. So the inclusion of dump ass does not change that this is still 19, right? We need to look for something that's around 29. So this doesn't get changed, but tau depot got shifted over, right? So tau depot, if we look at tau depot, it's 32 now. So let's change this by 1. That means any number higher than 32 also got shifted over. So this 33 is now a 34. Okay, so tau sync is 34. Tau sync, yep, it is 34. Excellent. So we fix that. We have this master list of init none functions, right? Init none functions. Dump ass, we're going to assume that it has an init none function. So pixload and dump ass. So pixload, where are you? Pixload is right here. So we're going to include dump ass right here. And now that we have this included in our list, we need to nuke. We need to nuke everything in here, right? These are like auto-generated functions. Right? It's basically boilerplate. Now, the reason we have this boilerplate is to make the main code in the main file more streamlined, because we don't have to wrap everything in macros in the main file. And I'll show you what that means after we generate this code. So let's take this source here and copy this, and then let's run FARC, which stands for find and replace clone, and it's going to generate like all these boilerplate functions. And it unfortunately had this little bug. It's not really a bug. Well, I don't like it, so let's consider it a bug. It's kind of benign of a bug, but I want to remove these extra spaces from here, which is kind of a little bit of a mindless time sink. So it's like, maybe I should figure that out, but for now, let's not worry about it. But as we make more and more of these, it's going to become more and more of a time sink, and it's going to require our attention eventually. Like, once we get up to hundreds of systems, if that ever happens, we're going to have to fix that. Okay, so all these systems are stubbed into here, into our F macros top file, but we also need to
attend to f macros bottom, which will undefine those same macros. So if we look at pixload, right? So dump ass comes after pixload. So here's pixload. Let's duplicate this line with Control D and then say dump ass, right? And now that that's in there, that's all we need to do. That's all we need to do for this. This is just being courteous to people using our library and cleaning up some of the macros, right? So we don't want to pollute other people's code with our macros. Yeah, if they don't need those macros, then we want to get rid of them, right? So we want to be courteous to other people using our library. So it looks like we've done everything. Now let's look at the function file for a second. So let's open up the f macros top file for a second to explain why we just, oh, not the f macros. We want to open up the function file. So in the main function file here to explain, hey, why do we make the f macros, right? Like, what is that all about? So what that is about is we can now streamline how we're initializing all of these systems, right? So when we initialize all these systems, it's one line per system initialization, right? But if we look at where all these f macros are declared, right? If we look at where those are declared, and we look at lib, and we look at f macros for a second, f macros, and we look at the top file, we will see that, like, all of these are the init none functions. You see all this mindless clutter here, like, you know, basically this macro resolves to the actual function call if this file is included. But if this file is not included, then this macro becomes this, right? So we could get rid of the macro and just say, if this is declared, call the function. If it's not declared, don't call the function. But what happens here is what is, you know, one call right here. If we didn't use f macros, it would turn into 1, 2, 3, 4, 5, 6 lines of code. 6 lines of code at the very minimum, and we probably would also want to put like a space between these blocks, right? So we're really talking like 8 lines of code, right? So this block already looks pretty big. Now imagine this block of code being 8 times bigger, and we don't have to imagine it, right? Let's just kind of like visualize that really quick. Let's paste this and say, okay, 1, 2, 3, 4, 5, 6, 7, 8, right? So look at this. Look at how ridiculous that would be, right? If your initialization code was like this big, I don't know. I think that just is ugly. And it's not really saying more, it would just inflate the code, right? So we're trying to just hide some of that uckiness by wrapping everything in macros so that we can kind of do this, right? And then we still have these comments here, which exactly mirror this code here, except instead of saying f macros, see the f macros namespace, it has the AAC 2020 namespace. So these f macros here are indirectly calling all of these functions. But we only want to call those functions if they actually exist, and that's kind of the reason why we have f macros like that. So, with that said, we're ready to like compile this and see if everything is stubbed in correctly, right? Because we just stubbed in a new system, and there is the potential that we have just made a mistake somewhere. Oh, it looks like we did it correctly. Nice, first time, awesome. First time, got it working, excellent. Okay, cool. So now that that's stubbed in, we need to create the logic. So let's close this, let's close that. And hard-coded assets, we kind of want to look at the hard-coded assets because that's what we're going to use. And let's look at dump ass. So dump ass functions. And let's just create the one function that we want, right? The one function we want to create is a function that loads a certain asset into, like, we can abstract the logic later, but let's think of the exact function that we really want. So we want a function. It's going to be called AAC 2020 dump ass, and dump asset 001. Let's call it asset 01. Yeah, sure. Let's just call it asset 01, right? Now, do you want to call it asset 01 or do you want to call it PNG 01? Now, we could call it asset, or we could call it, so if we look at this, we have default data 001 PNG. We could call it PNG 001, or we could call it asset 01. Asset is more abstract than PNG, right? Are we ever going to have an asset that's not a PNG? That time could come, but let us let us err on the side of being less abstract, right? So PNG 001, right? So the asset is called PNG. So we're gonna dump asset PNG 001. Into and we're gonna dump this asset into, let's go into PixName for a second. So PixName data, and we want to dump the asset into PAINT5D. We want to actually dump it into PAINT5D. So we want to dump it into PAINT5D, right? So we want to dump it into that system, so it's going to dump it into PixName PAINT5D, right? So we're going to dump this asset into this system's memory, right? So that's how we're going to name it. Now, I don't want to call it into, because into is 4 letters, and I would actually like to normalize everything to 3 letters. So the first thing we're going to look up is synonyms for into, right? So is there any synonym for into that would be like 3 letters or something similar enough? Like, what are our options for 3 letters for into, right? So I'm actually kind of disappointed here. I didn't think that into would have so little. How about insert, right? So let's look at our shortcuts here. 3 letters for into, 3 letters for insert. So INS for insert, right? Could be a thing. We could use INS, insert. So let's look for synonyms for insert. Embed. Embedding is what we already did with the hard-coded assets, so we're really not embedding. We could say pop, right? Place, obtrude, instill. Instill for, that would still be INS for insert. Interject, admit, infix, infuse. Inject. I do like inject, like INJ for inject. Embed, fill in. I kind of like inject. Inject kind of, I like inject. So let's go with inject. So let's make a note there here, right? So INJ, what does that mean? INJ means, right? So INJ means, and then we can just say INJ inject. Like load, but loads from one place in RAM to another place in RAM. Okay. Well, hold on. If we're just going to call it one place in RAM to another place in RAM, RAM is actually a 3-letter word, and it also is a noun. Or it's a noun, but it's also a verb, right? Like ram something into something else. So maybe we want to say RAM, right? So we're going to take this and ram it into RAM, right? I kind of like that. So RAM. Let's do that. So instead of this, we're going to say let's just put this definition in here. But use
Yeah, so instead of this, we're going to say RAM. RAM into RAM, right? I like that. So let's go with that. Let's go with that. I think that's the 3-letter word we want. So when we say RAM, RAM, like this, we're going to say, hey, you're correct. You're correct. That is a thing. And if we type RAM all lowercase, right, if you go RAM, that might actually give us a kanji. Not what I expected. Action performed to get the code to fire message displayed by alert or confirm, MC minified, blah, blah, blah. So obviously we have some type of old, like, lookup thing called ram.txt. I don't know exactly what it is. It's like a very old shortcut. From the looks of it, right? Because I noticed from the kanji that are in it that it's probably a very old file. So let's look for ram.txt, right? It was ram.txt. Hold on. So let's open that file again. It was called ram.txt. Yes. So ram.txt. Let's look for where that is in our shortcuts, and we might have to change that. So not diagram. Oh boy, we're gonna have a lot of that, aren't we? Okay, not too bad. Red alert map. So here's our RAM, right? I don't even know. This is IDB stuff. IDB for iDashboard stuff, which I do not work at iDashboards anymore. So I'm not going to worry about we can make a little note here that it was removed, right? We can make a note that RAM was removed from this list. But yeah, I don't really want to use this. This is something I'm never really going to look at, right? I just want to keep a chronological list of everything I've been doing till the day I die. So this is just something. Once upon a time, I worked at iDashboards. Around once upon a time, long, long ago, back in the days of Shortcuts 20,000, right? That was like years ago. That was like a year or two ago. I can't remember how much time has passed, but yeah, back then I had 20,000 shortcuts. I have more. I have at least twice as many shortcuts now. So anyways, we got rid of the RAM shortcut here, and now we're just going to say, if we type RAM, we're just going to uppercase it. And then we're going to say RAM means, and then RAM means, and then might as well say RAM means, and RAM means, and RAM means in all capital, and then RAM. RAM verb into RAM noun. RAM into random access RAM into random access. RAM into random. Okay, and that's good. So instead of calling it inject, we're going to call it RAM. Okay, so you might wonder, like, why am I doing this? Why am I having, like, this, like, this variable name plus RAM plus this kind of like system name? Well, the idea is that in data-oriented design, we think in terms of the data, obviously, and what you're really doing in any computer program is you're just taking one set of data and you're transforming it into another set of data. That is all you're doing. All you're doing is transformations. So when I write my functions in terms of transformations. Take this data, apply this transformation, and then get this data out, right? Input, transformation, output, right? That is why I write the functions in the way I do. And now, am I an expert at data-oriented design? I don't know. You know, I don't think so. I don't think I'm an expert, but here's what I think. I think I'm just going to say what I think data-oriented design is, and then either somebody's going to call me out on my bullshit and educate me and make me smarter, or I become the authority on data-oriented design. One or the other. So either way, I win, right? Either way, somebody
corrects me for saying the wrong thing, or I become an authority. Either one of those is a good outcome. So I'm just going to be bold about what I say I'm doing, and just let the chips kind of fall where they fall. So we got this thing. This is good. So it's going to take void, right? It's just going to take void because it's kind of like this hard-coded function here. And I was going to call it, we could actually kind of name it after the actual asset. So we could say, let's look at dump_ass for a second. Dump_ass data right here. Not dump_ass, hard-coded assets, hard_ass. And in here, we have a section called all PNG file assets, and then we have PAINT5D default data 001.png, right? So we could name this section .png, right? We could actually name this section after the asset that it's working with, right? So we can so I think that makes the most sense. Categorizing by asset. And let's formalize that, right? So let's formalize. Functions categorized by asset worked with. Right, so functions categorized by asset worked with. And then, right, so we're going to add another indentation level for this. And that's kind of weird to do this way, but I think this is going to have the most benefit for us. And ram into ram, we're just going to say void. No need to get fancy here. Right, so the idea is that if we look for this file name, we can find exactly where it's being used. Okay, so now the next thing is this section divider. We're going to make this section divider a little bit thinner, right? Because it's not, I'm actually feeling like, I'm feeling fancy today. I know that all these assets are going to be given, like, this normalized name of, you know, data 001, 002, whatever, or PAINT5D default data 001, let's kind of keep on numbering things sequentially. I don't know. Let's, I do like, I don't know, feeling fancy, so let's kind of subdivide it like that. Okay. So, right, so the line hierarchy, this kind of line here is thicker than this style of line, right? So within this section, how are we going to do this? So we know that, we need to, convert. So we're going to look at PHEXDUM. So let's close. We can close this for now. And let's open PHEXDUM.functions. So PHEXDUM.functions. And there should be a function in here which does exactly what we want to do. So if we look in here, we should have something used to reconstitute the data. So we have file read and write section. We don't care about this. Let's kind of move through here. File access wrapper methods. Well, are we doing file access? This is a file access thing? No, it's not, so we can skip through that section. How about U08 array to U32 or U32 array to U08 array? That's exactly what we want. This thing right here, this one, this first one is what we want. So this U08 array to U32 array, that is what we want. So let's grab that, copy that, and say, yeah, we're going to call this. I don't know exactly what our parameters are going to be here, right? But we know that we're going to have, if we look at our hard-coded assets right now, we can see that we have default data PNG and number of elements, right? And so here's the array, right? And then the array length, right? Number of elements, right? So this is called U08
array, and this parameter here is called U08len, right? Now we have these other by reference variables, right? So we can just kind of pack these in as they are, right? So we could just say U32 array and U32len. Now, instead of calling it U32, we could call it like, hold on here. Wrong command. Wrong command. Other way around. We want to convert a U32 array and convert it to a U08 array, right? We want the raw pixel data out. Yeah. My bad. U32 array, convert to U08 array. Okay, correct. So this is... Let's go find the other function then. So it's not this function, right? Because that's not what we want out. We want this one. And so these parameters... Wrong. Yeah, I did that wrong. My bad. So these are the parameters. And then the output is U08, right? A U08. Okay, U08 array. And now, do we want to give it like a more terse, not more terse, but more verbose name to help us identify what this is, right? I don't know. But let's put some commas here. And let's kind of put this here like this. So yeah, let's add more spaces. Let's go 1, 2, 3, 4. 1, 2, 3, 4. Not bad. I don't really like just calling it U8 array, but I mean that's kind of what it is. So this is decompressed deflated. Right, it's deflated. So deflated PNG and the deflated number of elements, right? So, okay, that's fine. So then here we can say that this is going to be a U08 pointer, and it's going to be U08 array, and it's going to equal a null pointer. So U08 pointer cast of 0, right? So a typed null pointer, which is nice. And then the length, right? We can say that the length is going to be int32 pointer. I just know that I use, sorry, not an int32 pointer, but just an int32. And a U08 len, right? So it's the length of the U08 array. And we're going to zero that out, right? We're going to set both of these to zeroed values because these are output parameters and we assume that they're not being used yet. So we want to put them in a zeroed out state, otherwise my code will complain. And that's just a safety measure to make sure that we don't overwrite something that is storing a valid memory address. So that's awesome. So now we have this thing, we got this extracted data. And after we load it, right, we're going to copy everything. After we load it, where we're loading it, we need to free the U08 array, right? So after we copy the data, free after copying, right? Okay, so how are we going to copy it? Well, that's going to be pretty simple. You know, for if we look at PixName for a second, for, I guess comdex would be the correct thing. Comdex equals 0. Comdex is less than or equal to max index, and then comdex plus plus. Comdex for component index. And then right here we can just say, you know, int32 comdex. And then we can just say, you know, int32 max index, max index, equals, and that is going to be 512 times 512 times 4, right? This is hard-coded. Because this is just how the system is. The system revolves around these 512 by 512 pixel textures,
and it's never going to change. If it changes, we're just in a lot of trouble because we've hard-coded this kind of stuff everywhere. So we're just designing around this because the more data, let's abstract this and say instead of it being a 512 by 512 texture, we have supercomputers now, and we can use gigantic textures. We can use like 1 million by 1 million. Well, even if we could use 1 million by 1 million, the more data we use, the more work our artist has to do. So we've selected this number because it's in that sweet spot of it's just enough memory to get some very nice high resolution assets, but not so much memory that it is a monumental amount of work for our artist. Okay? So in here, all we got to do is we're going to hard code this logic. So we're just going to take this CPU pixels, and we're just going to say that CPU pixels comdex equals, and it's going to equal this UO8 array, right? So now you'll notice we do have one thing we got to make absolutely sure of here, though, right? So if 512 times 512 times 4 is not equal to UO8 len, error we'll just call it PNG001, PNG001. And then we can also make a note here, right? So we know where that's coming from. So we might as well put that in our messages, right? So in our assets, it's PAINT5D is this file, right? So we'll take this actual file name, right? And we'll put it into the error message, right? So we'll just say, you know, fix asset, and that is a bit big, so we could just call it fix ass, right? Fix ass or fix asset, and then let's go over here and say, you know, define pf printf, right? Define u32, define i32. We also want to define UO8. Got all these little things we want to define, so now let's kind of take care of that while we're here. I don't know where here. Why don't we justify it like that? Before crash messages. Right, so we're going to use this printf for before crash messages. And now that we have that kind of all situated, we're going to make a checksum of everything we have here. So 1, 2, 3, and 4. Okay. And now that we have these defines, we want to go to the bottom of this section, right? And we want to undef everything we've defined. So anything in here, we're going to say undef that stuff. Okay. And then we also need to remove the excess tokens, right? So we can't have the definitions when we're undefining, right? It would be nice, because I feel like that would help have a little redundancy and be able to check what these were when we're undefining them, but we can't do that, so we're just going to have to... We got to work within the limitations of the language. So, does this all look good? Now, we got this UO8 array, we got this UO8 length, so does that look correct? These are the outputs. So we have to take the address, because these are the output parameters.
So this is out params, at out param. Now, do we have such a hashtag in our hashtag file? So let's look at our hashtag file. Open and go into the library. So let's go into lib and, oh, not lib, sorry, into documentation and open up the hashtag file. And if we look at this, do we have an at out param? Nope, we don't. So let's kind of document what that's about, right? So at out param or at out param. How about at output param? Do we have something like that, maybe? Nope. Or at output param. Okay, so these are all kind of different ways we could have written this. And let's just take this, copy paste it for a second. And we want to get rid of everything except for the last at symbol here. And then we want to right justify this. Okay. And that's just a little comment tag to make me know what that's for, right? So at out param. So this means the actual argument or formal parameter is used as an output param, meaning if you look at the function prototype, the variable is the Right, so just recording what that means. Also, let's do a little video timestamp here, right? So video IID is 128, and the time is 7 hours, 21 minutes, and let's call it 22 minutes. 7 hours and 22 minutes, right? So if we want to come back and see when we wrote this, it was at 7 hours and 22 minutes, and we're just documenting what we mean by at out param. That just stands for output param, right? So now that we have that, let's kind of go back to where we were coding this. So right here in dumpass.f, these are output parameters. So this and this, both output parameters. So we just marked it as at out param so we could see that a little bit easier. Now, I might want to rename this and just put like a underscore here, and then write it like this, just so I can see. It is a little bit more readable with this underscore in front of it like this, that's all. And then align this. And also we could call it at par for out param. But now if we do that though, then we have to go back here and say, okay, we have another let's just make another section for that. Okay, so if you see something that says outpar, shorthand for at out param, right? So this is just shorthand for these things here. So at outpar, oh, that needs an underscore. That also needs an underscore here. Okay. Let's go back here. So I just like that everything is a little bit more normalized that way. That's why I did that. And what next? So we have these arrays, right? The array length, the array and the array length. Right, so this is a pixel component array. And number of length of said array. Right, so this is the pixel component array here. This is the length of the set array. Then we're going to use the PNG hex dumper utility, which has the ability to reconstitute what it hex dumps, right? Like, if we're going to use it to encode assets, it should also have the ability to decode the assets, right? So we're going to, we could have written this in a different way, but it makes the most sense that the library responsible for encoding them can decode them, right? Then once we've decoded this, we want to make absolutely sure that the length that we get out is exactly this. Otherwise, it means that this asset right here, this PNG asset, we encoded a PNG asset of the wrong size, and we're going to have to fix that. So we'll print this off. And then once that's printed off, we're going to give it this error message right here, right? So okay. So after that, component index is the index of the component. Max index is the max index, and we just got that wrong though, right? Because this needs to be -1, right? So it is this calculation for the total number of components -1 because this index is inclusive, hence the less than or equal to. Then here's the actual allocation of memory that we want to dump. But we have one more thing, right? Because after we have copied this all in, we really want to update it, right? Now, it would be nice to just have it as like one little feature. So I think as a little parameter for like, should we update the memory or not, we should have like a update GPU memory, right? Like, we might want a flag for that. Do we really want a flag for that? Flat is better than nested, so it'd be nice for whoever is calling this should have the responsibility. Let's just say this. UO8 enum UO8 let's not get so fancy with enumerations. I'm not really happy with what we did with enumerations before. So let's just say update GPU memory actually no. TLCMD. Update GPU memory after loading into CPU, right? So, if that is true, so we'll do it after we freed the memory. So if this is true, then we're going to have to do some stuff over here. And how are we going to know what that stuff is, right? So, well, we know that in some code we're already kind of like doing this, right? So if we look at the P key, right? So when we press the P key, something happens, right? Well, let's figure out where that's happening, though. So we know that it's in the bindings, the keyboard binding. So if we look at keybind dot data, we should be able to find where it is wired to the P key. So one quote for the P key, because it's a character, not a string, and we can see P5D pattern, right? So if we take P5D pattern and we look through the code, we should be able to find the location of where this... So if char key equals this thing, so this is the command, and we see that we have pix push, and then we have this draw default offset command. I'm gonna say error, don't do this. Okay, so instead of letting this be done, we're just always going to say never set this. Always make this 0. And say, you know, CMC, caller must call. Yes, uglier, to make the caller update, GPU memory, but you know what? Flat is better than nested, and makes us less likely to do inefficient things like spam texture pushes. Right, so we're going to make a note of this and say, you know what, screw this. We're going to leave the option in there. We're actually going to make it an option that you should never use, right? Because it's going to crash. 7 hours, 32 minutes, and it's 7 seconds. Never use this option. So I know it's like I created an option only to say that I'm never going to use it and that it's bad to use that option. And so the idea for that is that maybe somebody comes along and says, you know, it'd be really nice if this had like an option to like update the GPU memory, right? So we're going to give it that option. And then if somebody uses that option, we're going to say, no, never use that option, right? So that when we do something with that, it'll do this kind of a thing, right? So now that we have this, we know that we can kind of comment this out, right? We can comment this out, and then we're going to use this newfangled function, right? This dump asset into RAM, PAINT5D, and we're going to give it a 0 for don't update, because this is going to update it, right? So if we got all that right, and we freed the memory, right? So we made sure we freed the memory created, because this function allocates some memory. So I would say if we've done all that right, then we're going to see some cool stuff right about now. I'm sure that I've made some type of, like, you know, syntax error or something somewhere. So we'll have to fix those, and then we'll run it. Okay, so err. So yeah, we forgot the err function. So err right here, let's define that. So define ERR, and that's going to be AAC 2020 dump ass, it's private, so dump ass halt, right? So this is our err function. Right, ERR for err. And I don't even know if I have that declared yet. I think this is the first time I tried to use this. So we'll have to make sure that that actually exists as well. And we keep a pretty consistent naming convention, but also even if we didn't keep a consistent naming convention, we keep our macros to only 3 letters. So that kind of eliminates the possibility by only using 3 letters, there's only so many sensible combinations for 3 letters that means error, right? So ERR, right? The 3-letter macros really help normalize our code, if that makes sense. I don't know if that makes sense. So we have halt, and yeah, so we have this halt function right here. It says what function is halting. It has the message for the error. This is a little macro, not a macro, but this is cut and paste code from snippets, so I'm not concerned that this code is wrong. It's been used, these snippets have been used many times, and they've proven themselves to work. So let's give that a run. I am really excited to see this because I have been working towards this for a week now. Well, maybe I've been working towards this for months and months, really. So I am scared, but let's press it. Oh, man. Embedded asset, not 512 by 512 PNG. Okay, well then what the heck do we have? Okay, so the next question is, did we look at this right? Oh, you know what? We didn't do this right. Because once we take this UO8 array to a UO8 array, this is not the PNG file yet, right? This is a UO8 array, but it's not the PNG stuff, right? So we're close, but it's not exactly what we want, right? That makes sense. I just screwed that up. So let's get rid of this. Let's close this. Let's close this. And in here, yes, this is close to what we want. And let's kind of see where that's being used. So unpack, where are we? So we unpack into byte array, save file UO8. So yeah, we don't actually have everything here that we need. So let's just directly use load PNG, I guess. Because flat is better than nested. Unless we want to create 2, yeah, let's just do that. Let's go in here and say, you know what? We're missing something, right? So we have UO8 array, but we want something for like 2-pixel array, right? We'll just throw it in here, right? So, so we're gonna say U32 array to pix array. And then also the inverse of this, right? So pix array to U32 array, right? That's the functions we want. So I see what's going on. I know exactly what I'm doing wrong. It's uncompressing. It's getting the actual bytes out of the U32, but those bytes still need to be decompressed, and so that's what I kind of screwed up here. So let's rectify that problem, right? So we're going to add some extensions to this, and so this thing that says to U08 array, we're going to call this pix array, right? So pix array, and then these things that say U08 array, we're going to change them to pixel array. So change these. Anything where we see U08 array, we're going to change it to pix array. So pixarray and pixlen. U8 len. So pixlen. Pixarray. We're going to free the pixel array here. Okay, cool. So, let's make a notice here that, is not so let's make a note that U08 array is not an array of pixels. Use So we're just going to make a little notice here. 4123, how about 23? Keep with that conspiracy there. So yeah, and let's make this red. This is kind of important, that we do not make this mistake. So, we're going to be pretty obnoxious about this. Right, so, because we just made this mistake, I don't want to make this mistake again. But if we look in this section, if instinctually what we look for, and we're trying to, instinctually, if we always kind of look for this function name, and it's not the function name we actually want, then we want a little notice to make absolutely sure that, hey buddy, that's not what you're looking for. Here's what you're actually looking for, right? So we could color code this. We could get a little bit decorative here, right? We could say, hey, this right here, you're not looking for this, right? This is not what you're looking for, but this is what you do want to look for, right? So we can get kind of like crazy with the coloring, be a little, you know, off the wall there. That's fine. And so down here, what do we want to do? So we want this thing here. And our function's void. Like, what's the signature here? Yeah, everything is kind of... Sure. Okay, so we can do this. And what we really care about is getting that pixel array out, right? So we got to figure out how to do that. Now, for the other thing, void, if we're not going to use it right away, we're just not going to code it, I think. So, I don't really see a reason to immediately do this. So we're just going to say, you know, error not implemented. Take this, paste it right here. So let's just say at not imp, because we don't have much room in there. And then we'll make a note in here. So let's go into our hashtag file really quick and say, hey, do we have a thing called not imp in here by any chance? And if we don't have that kind of abbreviation, oh, hey, look. Not quite, not quite. So we're going to go up here and we're going to say, hey, not imp. Or if we surround it like this, and we just want to say, hey, if somebody kind of like types something like this, what do they mean by this, right? And if we do this, at not imp, not implemented, for when I intentionally don't implement something, but I want to stub in a function for completeness / symmetry in the code. Right, so, and then we can make a note of what time I made this note. So we made this at 1:28, and the time was 7 hours, 45 minutes, and let's say 13 seconds to keep the unlucky numbers. Okay, yeah, so this thing here, the pixel array to a U32 array, we don't really want to do that. However, let's look at kind of how these signatures work and keep these signatures kind of the same. So U32 array to whatever, right? So we have a U32 array to whatever here. So we're going to paste that in here, and then we want our two U32 arrays. So the one thing, the signature that has the U32 array at the end up here, so not this, but this one, we just want to steal this exact signature from here to work off of this, to make sure that the code is as regular as possible, right? So all the functions have, the more regular our API, the easier the code is to work with, right? So let's put a little dash line in between here, dash line I1x64. And then let's also put a dash line above this function declaration here, and then let's put one down here. And then we also need some macros and whatnot. But before we make the macros, let's just change some of these signatures here. So U32 array to pixel array. Well, the pixel array is just going to be a U08 array, right? It's just by a different name. So pixel array, so U08 pointer, pixel array, I32. And then this thing is U08 array, but it's no longer going to be U08 array, it's going to be called pix array, but it's still a U08 array because the pixel array itself is encoded as U08s, right? So now that we have that, let's just create some of our macros. So define U08. Actually, we could steal all these macros. They're all the same macros, right? We actually need kind of basically all the same stuff. So we can kind of just steal the macros for this section, and just copy paste, and we'll be good to go. Okay, so I need to take a quick bathroom break here. So I'll be right back. Let's put this over here. Let's say break. Let's give it like 16 minutes. Red timer. And if I'm back early, I'm just going to do some more push-ups, because I got to get those push-ups done. So we're going to set this for 16 minutes. And we're going to put it on break screen, and I will be back. So I will see you when I see you in about 16 minutes. I'll be back. see what the timer's at. 40 seconds. Alright, back in time. Ugh. Took a shower. Okay. Yeah, so let's just wait for that timer to drain down. Let's check Facebook for 20 seconds and see if I can't commit social suicide in 16 seconds. Interesting. Okay. Let's close this. Let's change our OBS to get out of break screen, and let's make sure our recording, we're good there. Let's move this over, and let us kind of figure out what the heck we're doing here. Well, first of all, if we don't want to implement this, our compiler is pretty strict, right? So we're going to have to make sure that we're going to have to do no ops. And we may have to do like a index array of the first thing or whatever, right? So this is a pointer, right? So we may have to do like this. Let's just do that just in case, because I just don't want to come back to it. And then for the length, right? So pixlen, no op. And then for these things here, byref this, byref that. And we can just say, we can just dereference these for our comparisons, right? That'll just make this easier. And then we can kind of copy this, paste this here, wrap this, right, like that. And then that looks pretty good. Let's kind of like clean this up, make it more consistent. So there, we just got these no ops for the pixel array, the pixel length, and then these variables here, right? So we just, that's just to keep the compiler silenced, right? So at vid IID 128, and the time is 8 hours, 5 minutes, and let's say 23 seconds to keep with the conspiracy, and silence the compiler warnings. Right, so silence the compiler warnings specifically for unused variables, right? So we just want to make sure that I don't want any complaints about unused variables. It is my intention not to use these variables. It's my intention just to stub this in and just never implement it at all, just to keep the symmetry between pixel array to U32 array and U32 array to pixel array. So we could make a note here that U32 array, PNG binary, PNG file binary encoded into uint32 array, right? Pix array, RGBA, 8-byte array encoding pixel data. Right, so that is what's going on here, right? So if we want to know the definition of these variables in this section, then that is kind of what we mean here, right? And we don't need to go into like all the intricacies of like length and whatnot. These are the most important variables for this section, and I'm not going to document anything else. I think that's all we need to document there, right? 8, 06, and let's just change that to 07, because it's going to be 7 by the time we're done creating this section. But yeah, we're just going to document U32 array is the actual PNG file, but we encoded it in an array of U08s, or U32, sorry. So a whole bunch of uint32s encodes a PNG file, and the pixel array is a whole bunch of U08s, right? So in order to get this working correctly, so right here, this PHEXDUM, whatever the heck here, let's take this for a second, this code here, and the signature is pretty much the same, right? So we can take this and say, this is going to be the U08 array, right? So this is U08 array. And we also need, let's change this to UO8 array as well, UO8 array. And this to UO8 array, right? UO8 array. So declare variables. Okay, let's declare these variables here. And this is kind of like the workflow here is U32 to UO8 to pixels. So step 01 get convert U32 array right. So the first step right here is, ooh, God, is this thing here, right? Now the next step, we want to, let's just take this message here. We want to convert the UO8 array to a pix array, pixels. Let's just call it RGBA, because that's what it is, and it's shorter than pixels, right? And so we can take this variable here, and then we can paste it here. Pixel component array, is this true? No, this is not true. It's true here, but this up here is PNG binary data bytes, right? That's what this is, right? And the length of set array, that's fine. And then these variables match right now. We want to change that to pixarray and pixeln, right? And we have pixarray and pixeln here. So now what we want to do here is we want to call functions, call conversion functions. Right, so we'll call the conversion functions here. So we could make a note of this, right? We could say, technically this is step 001, and then, you know, step 002 is, you know, load PNG, whatever the... Right, we don't know what that step is yet, but we know it's something like that. And then once we've called these conversion functions, we want to free intermediary memory only. So we don't want to free both of those memory allocations, right? Because one of the memory allocations we want to give back. But there's an intermediary that we do want to free. So the intermediary is... so, you know, define free memory define don't keep this memory So I would like to make a note of the fact that one piece of memory we're going to free, the other piece of memory we're going to keep, right? So within here, this binary right here, this is an intermediary piece of data. And so the intermediary memory is what we're going to free. So free this memory. And then keep this memory. And the memory we're going to keep is this, is not this thing, but it's this pixel array, right? We're going to keep the pixel array. So we're going to free the U8 array, which is intermediary, and we're going to keep this. This is the output. This is the output. This is the intermediary. I don't know if I'm spelling that correctly, but as long as I spell it consistently, I guess that's all that really matters. So once we free the intermediary memory, then we can return via output param, right? So we'll return via output param right here. And that's pretty basic, basic logic. So let's just do what we have to do for that, right? So let's take, we have ByRef, these two ByRef variables are what we're going to output here, right? So we can go over here, make some space, indent that, and just say, hey, we're gonna dereference these, and then we're gonna assign them to pixel array, and then pixelen, respectively, right? So same exact names, right? The names just match. That makes it really easy to know what the heck we're doing. And this output memory is kept, right? We don't actually free this memory. It says free this memory, whatever. And the macro ends up resulting in nothing, right? It just ignore that call, and that is intentional. It's just like a no-op kind of operation to say, hey, I recognize this memory is here, and I am intentionally not getting rid of it, right? There's a reason why I'm acknowledging, hey, I'm acknowledging you're there, and I am saying keep it, right? So it's important to document what you do, but it's also important to document what you don't do, right? So that is why we have these 2 lines of code rather than 1 line of code there. Okay, so here's where we're going to return these outputs. That's great. We also should have checked the inputs. So input checks, and we're going to do a few input checks to check the sanity of what's going in here, right? So there's a few basic input checks that we need, that we do a lot, but first of all, let's just assert that if we take a null U32 pointer is not equal to this U32 array, right? Then we also want to assert this length variable. So if we take a U32 cast of this, or actually this would be an int32 cast of 0, that should not equal that, right? Then we also want to check these pointers, right? So the ByRef variables. So we're going to take these ByRef variables, and we're going to make sure that they are not equal to null. So this would be a U32 pointer. This would be an int32 pointer. And we want to make sure that this is not null and this is not null. And then once we dereference them, we actually do want them to be null, right? So if we dereference them, we're not expecting them to point at a valid memory address at this point in time, right? So if we take this and we just say, hey, over here, dereference and dereference, and so we're going to subtract a pointer from here, subtract a pointer from here, and make sure that those equal null. And then we're just going to take some time to line up everything nice and liney-uppy, right? So let's just do this. That lines up kind of nicely. Let's do this. Let's line this up over here on this side. And then, sure, let's give that some space. And then something like that, right? So that looks nice. So I know it's kind of redundant, and I've made these checks many times, and it's like, if you make these kind of checks all the time, why not put it into an include file so you can easily reuse it? And the answer is that code is going to be read many more times than it's going to be written, so we might as well be very verbose about this, right? So we can make a note of this, so we can say, you know, @vid iid, or actually, hold on. at vid IID 0128, and the time is 8 hours, 17 minutes, and let's say 50 seconds. So why are we doing this input check? Well, first of all, we want to make sure that this array is not null. We want to make sure the length is not 0, right? Okay, now for the by reference parameters, it's a little bit more tricky. We want to make sure that the reference itself is not null. A reference cannot be null, but when we dereference these, we want them to point at addresses that are null and 0, right? So this is a null array, and this is a zeroed out length, right? So we don't want them to currently point at valid memory, right? Because we're going to reassign them using them as output parameters, right? So we don't want to accidentally overwrite valid memory, and that's why when we dereference them, we want to make sure that they actually point to null. But when we look at the top level reference, that should actually be non-null, because references can never be null. Does that make sense? I hope it makes sense. Okay, so the input checks make sense. Declaring the variables, we got step 1 and 2, right? So the intermediary U8 array and U8 length, and then the final pixel array and pixel length. And the pixel array is what is going to be outputted, right? Pixel array is outputted in orange, but the memory is for the intermediary is being freed here. So that all looks good. Now the next thing we gotta do is figure out this load PNG, whatever the heck, right? So if we try to, let's put a little breakpoint here, and then just look for where else we're using load PNG, because somewhere we're already doing this, right? So we have like load PNG decode 32, right? So load PNG decode 32 is what we're gonna need. And let's just steal this, right? Let's just steal this whole thing and then figure out how to use it, right? So let's put a breakpoint here in case we want to come back to this. But yeah, we know it's basically this function here. And we don't know exactly how we gotta make this work, but we're gonna make it work. So load PNG decode 32. So these are the output variables. We can tell by the AND symbols around them. And we see that this is the U08 buffer and the length. So let's just take this, right? So let's say the U08 array and a U08 length, right? So let's just throw that in there, and we don't really have to. Let's kind of remove the parentheses from around this. That way the output parameters are kind of like more highlighted by the parentheses, if that makes sense. And we have more outputs than I thought we were going to have, and that's because we have a width and a height. And so over here in our variable declarations, we have this pixel length, and that's not really what we want, is it? Because we don't want the length, we want a width and a height. Now, if we look at, yeah, let's just change the signature, right? Pixel array and pixel length? No way, let's not do that. That's just gonna make things harder to work with. So now that we realize that are the errors of our ways, anywhere we see pixel length as an output parameter or whatever, we're gonna duplicate this, and we're gonna say pixel length is going to be pixel width, the width in pixels, and the height in pixels. And you notice that I'm returning an int 32, but I guarantee that the intermediary is going to have to be a U32 because load PNG expects that to be unsigned. So we're going to say, hey, width and height, right? So this is going to be width, and this is going to be height right here, pixel width and pixel height. We can make these a U32, but the, yeah, so that's fine. And then now that we have this, we have to duplicate this line here. So duplicate, duplicate. And then wherever we see length, we're just going to say, hey, length, you're now width and height. And this is also width and height, right? And it's an int 32 there. Now over here, we can address that. So this out, whatever the heck, just we're going to change that and say, hey, you are pixel width and pixel height. And then this thing here is the output buffer, out character pixels, whatever. That's just going to be called pix array, right? Pix array. And the pixel array should be a U08, right? Yeah, U08 pointer pointer. That's fine. So we already have the... Ooh, hold on. Because this decode might not allocate the memory. Let's look at that for a second. So if we look at, let's just look at where else we're using load PNG decode for a second and look at the second parameter. So this thing, is this being allocated anywhere? Nope, looks like it's being zeroed out. Okay, so I think that load PNG actually will allocate that memory for us. How about this pixel array? What about that pixel array? Not allocated. Okay. Load PNG decode 32. Yeah, I'm pretty sure that load PNG decode 32 is allocating that memory. Now we can look in some other files, find in files, and just look for this for a second in the project, and look for other places where we're using this, because I know we're using it in some other stuff. So, oh, maybe not. Maybe not in as many files as I thought. Okay, yeah, so we're just going to assume, I'm pretty sure this is how it works. We'll learn pretty quickly if that's not the way this works. Actually, let's just look at the actual header file. Let's make absolutely sure. So let's go into the dependencies, look at load PNG dot, I don't know which one I want to look at. Let's just look at this first. Decode 32. Decode memory, and so here's our output. And I'm going to guess it's the header file that has the explanation, so let's open this up again and look at the header file and see what we have here. So load PNG decode 32, same as load PNG decode memory, but always decodes, right? So whatever a load PNG decode memory does. Output parameter, pointer to buffer that will contain the raw pixel data after decoding its size is width times height. So, okay, must be freed after usage with free out. So it's allocating the memory for you. You don't have to pass in allocated memory. It's going to handle that for you. And we also can see it here, char pointer pointer. Okay, that's what I expected. Okay, that's fine. But we also see that it's char pointer pointer. So pixel array right here. We're just going to it really should be char pointer pointer. It's right, so we're going to cast this as load PNG expects it, but load PNG really is being improper with this. Like, really, it should be like a uint 8 type. But so this is kind of ugly, but this is the way we're going to do it. But we're just going to wrap it in a cast right here. But we know that that's what we want, right? We want this. The width and the height we're going to get out. This is a U32 for the width and height. So you know what that means. This by ref is an int 32, right? The int 32. So here we're going to have a cast for the width and the height when we get it out. So right here, let's find the width and the height variables right here, right? And let's go, hey, take those, steal those, copy those, and say this is going to be width and height, and width and height. But we're also going to have we're going to int 32 cast these, right? So we're going to change them from signed to unsigned. The pixel array itself is already an int 08 or uint 8, so that's fine right there. Now, what else do we have here? Do we have any other stupid mistakes we're making? I think we're pretty good here. I think this looks good. Now, we do have to look at where we're calling this, right? So let's blank out this for a second, and then kind of go Control F, look for this function. It's right here. And we did pixlen, right? So pixlen, anywhere we see pix length, we want to change it to pix width and pix height. And also, because we said pixlen, and we know that really we want width and height, let's type pixlen for a second and see what we get here. So if we type this, use so really, you should be using something like this, right? Len pix, use backwards, and use this instead anyways. Wrong. Use this. Okay. What about PixWid? Do we have something for PixWid? I think that's something we've used often enough. How about WidPix? Do we have like a backwards? Yeah, that's backwards. PixHeight, same thing. PixHeight fixes it. If we do HighPix though, that's wrong. It'll tell us. But yeah, so we just made a mistake where we were trying to use this pixeln variable, and that was completely wrong. So next time we try to do something like that, we will be correct and be like, that's not what you wanted, and this is what you actually want. So now we're going to see pixeln. This number of elements here. U32 array. Width and height would be the square root of the number of elements, right? So really, so if we're really thinking, if we really want to comment that and how it relates to the number of elements, these variables, it would be the, and not even that, because number of elements is compressed data, right? So, oh, 1 PNG, it's the number of pixels, really. Okay, you know what? If we don't know what to call it, sure. These commentaries were just kind of wrong. We're just gonna throw it in there like that. Say, you know what? We don't really know what we're doing. U32 to PixArray, right? So we got the original U32 array. Its length, then the output array, the output width, the output height, right? So instead of this pixel length equaling this, we want to take pix width times pix height times 4, right? Pix width times pix height, right? Okay. And make sure that that equals what we think it's going to equal. Then the component index is going to go through each individual component index, right? So, yeah, I mean, that looks correct. Then we're going to free the actual pixel array after we've loaded it in, right? So that looks pretty good there. We're going to have to stop the stream and start a new one pretty soon because we're kind of getting to the point where we're close to 10 hours. U08 pointer, PixArray, pix width, and pix height. Does that all make sense? In every place where we are using this, does it make sense? So let's make absolutely sure that this makes sense. So this is consistent. Width and height are both pointers to integers. When we dereference, we get rid of a pointer here, and then the pointers here. And those should be equal to the zeroed out values. That looks good. So first step is we take the U32 array and we want to convert it to a U08 array, right? So we need these variables to get that. And we're going to use this helper function, which we already have, and we're going to take this data. Well, hold on, we just cut and pasted that, didn't we? we want the U32 array, right? So if we let's look at where U32 array is referenced. So U32 array and U32 length. We have an assertion here. We don't have it referenced anywhere else, right? So it's actually, we could flip this. We could flip this and say, we can take this and use it as an example variable. Example, right? So EX for example, right? Because these are examples of what those variables could be. But yeah, we're going to take the U32 array, convert it to a U8 array. So we need the array, and we need the number of elements in that array, and then we're going to unpack those uint32s into individual bytes and get the array and the length, right? So if we look at the next things that are being passed on, let's make sure that makes sense. So we got this U8 array. It's zeroed out here, right? Zeroed out here. Excellent. And then we're going to use it where? We're going to use it here in load PNG decode. And I guarantee that load PNG decode 32 expects that to be an unsigned integer. So let's look at that for a second. Yeah, so unsigned, like everything is unsigned, except for the last thing is a size t. That last thing is a size t, okay. So if we want it to work correctly, this last thing here, that's a size t. So size t. Yeah, we want to make that a size t cast. The pixel width and the pixel height, we already made them unsigned here. It's just that once we get them out, right? Once we get these out, we're going to cast them correctly when we return them, right? So right here, we don't cast this one because it's already the correct type, because we cast it here and we passed it in, which is kind of weird, but I think that should work. But yeah, we want to make these signed again, because I would like signed values for lengths, because I think I can find more problems if I do it that way. It's not like I'm not like allocating such large blocks of memory that I have to worry about integer overflow when I'm using 32 bits. So, okay, so checking over that looks pretty sane. And so we know that this function here should be the function used here, right? So there it is. There you are. So we're going to take a U32 array. We're going to convert it to a... Ooh, hold on. That kind of scared me. I think I accidentally pasted instead of highlighted, but it was the same exact thing, so it didn't overwrite. U32 array to pixel array. So this is the U32 array. The array, the length. Here's the actual pixel array, right? The pixel array has 3 constituent parts. And these are the output parameters. They're zeroed out to begin with. That looks good to me. Then we're going to do a check. We're going to make sure that this asset is always 512 by 512 pixels. Then we're going to make the max index go through all the components. The max index is inclusive. That makes sense. Component index. And we're going to copy everything into the PAINT5D memory. And then once we've copied everything in, we're going to free after copying, right? We're going to free that memory. And what about the other free? So we have one more free. So you have that intermediary memory right here, and we're going to free that here. So we free the U08 intermediary here, but this pixel array, we keep it here, and we don't free it until over here. So that all makes sense. That all looks great. So I am a little bit nervous, because I'm like, I don't know if this is going to work. But we're ready to give it a shot. We're ready to give this a compilation, see if maybe we've made some syntax errors somewhere. Byref, pixarray, whatever the heck. Assert comparison of distinct pointer types lacks a cast. So we're going to have to, I'm going to put this up here, and then I'm going to look at that code. So that is in libchan top. PHEXDUM F. So in here, on line 1135, so here's our U32, whatever the heck. And the pixel array, a pixel array is not a U32. The input is a U32. This input is a U32. That makes sense, but the pixel array itself is not a U32. So that's easy enough to fix, right? U08 and a U08. And so that's nice, because we made an explicit null pointer, if we had just used like a void pointer and a double void pointer, we would never have caught that. The compile time warnings would have not caught that. So it's nice that we have typed null pointers, because we're badass. So let's kind of look at this. Some more mistakes. So on line 1173, let's look at line 1173 now. So we're made a little bit further now. And this is going to give us a problem, isn't it? L value required as unary. So I'm going to guess that casting is it doesn't like us, right? So if we're going to if we're going to do this pixel array thing, okay, so we're going to have to do this. We're going to have to say that pix array equals U08 pointer CHR array. Right. And yeah, we're going to have to do this. This is actually pixel array. Let's just declare it here. So char pointer CHR array. And then we just say, you know, load PNG is stupid, right? So the commentary for this is load PNG is stupid, right? So we just have to do it this way, right? So we'll use this memory here like this, and then we'll cast it correctly here, right? We'll cast it correctly here. This is the memory we keep. That'll be fine. That is technically this is technically I'm pretty sure that this might be violating strict aliasing rules, because this memory, there might be special rules for char though, but we're saying that the same memory address is pointing to a U8 array, but it's also pointing to a char array. That is kind of yucky. But if we want this to compile, we're going to have to do it the way the library tells us to do it. So load PNG decode 32 from incompatible pointer type. So do we just not know what the hell we're doing? It looks like we don't know what we're doing here. Load PNG decode 32. Let's go look at that. I swear that's... Oh, unsigned. Duh. So close. So we were close. We were close. We just forgot to do that one thing. So this char array is unsigned. Right? And let's just make it over here. Let's say define UC unsigned. Let's go look at that. Let's go look at load PNG for a second. Unsigned char. Const unsigned char, really? No, it's just unsigned char right here. Unsigned char. Oh, and we have other mistakes here, like const unsigned. So, okay, one problem at a time. One problem at a time. Unsigned char, right? So UC for unsigned char. Okay. And UC is right before ERR for error. So right here, duplicate this. We're going to call this UC for unsigned char. And then we got 4, we got 5. Okay, so let's look at UC for a second. Are we using it anywhere yet? Nope, we aren't. And this char array right here is actually just gonna, we're just gonna call it UC pointer char array, right? And then if we take the address of it, it creates a UC pointer, right? Which is unsigned char pointer, which is what it expects for this parameter. For these other parameters, I am kind of worried because this UO8 array, this inputted UO8 array is probably wrong as well, right? Because load PNG for that input is expecting const unsigned char in, right? Yeah. Okay, you know what we're gonna do? We're gonna call this char in. Right, so this is char in. And then this one is gonna have to be char out, right? Or no, this one's gonna be this UO8 array here is gonna have to be ch char out, and then it's not char out. I got that reversed. This is char in. Chr in. This is char out. Char in, and this is char out. This is char out. Chr out, and this is chr in. Char out, so char out is out. This is the output parameter. This is the input parameter. In and then out. And then this PixArray is, the PixArray is whatever comes out of here, right? So chr out, right? So the output, we're going to cast it correctly, and then we have it, right? Character in is this UO8 array, but it's not just a unsigned char pointer, right? If we look at this, it is a in is const unsigned char. So const unsigned char. So let's take that, and up here we're gonna say define const unsigned char. Const unsigned char. Let's kind of line this up to make it a little bit nicer. And then 05 and 06. And then down here it's going to be directly above air. So let's duplicate this line. Const unsigned char. This is going to be 5, and this is going to be 6. Okay. So now that we have this variable type, the input, const unsigned char is just saying, hey, buddy, we're not going to edit this, right? So this is the, this right here is the UO8 array, right? So this is just kind of nonsense that we have to do it this way. And then we could make a little diagram. We could say, hey, you're going from here to here, right? Sure, we could have fun like that. Right? So the UO8 array is being converted to the pixel array, but we have this intermediary cast, right? So this is the same as this, and this is the same thing as this. So we can confirm that by making sure these colors match. Pix array, char out. So the oranges match, and the cyans match. So I'm satisfied that that is correct. So step 2 kind of sucks. It's kind of ugly. Let's see if we did that all correctly. Let's see if all those casts are correct, or if we've kind of like, you know, screwed the pooch on this. Char pointer 0. Load PNG is stupid. Well, that's because... Yes, that's fine. So we know what we did wrong there. That's kind of obvious. Load PNG is stupid, right? So we made this define here. So if we're going to do that correctly, then, you know, we got to do that, right? Okay, so let's give it another run and see if we can get this to work, bend to our will. with all this crazy casting nonsense. I think we finally might have gotten it. Okay, so I'm pretty nervous here. So I would say something didn't happen. P key for pattern. Okay, so something is not quite happening. So let's go look at that. So let's close this. Let's go look at, well, where is that pattern code happening from, right? Like, the key bindings are where that kind of happens. So if we do, like, a Control-F P5D pattern here, I think it's happening in here somewhere. Yeah, so P5D pattern. So we decided, hey, we want this to happen. And it's not happening, right? So if we swap out one for the other again, right? So we swap this out and try to run this, right? Then we're going to expect it works. But we need to kind of hone in, like, why aren't we getting the data that we think we're getting? It seems like maybe the we're not updating correctly. Something's not happening. Let's make sure that the code still works correctly if we just say P for pattern now. Yeah, so if we say P for pattern there, that looks correct. So the question is, why isn't this working? Why doesn't this work? So let's kind of look at that for a second and be like, hey, why don't you work? Why no worky? So this stuff here. So here's the component indexes. So we're copying the data. Let's just put both of them in here. For funsies, let's put both of them in here and see what happens, right? Because I'm curious to just see what happens there. Because if that... if this still gives us something blank, it says that, hey, the memory we think we have is just, it's just bogus, right? It's just zeroed out. So P for pattern. And yeah, we just get this kind of 0 thing here. So let's go, let's go O for output here. And let's just close this. And let's look at the, let's go look at the mod folder and go look at paint5d.png and see what's in there. Well, that is disappointing because the data that's in here is indeed what I expected. But yet, it's not doing anything. Huh. So what's the possibility here? Do you think the possibility is everything's, like, canceling itself out? I mean, that could be one possibility. Everything cancels itself out and nothing works, right? Because, I mean, that's what we expected. So it's getting in there somehow. But it's not, it doesn't look at all, obviously it doesn't look like what we want it to look like, right? It's just like, hey, it's just BS, right? It's like, what the heck, man? That sucks. So, the initial assumption here is that the rendering code is wrong, right? That, if we say P for pattern, and this is what we get, right? To me, that says the rendering code is wrong. But what it could be doing is it's looking at RGBA. Ooh, RGBA. You know what that means? It's looking at if we think about the diagram, yeah, actually that makes sense. The reason why it doesn't look like anything is because we gotta just change the hard-coded asset. So well, hold on. Yeah, okay, yeah, that makes sense. Okay, I see what's happening. Okay, so what we gotta do here is it's actually working as expected. We just need to fix up some things here. So first of all, let's go into where the PAINT5D thing is happening here. And let's comment this out. Everything, I know exactly what's happening. We're gonna fix it. So we gotta go into the assets folder for a second. And for this default data here, let's open up this PNG file. Actually, no, let's open it up in, gotta open it with paint.net here. And wherever we see black, which stands for nothingness, we want to have actual nothingness. Because the first offset that is active is going to be in the alpha channel, RGBA, right? The least significant bits mapped to the lower offsets. If we look at this, the least significant bits, the alpha bits, all of the alpha bits are 1, right? Because everything here is 1, right? Does that make sense? Everything here is 1 in terms of alpha, because the alpha channel is 255 for every single pixel. So if we want this to give us something meaningful, we're going to have to turn on global selection here, global. We're going to have to make sure that pixelated selection quality, and then we're going to have to just hit delete. And oh boy, does that make it kind of like hard to look at, but that's what we need. So we'll save this. Okay, now let's make sure when we look at it, it just looks correct. So it almost looks like the same thing, but that background now has actually been, it's been nuked, right? So now, if we build our system, we're going to encode a different asset, right? Where the build system will encode that new asset, and I'm worried that this might bloat our code base a little bit, but if we have to, we'll delete the commit history if we really have to, because the videos are actually what really matters. Okay, moment of truth. Holy fucking shit. No fucking way. Oh boy. Ooh. Oh yeah. Oh yeah. Oh man, this is gonna get, oh, this is gonna be badass, man. This is gonna be really badass. Yeah. Yeah. Okay, yeah. Awesome. So, yeah, this is promising. Like, I've had this idea for like 8 years, but, I think that this is... Oh, I finally got to, where I wanted to be. Hey, El Papa Pig, yeah, so let me explain this for you. There's still a long way to go for this rendering engine, but I just got to a breakthrough here. So let's take a look at this for a second, right? So let's take a look at this. So this stuff here that we're looking at, I'm going to have to Control-C on this. So I still have some window code I need to fix, but we'll fix that when we fix it. That is rendering this data set here, right? So this is the top left tile over here, the top right tile, the bottom left tile, in the bottom right tile. Now, there's some things I still need to fix with the rendering, but I mean that looks pretty badass. That's yeah. So let me just compile that one more time, because I want to take a screenshot and show my artist that for a second, because we're getting somewhere. We're getting to a very cool, like, so we're talking auto tiles with multiple layers, blending modes, and fractal graphics. We're talking about some pretty heavy-duty auto tiles. So yeah, I just want to take a snippet of this for my artist really quick, so I can show them, hey, look, it's been months, but I finally made a little bit of progress. So I want to crop one of these, if I can do this. New, yeah, ooh, this is looking good. So I'm gonna save this. I'm gonna crop this up in like a notepad, in what do you call it? What do you call that thing? Paint.net. So let me close this. But I still need to fix my window code, because my window keeps on crashing for some reason. I don't know why. I need to fix that. But yeah, let me, so this is for Josh crop or something like that. Let's go open up paint.net for a second. And where's my thing here? But yeah, this is getting cool. So I'll probably like let everybody know that I have something interesting. Like I'll message everyone who are my followers and set a, like, maybe we'll do like maybe for like Sunday is my no work day, so maybe we could just do a little short kind of like tech demo on Sunday of like where I'm at, since we have something visually interesting, because I know it's not interesting to watch like everything I'm coding. So there's just little gems here and there. So let's see, what did I call this? Crop tile for Josh. We're gonna edit this up a bit here. Yeah, because we can see all of that intricate detail blended together very nicely. Yeah, we're getting something here. We're getting stuff is getting pretty awesome. So let's just kind of neaten this up a little bit, and then send it off on Discord. So where are my tools here? Let's kind of zoom in here, and let's take the exact tile. So this is the exact tile here, and this is just what we're actually creating here is not the final tile design either. This is just the base tile. This is just the you could think of this tile here as the atoms of the material. So we're gonna be able to have like this fractal rendering quality and be able to zoom in and zoom in, zoom in, zoom in. And this is the final terminal tile. So this is like, once you've zoomed in so far that you can't zoom in anymore, this is kind of what you're gonna see, something like this, or other designs depending on what my artist makes. We're gonna have to tweak how this engine kind of works here, but let's save this, and we're gonna just send it off on Discord. File, save as. I'm gonna name that send to Discord. Okay. And close this. And let's see. I'm gonna go on Discord really quick, send that off. So Josh Chat is my shortcut for Discord, because I only really talk to one person. Actually, I talked to 2 different people on Discord. Okay, maybe some more. Maybe like 4 people in total. But really, Discord is mainly for Josh, my artist. That's the only reason I have Discord. There's other people who talk to me on Discord, but the real reason I have Discord is to show my artist things. So I'm going to find that in my thing. So desktop, delete me, send to Discord is what I call that image. I thought I'd call it send to Discord. Let's just arrange our sort by date. That'll make it easy to find, hopefully. Come on, where are you? Come on, I just like send. Where are? Oh, there it is. Send a Discord. Bulgogi is fine, yeah. Bulgogi, yeah. So that AAC 2020 folder. I'm on Discord. The Discord is on my other screen because Discord is on a different screen just because I never know what's gonna pop up on Discord. Like, I don't want to like accidentally dox my friends or something, you know. So let's see, in our lib folder, I'm gonna take out my asset. This is the raw data. Raw data. Okay, yeah, so it doesn't look like anything's important here, so I can just show you what I'm showing Josh. So, right, I'm just showing them that, hey, I got this image, and this image is generated from this data here. It's actually generated from one of these quadrants. It's not using all of this data, it's actually using one of the quadrants. So, one quadrant of the big bitmap is used to generate the colored image you see above. Still need to get editing, get in-game editing tools working so you can draw stuff yourself. Right now, the only way to get data into this engine is to painstakingly create these crazy 512 by 512 bitmaps. So next step is to create, to get the editing tools working. A lot of that groundwork is already done. No clue when I'll have that for you, but hoping the frequency of interesting visual progress will start to become more frequent, intervals, yeah. So yeah, so right now it's kind of programmery art, but once I have the tools ready, I think you'll appreciate how it works. I'm designing it to be used in a watercolor front to back way of drawing slash creating. We can change that around once we get it in your hands, because really in the end it's whatever works best for you. So how I design it for this first iteration is just hypothetically what I think will work for you, but really we won't know if it works for you until we get it in your hands. Okay, so anyways, I just wanted to show them that. Now I'm going to put this up somewhere on a different screen. And, this is insane. Yeah, I thank you, El Papa Pig. So, yeah, I'm hoping that we're going to get somewhere. Like, I am kind of scared that, like, I'm putting this rendering tech out on, like, a public stream, but here's my hope. My hope is that, I'm not going to get a lot of followers until it starts to get, like, really cool looking. And by the time it gets really cool looking, anyone who wants to copy me will be literally years behind, right? So, like, Minecraft, like, there's Minecraft clones, but Minecraft is #1 because they did it first. So that's kind of the strategy I'm going with here. I'm going to hope that I'm doing this first, and so I don't have to worry about anyone copying me. But yeah, it's good to see you, El Papa Pig. I know I haven't seen you in a while. But like I said, I know what I'm doing right now isn't too interesting. So it's like, you know, popping in every once in a while to see. You kind of came in at the right time. But I am going to message everyone now that I have something interesting. And just say that, you know, Saturday sometime will be like a tech demo day. We'll probably do it like after Hirosa streams, right? So I know that Hirosa usually does things from like 1. They end their streams somewhere around 1 p.m. So like we'll say like 1 p.m. to 2 p.m. or maybe 1 p.m. to 3 p.m. will be like tech demos, and I'll just kind of repeat myself for people, you know. Yeah. So, anyways, so Josh is excited, so that's cool. So hopefully I can, it'll get more and more interested as time goes by with this. But what do I got to do now? Because I have like all this stuff here. The next goal is to try to get some editing tools in. Now, we're at 9 hours and 10 minutes, so we cannot upload this to YouTube if we get to 10 hours. And we just kind of found a really good stopping point, right? Because we got this, like, good-looking stuff up. So what we're going to do here is we're going to commit this to Kanji Coder as well as my private repo. So we're going to publicly push this. So if you want to actually take a look at this code right now as it is, you can take a look at it, right? Because I'm about to push it up. So git status. And we're going to just add everything. So we did a whole bunch of changes. We're just going to go git add dot, git commit dash am. We got some fancy press 1, then press P. So you're going to have to know what keys to press if you actually compile this. So in the commit message, I'm just going to say, for fancy graphics, press 1, then press P. That's going to be my commit message. Right, so I don't abide by that rule of a commit message should always be, always commit why you did what you did. I think that's stupid. I think the most important commit message now is to give you some type of instruction about what to do if you want to, like, see the cool stuff that I just did. So for fancy graphics, press 1, then press P. If you abide by those instructions, you're going to see that fancy graphics. So git status, or that's not correct. Git status, git push GitHub master, and then we're going to also git push to Kanji Coder as well. So if you want to take a look at this, in the orange text in the bottom right of my screen is my repo. So if you want to actually take a look at this, it's for Windows. So if you're on Linux, I'm sorry. Git push Kanji Coder master. So I push that up to Kanji Coder, and then I'm going to stop now because food was ordered, and I can take some time to kind of think about what to do next, right? So I've gotten to a good point where I got to think about, okay, what's next? I know it's probably going to be tweaking the renderer and adding the zooming controls is probably the next thing. And then once we get the zooming in and out controls and some of the basic rendering, editing controls, then we're going to make the palette, we're going to make the, like, the pixel setting code, like clicking and dragging colors and whatnot. Yeah. But yeah, so I don't know when I'm going to see you, but it's going to be like probably max 2 hours. Yeah, max 2 hours, yeah. Yeah, no problem. It is gonna get more interesting. It's gonna get more interesting as the weeks go by. But anytime I have some type of anytime I have a visually interesting breakthrough, I don't have many followers, right? So I can take some time to message like every single follower. And in fact, you know what I'm gonna do? I'm gonna keep I'm gonna just stop the stream now. But I'm going to just take some time right now to message everyone on my followers list and be like, hey, I made a little breakthrough. I'm going to do the technical demo on Sunday or whatever. But I'll see you, El Papa Pig. I'm going to end the stream now. And so this has been, let's go to the title screen, PNG Hex Dumper Part 60 of PAINT5D Sprint. And yeah, I'm out of here.